and now travel beyond Earth once again and settle into another 10 plus continuous hours of cosmic mysteries. This stellar compilation explores the profound enigmas of the universe, from the Andromeda galaxy to explosive supernovas, from the life cycles of stars to the secrets hidden in our night sky. Tune into the celestial unknown, let the astronomical mysteries wash over you, and sleep soundly through the night. Inspired by the unsolved puzzles of astrophysics and the quiet vastness of space. These videos provide a unique, deep auditory background for the perfect night's rest, and will keep drifting, floating together through the mysteries. 100 Andromeda mysteries, looping softly, endlessly through the night. Tonight we'll drift through the moment Andromeda first emerged from cosmic darkness, the silent collision already unfolding between Andromeda and the Milky Way, the ancient light from Andromeda just now reaching your eyes. There's nothing you need to do now, just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper, into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into Andromeda, 2.5 million light years away. A galaxy spirals, slowly, endlessly, in the constellation that bears her name, Andromeda, the chained princess of ancient myth, bound to the rocks, waiting for Perseus. The Greeks looked up and saw her story written in stars, but they saw something else too, a small, faint smudge of light. They called it the little cloud, not knowing, not understanding that this tiny patch of softness, this whisper in the dark, was an entire galaxy, 1 trillion suns spinning together, drifting through the void. Let your breath slow now, in and out, in and out. Feel yourself sinking deeper into the darkness, deeper into the quiet, just like Andromeda sinks into the night sky, appearing, disappearing with the seasons. The Persian astronomer Al-Sufi, in the year 964, wrote of this celestial smudge, describing it in his book of fixed stars, calling it a little cloud, never imagining its true nature for centuries, millennia. Humans looked at Andromeda and saw only a fuzzy star, a cosmic question mark, hanging in the autumn sky, your eyelids growing heavier, heavier, each blink lasting longer, the room around you fading, melting into shadow. When you look at Andromeda on a dark night, away from city lights, you're seeing photons, tiny messengers of light that left that galaxy 2.5 million years ago, when our ancestors were just learning to walk upright. Australopithecus, moving across African plains, while light from 1 trillion distant suns began its journey across the emptiness, across the dark, traveling, traveling, traveling for millions of years, just to touch your eyes tonight That ancient light arrives tonight like the gentlest hello from a stranger who has always known you. Thump, thump, your heart beating slower now, matching the pulse of deep space, where time moves differently, where 1,000,000 years is just a moment, just a breath. Your heartbeat and the cosmos find the same unhurried rhythm. Andromeda is the most distant object you can see with your unaided eyes. No telescope needed, no instrument, just your eyes, the darkness, and 2.5 million years collapsing into a single moment of soft, gentle light. It appears as an oval smudge stretched across the sky because we see it at an angle, tilted, inclined 77 degrees from our line of sight, like a dinner plate held up, turning slowly in the dark. In that faint smudge, 2.5 million years fold quietly into the palm of your gaze. Let your jaw release, unclenching, softening, your tongue resting heavy in your mouth. Nothing to say, nowhere to go, just drifting with Andromeda through the night. The jaw's release is the first small surrender to the night's vast permission. The Andromeda galaxy spans roughly 220,000 light-years across, making it larger than our Milky Way, which stretches only about 100,000 light-years. Andromeda is the big sister, the elder twin, holding more stars, more light, more mass, drawing everything near it, closer, closer, with invisible threads of gravity. Size becomes irrelevant when gravity weaves the same quiet thread through both, your shoulders melting down into the bed, down into the earth, down, heavy, so heavy, like you're made of stardust, which you are. Carbon, oxygen, iron, all forged in stars like those in Andromeda, billions of years ago. The heaviness is stardust remembering its origin and settling back into rest. Inside Andromeda, 1 trillion stars burn, some young and blue and fierce, others old and red and dying. The galaxy's spiral arms, elegant curves of light, wound tight around a bright central bulge, where stars crowd together, ancient and golden, born when the universe was young, 10 billion years ago, or more, before Earth existed, before the sun, before anything you've ever known. 1 trillion quiet fires burn together, each one older than memory, yet still alive in this moment. Breathe in, slowly, deeply. Breathe out, longer, slower. Feel the air moving through you, carrying you down into sleep, into the dark, into the infinite. Each breath is a small voyage across the same darkness the photons crossed. At Andromeda's heart, buried in that dense core, something waits, a supermassive black hole, weighing as much as 100 million suns, sitting silent, patient at the center of everything, pulling, always pulling, space bending around it, time slowing, light circling, unable to escape, just darkness, pure and absolute, at the very heart of all that light. Even the brightest galaxy cradles a perfect, patient silence at its core, your thoughts beginning to scatter, to dissolve, words becoming sounds, sounds becoming silence, nothing to hold on to, nothing to remember, just this moment, this breath, this soft, eternal. Now, thoughts scatter like stars, no longer needing constellations to belong. But Andromeda holds a mystery, a puzzle astronomers noticed decades ago. The galaxy seems to have two bright centers, two nuclei, where there should be one, like a double heartbeat. Thump, 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 pulsing in the core. Scientists believe this isn't two black holes, but rather the result of past collisions, past mergers, where Andromeda consumed another galaxy long ago, and the remnants still glow, still circle, forever marked by that ancient, violent, beautiful dance. The double pulse is the galaxy's way of remembering love it once devoured. The mattress holds you completely. You're sinking into it, becoming part of it. Your body heavy, so heavy. Arms like lead, legs like stone, fingers barely moving, barely there, fading into the soft embrace of gravity, of darkness, of sleep. The mattress becomes the gravity well into which everything willingly falls. Andromeda didn't always look like this. 11 billion years ago, in the universe's youth, clouds of hydrogen collapsed, pulling together under their own weight, forming stars, forming clusters, forming the first, faint ghost of what would become this mighty spiral over billions of years. Andromeda grew, pulling in smaller galaxies, devouring them, absorbing their stars, their gas, their light, growing larger, until it became the giant we see today. Growth is the galaxy's long, slow act of gathering forgotten pieces into one. Let your eyes close, if they haven't already. No need to see anymore, no need to watch. Just listen, just feel, just drift. Closing the eyes opens the door to the darkness that has always been watching. The evidence of Andromeda's cannibalistic past is written in stellar streams, long ribbons of stars stretched across the galaxy's halo like scars. These streams are the ghosts of smaller galaxies, torn apart by Andromeda's gravity, their stars scattered, strewn across space, forming faint loops and arcs, visible only in the deepest images, the longest exposures, whispers of violence, softened by time, by distance, by the gentle, endless turning of space. Scars are the galaxy's poetry, written in light too faint for most eyes. Thump, thump, your heart beats so slow now, so quiet, barely there, like you're floating and in the void, in the dark, between stars, between worlds, weightless, formless, pure awareness, dissolving. The slowing beat is the heart learning it no longer needs to hurry. The giant stellar stream, one of Andromeda's most prominent scars, stretches across the galaxy like a river of ancient suns. These stars, ripped from a dwarf galaxy, perhaps 1 billion years ago, now orbit Andromeda, forever, trapped, like debris circling a drain, slowly, spiraling in over millions, billions of years. The stream flows without hurry, carrying the memory of what was lost into what will always be. Your breathing so slow, so shallow, each breath lasting longer. The pause between deeper. You're not sure if you're breathing or being breathed by the universe, by the night, by the soft, persistent pull of sleep. Breath becomes something the night does through you, gentle and unasked. Andromeda has its own family, its own companions, at least 14 satellite galaxies, small dwarf galaxies, orbit around it, held by gravity, dancing in formation. M32, M110, and others too faint, too distant to have familiar names. These satellites are Andromeda's children, or its prisoners, depending on how you see it. Bound forever, to circle, to drift, never escaping, never alone. Companions circle not out of captivity, but out of the same quiet belonging. Let go, let everything go. Your name, your day, your worries, your plans, all of it dissolving, melting like snow, like morning mist, like stars, fading in the growing light of dawn. But there is no dawn here, only night, soft, eternal, night. Letting go is the night saying you were never holding anything that wasn't already safe. In 1924, a young astronomer named Edwin Hubble studied Andromeda through the Great Telescope at Mount Wilson. He found variable stars, Cepheid variables, stars that pulse, brightening and dimming, with a rhythm linked to their true brightness. By measuring their apparent brightness and comparing it to their actual brightness, Hubble calculated distance and realized Andromeda was far, too far, to be part of our Milky Way. It was another galaxy entirely, an island universe, separate, distant, vast. One man's quiet measurement opened the universe's door to infinity. This discovery, quiet, revolutionary, changed everything. Suddenly the universe, our universe, became infinite, filled with galaxies, billions of them, trillions of them, each containing billions of stars. Andromeda was the key, the proof that we live in an ocean, not a pond, in an endlessness that dwarfs all human knowing. The pond became an ocean the moment someone dared to measure its depth. Your thoughts like clouds now, shapeless, drifting, no edges, no boundaries, just softness, melting into more softness, sky into sky, star into star, you into universe, universe into you. Clouds have no need for edges when the sky's already complete. The spiral arms of Andromeda, those elegant curves, are not solid structures. They're density waves, regions where stars and gas bunch together like traffic slowing on a cosmic highway. As material enters the arm, it compresses, triggering star formation. New suns ignite, blue and bright and brief, lighting the spiral before drifting away. The arms themselves remain, but the stars within them come and go like water flowing through a river's shape. The arms stand still while everything within them flows onward, beautiful and transient, heavier, heavier. Your whole body sinking through the bed, through the floor, through the earth, falling, but safely, gently, like floating down, through warm water, through darkness, through space itself, down and down and down. Falling is only frightening until it becomes floating in the same direction as everything else. Within those spiral arms, vast clouds of gas and dust collapse, forming stellar nurseries, regions where hundreds, thousands of stars are being born right now. Blue giants, red dwarfs, stars like our sun, all igniting, all beginning their long, slow burn. Some of these stars forming in Andromeda tonight will outlive our sun, will shine long after Earth is gone, after the Milky Way merges with Andromeda, after everything we know has changed, transformed, become something new. New stars ignite tonight in places we will never touch, yet their light will carry on without us. But not all of Andromeda is creating stars. Much of it is quiet now. The central bulge, that bright golden core, is mostly filled with old stars, red giants, ancient suns, born billions of years ago, slowly dying. They've exhausted their fuel, expanded, cooled. Their light is soft, orange, red, like embers, like sunset, eternal, fading. The quiet core glows with the patience of things that have already burned their brightest. Your consciousness fragmenting, pieces floating away, thoughts becoming dreams, dreams becoming shadows. You're not sure what's real anymore, not sure if you're here or there or nowhere, just drifting in the space between waking and sleep. Fragmentation is the gentle way the self remembers it was never truly separate. Andromeda's disk is warped, bent, twisted. Astronomers aren't certain why. Perhaps it's the gravitational tug of its satellite galaxies, or the memory of past collisions, past mergers. The galaxy isn't perfectly flat, isn't perfectly symmetrical. It has scars, imperfections. Like everything, it's been shaped by its history, by violence, by time, by the slow, relentless pull of gravity. Warps and bends are the galaxy's way of wearing its long story with grace. Dark lanes of dust run through Andromeda's spiral arms, visible as dark shadows against the background glow. These dust lanes, made of carbon, silicates, ice, block the light of stars behind them, creating contrast, creating structure, like the dark spaces between words, between thoughts, between heartbeats, necessary, essential, defining the light by their absence. The shadows are what give the stars their quiet, perfect shape. Thump, thump, so slow, so faint. You might be asleep already. You're not sure. The boundary, blurring, disappearing. There is no boundary. There never was. Just consciousness, flowing, shifting, like water, like light, like Andromeda, slowly turning in the dark. In that blur, everything finally feels allowed to simply be. Globular clusters, dense spheres of ancient stars, orbit Andromeda like bees around a hive, roughly 500 of them. Each cluster contains hundreds of thousands of stars, packed together, their light blending creating golden orbs hanging in space. Some of these clusters are among the oldest objects in the universe, 13 billion years old, formed when the cosmos was young, when galaxies were just beginning to take shape. Each golden orb is a time capsule, still glowing with the universe's youngest memories. Your body completely still now, barely breathing, barely there, just a whisper of warmth in the dark, just a flicker of awareness, watching, listening to the soft voice telling you about stars, about time, about Andromeda, drifting, always drifting closer. Stillness is the body's way of saying it has nothing left to prove. The halo of Andromeda, a vast spherical region extending far beyond the visible disk, contains the oldest stars, the faintest stars, scattered sparsely across hundreds of thousands of light years. This halo is mostly dark matter, invisible, undetectable, except through its gravitational effects. Dark matter outweighs all the stars, all the gaze, all the light, by a factor of 10 or more. It's the skeleton, the scaffolding upon which all galaxies are built. Invisible hands hold the visible world in the gentlest, strongest grip. Scientists estimate Andromeda's total mass, including dark matter, at about 1.5 trillion times the mass of our Sun, but most of that mass is invisible, unknowable, felt only through the way it bends space, the way it pulls on light, on stars, on other galaxies. A ghost, holding everything together, silent, patient, eternal. The unseen is what makes the seen possible, quietly and without fanfare. Let yourself go completely now. Surrender to the darkness, to the weight, to the pull of sleep. Nothing matters. Nothing needs to happen. You're already exactly where you need to be. Already home, already safe, already drifting into the deep, the soft, the endless. Surrender is the moment home recognizes you've returned. Andromeda rotates, its outer regions spinning at about 250 kilometers per second. Stars orbiting the galactic center, taking hundreds of millions of years to complete one circuit. From the perspective of those stars, of planets, if they exist, circling those stars, Andromeda's center barely moves. The galaxy is eternal, unchanging, a fixed point in an infinite, turning, dark. To the stars, one full turn feels like standing still forever. But Andromeda isn't static, isn't frozen. X-ray observations reveal hot gas, superheated to millions of degrees, glowing in the core, supernova remnants. The afterglows of exploded stars shine in X-rays, marking places where massive suns died violently, scattering their atoms, their carbon, their oxygen, their iron, back into space to form new stars, new planets, perhaps new life. Every violent end quietly seeds the next gentle beginning. Your mind empty now, no thoughts, no words, just the voice washing over you, through you, like waves on an endless shore. Each word a ripple, pulling you deeper, deeper into the ocean of sleep. The voice becomes the water, and you become the shore that needs no name. Planetary nebulae, scattered throughout Andromeda, glow softly. These are the outer layers of dying star, puffed away, illuminated by the hot white dwarf core left behind. They drift through space, expanding, fading over thousands of years, beautiful, ephemeral, like breath, visible in cold air, then gone. But the atoms remain, recycled, reused, forever. Even fading beauty leaves its quiet gift behind. Andromeda's chemical composition tells a story. The oldest stars, formed from nearly pure hydrogen and helium, the primordial elements from the Big Bang. But as generations of stars lived and died, they created heavier elements: carbon, nitrogen, oxygen, silicon, iron, gold. Each generation slightly richer in metals, as astronomers call them. The metallicity, a measure of this enrichment, increases closer to the center, where stars have formed and died and formed again for billions of years. The galaxy remembers every life it has lived, written in the atoms of its heart, sinking, sinking, like snow falling on a quiet night, slow, silent, inevitable. You're falling into sleep, into the dark, into Andromeda. No difference anymore between you and the galaxy, between inside and outside. All boundaries dissolving, melting away into the soft, warm, eternal. Falling is just another way of arriving. Compared to the Triangulum galaxy, Andromeda's smaller neighbor, Andromeda is massive, ancient, dominant, Triangulum. M33 contains perhaps 40 billion stars, modest compared to Andromeda's trillion. The three galaxies, Andromeda, the Milky Way, and Triangulum, form the heart of the local group. A small cluster of galaxies are bound by gravity, drifting together through the expanding universe. In this small family, size matters less than the shared gentle orbit. The local group contains more than 50 galaxies, most of them dwarfs, small, faint. But Andromeda rules this region, the largest, the brightest, the most massive. Its gravity shapes the orbits, the fates of everything nearby. We orbit it, in a sense, or rather, we're falling toward each other on a collision course that will take billions of years to complete. Even rulers fall toward what they hold close. Thump, thump. Perhaps your heart has stopped. Perhaps you're dreaming already. Perhaps you've become one with Andromeda, a star in its spiral arms, burning quietly, patiently, for billions of years, waiting for the moment when two galaxies become one. In that waiting, every quiet burn becomes eternal. Andromeda moves toward us at about 110 kilometers per second, approaching, closing the distance. This was discovered through Doppler shift, this stretching and compressing of light waves. Blue shifted light means motion toward, and Andromeda's light is blue shifted. Unmistakably, it's coming, inevitable, beautiful, a collision written in gravity, in motion, in the mathematics of space and time. The blue shift is the universe whispering closer, closer, closer. But don't worry, don't fear. This collision won't happen for 4 billion years, long after you, long after humanity, perhaps long after the sun has swelled into a red giant, consuming Earth. The stars won't actually collide. Space is too vast, too empty. They'll pass through each other like ghosts, like dreams. The galaxies will merge, their shapes dissolving, reforming into something new, something neither, but both. Time stretches the fear until only beauty remains, your breath barely moving now. In, out, so slow. You might have already stopped, crossed over, into sleep. But the voice continues, soft, persistent, telling you about light, about time, about Andromeda. Even when breath pauses, the story keeps breathing for you. The ancient collision already unfolding across timescales. We can barely comprehend. It began long before we existed and will continue long after we are gone. When the merger begins, truly begins, in about 4 billion years, the night sky will transform, Andromeda will grow, night by night, year by year, millennium by millennium, from a faint smudge to a bright oval, to a spectacular spiral, filling half the sky, its spiral arms glowing, magnificent, close enough to see individual star clouds, individual bright regions, the most beautiful, terrifying, awe-inspiring sight any world could witness. That slow unveiling will be the sky's most patient love letter. Let your whole being soften, release, melt into the bed, into the darkness, your awareness fading like stars at dawn, still there but invisible, absorbed into something larger, something infinite, just drifting with Andromeda across the void. Melting feels like coming home to the place you never left. During the collision, stars will rarely hit stars. Space is too empty. The distance between stars too vast. Our sun could pass through Andromeda's densest regions and never come close to another star. The galaxies are mostly emptiness, darkness, with tiny points of light scattered like dust motes in a cathedral. But gravity will tug, will pull, will fling stars into new orbits. Some will be ejected, thrown into intergalactic space, lonely, exiled, forever. Others will spiral inward toward the merged core, where two supermassive black holes will orbit, merge, releasing energy, gravitational waves rippling through space-time like dropping a stone in a still, dark pond. Even in cosmic violence, most of the space remains gently untouched. Your eyelids so heavy, sealed. You couldn't open them, even if you wanted. But you don't want. You want only this darkness, this softness, this voice guiding you through the mysteries, the slow science of Andromeda. The weight of eyelids is the final permission to rest. The merger will take billions of years to complete. The galaxies will pass through each other, swing back, pass through again and again, each passage more chaotic, more tangled, until finally they settle into a new form, an elliptical galaxy bloated, featureless, the spiral arms gone, dissolved, the structure lost. What remains will be called Milkomeda, or perhaps Milkdromeda, a hybrid, a child of two ancient parents, red and orange stars, old and dying, filling the new galaxy. Few new stars forming, the gas mostly expelled or consumed in brief, violent bursts of star formation triggered by the collision. Birth and death entwined so slowly that the new galaxy simply breathes into being. But our sun, if it still exists, will likely survive. Flung into a new orbit, perhaps farther from the galactic center, perhaps closer, Earth, if it somehow survived, the sun's red giant phase, would see a transformed sky. No spiral arms, no Milky Way band, just a diffuse glow of countless stars scattered everywhere. The night sky would be brighter, but emptier, somehow less structured, less familiar. A universe transformed by time, by gravity, by the slow, inevitable dance of galaxies. Change arrives not with thunder, but with the quiet rearrangement of light. Thump, thump. Or perhaps that's not your heartbeat anymore. Perhaps it's the pulse of the cosmos, the rhythm of expansion, of collapse, of stars forming and dying, of galaxies merging. The universal heartbeat, slow, eternal, thump, thump, thump. Every thump echoes the same patient rhythm that carries everything. Let your last thoughts drift away like leaves on a stream. Thoughts about tomorrow, about yesterday, about anything. Gone, floating, away, into the dark. There is only now, only this moment, this breath, this word, dissolving into silence. Thoughts leave like guests who finally know it's time to go. Andromeda formed roughly 10 billion years ago in the early universe, when galaxies were just beginning to take their modern shapes. Clouds of primordial gas collapsed under gravity, forming the first stars. These stars, massive, blue, short-lived, exploded quickly, enriching the gas with heavier elements. The next generation of stars formed from this enriched material, and the next, and the next. Each generation slightly different, slightly richer, building the galaxy star by star over billions of years. Each star is a chapter written in fire and patience. Early in its history, Andromeda likely collided with other galaxies, smaller ones, absorbing them, growing. The evidence remains in stellar streams, in the warped disk, in chemical gradients that mark where separate galaxies once existed before becoming one. Everything in Andromeda has a history, a story, a formation, collision, transformation. Nothing is pristine. Everything is recycled, reused, reformed, like consciousness itself, flowing, changing, never the same, from moment to moment. Every scar is proof of a life fully lived. Your body doesn't exist anymore. Not really. It's just a sensation, a vague warmth in the darkness. No arms, no legs, no face, just awareness, floating, pure, unmoored, drifting through space, through time, through the soft, endless. Now, without form, you become the space that holds everything. Andromeda has experienced quiet periods and active periods, times when star formation exploded, filling the galaxy with young blue stars, and times when it nearly stopped, the galaxy breathing in and out across billions of years. Currently, Andromeda is relatively quiet, forming fewer stars than galaxies like the Milky Way. Most of its gas has been consumed or blown away. What remains burns slowly, patiently. The galaxy, in late middle age, past its wild youth, settling into slower, gentler rhythms. Maturity is the galaxy learning to rest in its own light. Compared to some spiral galaxies, Andromeda is unusual. Its star formation is suppressed, its gas content lower than expected. Astronomers call this the missing gas mystery. Where did it go? Was it blown away by supernovae, by the central black hole, or consumed in past bursts of star formation? The answer remains uncertain, a puzzle drifting through the star. Some questions are beautiful simply because they linger, sinking deeper now, past sleep, past dreams, into something formless, nameless. The place where awareness goes when it lets go completely, when it surrenders to the dark, to the void, to the eternal. Surrender is the moment the wave forgets it was ever separate from the ocean. In infrared light, Andromeda transforms. The dust lanes that appear dark in visible light glow brightly, heated by young stars, revealing the spiral structure in stunning detail. In ultraviolet, the youngest stars shine, blue and fierce, marking regions of active star formation. In radio waves, vast clouds of cold hydrogen become visible, the raw material for future stars. Each wavelength reveals a different Andromeda, a different truth, like looking at something from different angles, seeing layers, depths, complexities invisible to a single perspective. Every lens uncovers a hidden tenderness in the same familiar face. X-ray telescopes reveal the hottest phenomena, supernova remnants, glowing shells of gas, heated to millions of degrees, X-ray binaries, where a normal star feeds matter onto a neutron star or black hole. The matter spiraling inward, heating, emitting X-rays before vanishing forever into darkness. And the central supermassive black hole, surprisingly quiet, dormant, not feeding, not active, just waiting, patient at the heart of everything. Even the hungriest silence knows how to wait. Your awareness, barely a whisper now, a ghost, haunting the edges of consciousness, not quite awake, not quite asleep, somewhere in between, in the soft grey space where boundaries dissolve. In the grey borderland, all opposites hold hands. Andromeda's stellar density is highest at the core, where stars crowd together, a few light years apart. Imagine living on a planet in that region. The night sky would blaze with stars, thousands visible no darkness between them. The sky, a solid sheet of light. But farther out, in the spiral arms, where our sun would orbit, if it orbited Andromeda, stars are scattered, sparse, light years, tens of light years apart. The sky, mostly dark, mostly empty, like our own familiar night. Crowded or sparse, every sky still sings the same quiet song. The quiet core, despite its brightness, is relatively inactive. Old stars, red giants, moving in stable orbits, little gas, little dust, few new stars forming. It's a retirement home for ancient suns, a place of stillness, patience, slow, inevitable decline. Age brings not diminishment, but a deeper, softer glow. Andromeda's central black hole, weighing roughly 100 million solar masses, is smaller than expected for a galaxy so large. The Milky Way's black hole, Sagittarius a star, weighs only 4 million solar masses, but other galaxies, comparable to Andromeda, often have billion solar mass black holes at their hearts. Why is Andromeda's relatively modest? Astronomers don't know. Perhaps it hasn't fed in a long time. Perhaps it expelled more than it consumed. Another mystery, another question, drifting, unanswered, through the dark. Even giants can choose quiet restraint. Thump, thump. The sound might be your heartbeat, or might be something else. The rhythm of stars pulsing, the beat of galaxies rotating, the pulse of the universe expanding, contracting in cycles too vast to comprehend. It doesn't matter. Let it wash over you, through you. Let it carry you down, down, into the deep. The rhythm continues whether you hear it or become it. When you photograph Andromeda with a long exposure, a camera mounted on a telescope tracking the stars for minutes, hours, details emerge, invisible to the eye, spiral arms, traced in blue and pink, star-forming regions, glowing red, dust lanes, dark and intricate. The galaxy's true size becomes apparent, stretching across 3 degrees of sky, 6 times wider than the full moon, but most of it too faint to see, without technology, without time, without patience. Time and patience are the only lenses that reveal what the eye alone cannot hold. Amateur astronomers with backyard telescopes can see Andromeda's core, its central bulge, bright and oval, in dark skies. Hints of spiral structure emerge in photographs. Even modest equipment can capture astonishing detail. The galaxy is close, bright, accessible, a favorite target for anyone looking up, wondering what lies beyond. Wonder needs no grand instrument, just dark skies and open eyes. Ancient humans may have seen Andromeda differently than we do, in truly dark skies, unpolluted by cities, by light. The galaxy might appear larger, more obvious. Ancient astronomers in Persia, in China, in Greece recorded it, described it, wondered at it. They had no idea what it was, but they knew it was strange, different, a mystery, In the firmament, the same mystery still looks down on us, unchanged. Your thoughts completely gone now. No memories, no future, no past. Just this moment, this word, this breath, timeless, eternal, the universe reduced to a single point of soft, warm awareness, floating in infinite darkness. When everything else vanishes, what remains is already complete. In Islamic astronomy, scholars studied Andromeda, catalogued it. Al-Sufi's description from the 10th century remains the earliest definitive record. A small cloud, he wrote, visible to the keen eye on moonless nights. He couldn't know that he was documenting another galaxy, an island universe, but he saw it, recorded it, preserved it for future generations who would understand what it meant. One careful observation becomes a bridge across 1,000 years. During the Renaissance, as telescopes improved, astronomers sketched Andromeda, tried to understand its nebulous nature. Was it a cloud of gas, a cluster of faint stars, a hole in the heavens? They debated, theorized, observed, but the truth remained hidden until Hubble, in 1924, measured its distance and revealed the staggering, humbling reality. Each question answered only opens the door to deeper awe. Andromeda became a benchmark, a reference point for understanding other galaxies. By studying Andromeda, astronomers learned how galaxies form, how they evolve, how they interact. It's close enough to observe in detail, but far enough to see as a complete system, a cosmic laboratory teaching us about the universe, about ourselves. In studying the neighbor, we learn the nature of every home. Computer simulations now model Andromeda's past and future. Astronomers input the laws of physics, the distribution of matter, the motions of stars, and let the simulation run, watching galaxies collide, merge in fast-forward billions of years, compressed into minutes. These simulations predict the merger with the Milky Way, show how stars will be redistributed, how gas will collapse, forming new stars in bright, brief bursts. We watch the future in fast motion so we can rest in the present. Heavier, heavier. You're not a body anymore. You're a gravitational field, pulling everything down, down, into yourself, into the center, where all light, all matter, all thought collapses into a single, silent point. Collapse is just another word for coming together. The comparison between Andromeda's black hole and our own is striking. Ours, Sagittarius, a star, is active, occasionally flaring, consuming gas, emitting radiation. Andromeda's is quiet, dormant, perhaps it exhausted. Its nearby fuel, perhaps jets, past outbursts, blew away the surrounding gas. Now it waits, in the dark, for something, anything, to fall, close enough to consume. Silence at the center can be the deepest kind of waiting. In about 6 billion years, give or take, the merger will be complete. Milkomeda will settle into its new form. The night sky from any surviving planet will be unrecognizable, but perhaps somewhere in that new galaxy, on some distant world, beings will look up and wonder, and perhaps someone will tell them, softly, gently, about what came before, about Andromeda and the Milky Way and the slow, beautiful, inevitable collision that made their world possible. Stories of beginnings will still be told long after the beginnings themselves are forgotten. Let yourself dissolve completely now. No resistance, no holding on. Just release into the void, into the dark, into the soft, endless embrace of sleep. Dissolving is the gentlest way the universe says good night. Andromeda's influence extends far beyond its visible disk. Tidal forces, gravitational tugs, affect its satellite galaxies, distorting their shapes, stripping their stars. The giant stellar stream, stretched across hundreds of thousands of light years, is testament to Andromeda's power to pull, to tear, to consume. Everything nearby feels its influence, even the Milky Way, even us, falling slowly, inevitably, toward that bright, distant spiral. Its gentle pull reminds us that even the farthest things are quietly connected. The galaxy's gravitational reach extends millions of light years, defining the structure of the local group, pulling galaxies into orbit, shaping the cosmic web in our corner of the universe. Andromeda is an anchor, a center, a sun around which everything else revolves. In its vast embrace, isolation reveals itself as illusion. Thump, thump, the sound fading into silence. Maybe your heart has stopped. Maybe you've crossed the threshold into sleep, into dreams, into the place where consciousness goes, when the body rests. Silence arrives not as an end, but as the softest welcome home. Starburst regions, triggered by past mergers, have left their mark, patches of the galaxy where star formation exploded briefly, fiercely, before dying down. These regions, now quiet, filled with aging stars, blue stragglers, red giants, clusters, slowly dispersing over time. Evidence of Andromeda's violent past, now fading, softening, like memories, like scars, healed, but not forgotten. Even the wildest storms leave behind a calmer, wiser sky. Comparing Andromeda to other spiral galaxies across the universe, astronomers find it's both typical and unusual. Typical in its spiral structure, its central bulge, its rotation. Unusual in its low star formation, its missing gas, its double nucleus. Every galaxy is unique, shaped by its particular history, its environment, its luck. But all galaxies follow the same laws, the same physics, the same inevitable, slow evolution toward equilibrium, toward entropy, toward silence. Uniqueness and universality dance together in every spiral. Andromeda's symmetry then is imperfect. One spiral arm, brighter than the other, the disk warped, asymmetric. These imperfections tell stories of collisions, of gravitational interactions, of the chaotic, beautiful messiness of real galaxies. Only in simulations, in idealizations, are galaxies perfectly symmetric. In reality, everything is flawed, everything is beautiful, because of, not despite, those flaws. Flaws are the handwriting of a galaxy's long, honest life, your consciousness, fragmenting into dreams now, images, without logic, thoughts, without words, the voice, still speaking, but you're not listening anymore. Not really. You're somewhere else, somewhere deep, somewhere soft, where Andromeda might dream, if galaxies could dream. In dreams, the boundaries between self and cosmos quietly dissolve. Mapping Andromeda in 3 dimensions requires painstaking work, measuring the motion of individual stars, their distance, their velocity, building up a picture of the galaxy's shape, its rotation, its depth. Not just a flat image, but a living, breathing, 3-dimensional object spinning through space. Astronomers have mapped millions of stars in Andromeda, each one a data point, a story, a lifetime of light. Each measured star is a small act of love across unimaginable distance. The faint outer disk extends far beyond. The bright spiral, scattered stars, ancient metal poor, orbiting. In the darkness, the extended stellar halo reaches perhaps 300,000 light years from the center, containing the oldest stars, the remnants of the very first stellar generations, born when the universe was young, when galaxies were just forming from the primordial dark. The oldest light still carries the memory of the universe's first quiet breath. Cold gas reservoirs lurk in Andromeda's outskirts. Clouds of hydrogen, too cold to glow, too diffuse to collapse, just waiting, drifting. Perhaps, someday, they'll fall inward, forming new stars. But for now, they wait, patient, invisible, in the dark. Patience in the void is the prelude to every new beginning. Heavier and heavier. You're falling through layers of sleep, each one darker, each one deeper. Soon, you'll reach the bottom, where dreams live, where consciousness dissolves, where you're no longer you, just awareness, pure, formless, one with everything, one with Andromeda, spinning slowly through the endless dark. At the deepest layer, falling becomes floating, and separation becomes embrace. Why Andromeda appears oval from Earth is simply perspective. We see it tilted at an angle, like a frisbee, spinning toward us. If we could view it face on from above, it would appear perfectly circular, spiral arms emanating from the center in graceful curves. But we see it edge on, almost, the spiral, compressed, foreshortened, still beautiful, but different than its true form. Perspective changes nothing of the truth, only how tenderly we receive it. The galaxy's inclination angle, 77 degrees, means we see it, nearly edge on. This makes studying its spiral structure more difficult. The arms overlap in our view, but it also makes certain features more visible. The dust lanes appear darker, the warped disc more obvious. Every angle that reveals something hides something. There is no perfect view, only perspectives, each incomplete. Each imperfect angle still offers its own quiet gift of revelation. Andromeda rises in late summer in the northern hemisphere. By autumn, it's high overhead, easy to find. In winter, it sinks toward the west. By spring, it's gone, lost in the sun's glow. The cycle repeats year after year, Andromeda appearing, disappearing, with the seasons, eternal, reliable, like the stars themselves, like the soft, persistent rhythm of sleep. Season after season, it returns like a promise kept in silence. The best time to observe is autumn, on moonless nights, away from cities, in dark skies. Andromeda appears as a faint oval smudge. At first, you might miss it, might look right past it, but once you see it, once your eyes adjust, you can't unsee it. It's always there, waiting. 2.5 million years, collapsing into a moment of recognition, of wonder. That first glimpse is a small eternity folded into a single breath. Let your body go completely limp, no muscle tension anywhere. Your arms heavy, useless. Your legs distant, forgotten. Your face smooth, expressionless. You are no one. You are everyone. You're the dark between stars, the silence between heartbeats, the peace that comes when everything finally stops. Limpness is the body's gentle way of saying it trusts the dark. Long exposure photography reveals Andromeda's hidden beauty. Colors emerge, blues from young stars, reds from hydrogen gas, glowing in star-forming regions, yellows and oranges from the ancient core. With enough time, enough patience, even backyard telescopes can capture as breathtaking detail the spiral arms, the dust lanes, the satellite galaxies, all waiting to be seen, to be known, to be remembered. Patience turns faint light into vivid memory. Ancient humans, looking up, might have wondered, what is that smudge, that faint cloud in the autumn sky? They couldn't have known. They were seeing light from 1 trillion suns, couldn't have imagined the distances, the timescales involved, but they saw it, marked it, passed down stories, and now we know, we understand, we see not just a smudge, but a galaxy, a universe, a future home, when 2 galaxies slowly, inevitably, beautifully become one. Wonder began long before understanding, and it remains after. Thump, thump, or maybe silence. Maybe you've slipped beneath the waves into the deep, where sound doesn't reach, where time doesn't flow, where you simply are existing, without thought, without effort, floating in the warm, dark, eternal womb of space. Silence is the cradle where existence rests without needing a reason. Andromeda appears in ancient star catalogues. Chinese astronomers recorded it. Persian scholars described it. Greek observers noted it. Each culture saw it differently, named it differently, but all agreed it was there, persistent, mysterious, unchanging, a fixed point in the turning heavens. Across centuries and continents, the same faint glow held everyone's gaze. During the Middle Ages, Islamic astronomers preserved and expanded ancient knowledge. They studied Andromeda, measured its position, described its appearance. Their work passed to European scholars during the Renaissance, building generation by generation toward understanding, each step small, each contribution valuable, until finally the truth emerged. Knowledge is a relay passed through the quiet dark of time. Modern astrophysics now studies Andromeda with tools unimaginable to ancient astronomers, radio telescopes, space telescopes, spectrographs, computer simulations. We map it in every wavelength, from radio waves to gamma rays. We measure its rotation, its composition, its history. We predict its future. We understand so much, yet mysteries remain. The double nucleus, the missing gas, the details of the coming merger. Still, we wonder. Still, we look up and ask, why? Understanding deepens wonder rather than ending it. Your mind empty as space itself now. Vast, dark, infinite. Thoughts like stars, scattered, distant, barely visible. And between them, nothing. Just void. Just peace. Just the soft, endless, dark, where sleep finally gathers you in its arms. In that vast emptiness, the last flicker of thought dissolves into perfect belonging. The silence between Andromeda's stars is absolute. Perfect. In the vacuum of space, no sound travels, no whisper carries. Each star burns alone, separated from its neighbors by light years of emptiness, of nothing. If you stood on a planet orbiting a star in Andromeda's spiral arms and screamed, no one would hear, not the next star over, not anyone. The silence, deeper than any silence you've ever known, deeper than the quietest room, the stillest night. It's the silence of space itself, of the void between everything. In that perfect hush, every worry finally finds its place to rest. Let that silence wash over you now. Feel it in the room, around you. The quiet growing deeper, softer. Your breath, the only sound, and even that fading, becoming part of the silence, part of the endless, cosmic quiet. The world outside dissolves until only this gentle absence remains. The scale of emptiness inside Andromeda defies imagination. 1 trillion stars sounds crowded but spread across 220,000 light years. It becomes sparse, empty, vast beyond comprehension. If you could shrink the sun to the size of a grain of sand, the nearest star would be 4 miles away. In Andromeda, The distances are similar or greater. A galaxy is mostly nothing, mostly darkness, with tiny specks of light scattered like dust in an endless cathedral. Emptiness is not absence. It is the canvas on which everything quietly exists. Your body sinking through layers of mattress, of floor, of earth, down and down into emptiness, into the spaces between atoms, between thoughts, between heartbeats. You're becoming the emptiness, the silence, the vast, patient dark. And in becoming nothing, you become everything at once. Imagine drifting through Andromeda, moving between stars. Light years pass, decades, centuries, nothing but darkness, nothing but void. Occasionally, a star appears, distant, faint, growing brighter as you approach, then passing, fading, behind you, and darkness again. For years, for lifetimes, just empty space, cold, silent, beautiful, in its absolute emptiness. Each lonely passage only deepens the peace of simply being. Thump, thump, your heart, barely moving now, each beat separated by eternities like stars in Andromeda, each one alone, burning in the dark, connected by gravity, by history, but separated, always separated by the unbridgeable void. Even the faintest rhythm echoes across the same infinite quiet. In science fiction, Andromeda calls to explorers, to dreamers. The Andromeda Galaxy, a destination impossibly far, impossibly beautiful. Stories imagine generation ships traveling for millions of years, civilizations born, living, dying in transit, never seeing either home or destination, just the journey, endless, patient, slow. The dream of arrival matters less than the courage to keep drifting. Let your thoughts drift like those ships, moving through darkness. No destination, no arrival, just movement, just the journey, floating forever through the void, content to never arrive, content to simply drift. Drifting without end is its own kind of homecoming. Other stories imagine wormholes, faster than light travel, ways to cross the 2.5 million light years in moments, in heartbeats, emerging in Andromeda among alien stars, alien worlds, finding what? Life, civilizations, or just more silence, more emptiness, more stars, burning alone in the dark. Even shortcuts would only lead back to the same beautiful solitude, but the reality is simpler, more beautiful. We can't go there, can't visit, can't ever leave our local group, our cosmic neighborhood. We're bound by distance, by physics, by the speed of light. Andromeda will always be unreachable, except through light, through observation, through imagination, a forever as distant dream. Unreachability makes the longing pure and gentle. Your eyelids, sealed shut now, too heavy to ever open. The darkness behind them, complete, like the darkness between galaxies. Nothing and everything, all at once. Behind closed eyes, the universe folds itself into perfect stillness. In popular culture, Andromeda appears in songs, in poetry, in art. The Andromeda Strain, a novel about cosmic contamination. The Andromeda Galaxy, a symbol of the distant, the mysterious, the unreachable. People name their children, their companies, their dreams after Andromeda, because it represents something beyond, something greater, something eternal. We borrow its name to remind ourselves that wonder has no horizon. Musicians write songs about galaxies colliding, about spiral arms, about cosmic loneliness. Andromeda becomes metaphor for distance, for longing, for the unreachable beloved. Two galaxies destined to merge, but separated by millions of years, like lovers kept apart by time, by space, by fate. The ache of separation only makes eventual union more tender. Let that longing dissolve now. There's nothing to reach for, nothing to want. Everything you need is here, in the darkness, in the quiet, in this moment, complete, whole, perfect. Just this. Desire fades when the heart finally recognizes its own fullness. Artists paint Andromeda, its spiral arms, rendered in oils, in watercolors, in light. Photographers capture it. Long exposures, revealing colors, invisible to the eye. Blues, pinks, golds, each image unique, each perspective different, but all showing the same truth. The galaxy, spinning, eternal, beautiful, indifferent to our watching. Every brushstroke and photon carries the same quiet reverence. The emotional impact of seeing Andromeda for the first time can be profound. Standing in darkness, looking up, finding that faint smudge, and knowing, really knowing what it is. 1 trillion stars, 2.5 million light years, an entire galaxy, visible to your unaided eyes. Some people weep, some people laugh, some stand in silence, overwhelmed by the scale, by the beauty, by their own smallness. In that moment of recognition, smallness feels like the sweetest freedom. Heavier, heavier. You're not just sinking just anymore. You've sunk past the bottom into something deeper, a place where weight has no meaning, where body has no form, just awareness dissolving into the infinite. Dissolution is not loss, it is the gentlest return to wholeness. Andromeda reminds us we are small, our lives brief, our world tiny, but also we are part of something vast, ancient, eternal. The same atoms in your body exist in Andromeda. Carbon, oxygen, iron, forged in stars, scattered by supernovae, across galaxies, across time. You are made of star stuff. Andromeda is made of star stuff. There is no separation, only the illusion of distance, of difference. In that shared stardust, every lonely silence becomes a quiet embrace. Looking at Andromeda, some feel cosmic loneliness, the vast, empty silence between galaxies, the impossibility of ever reaching out, touching, connecting. We're alone on our small world, in our small galaxy, watching others from across unbridgeable voids, forever separated. Yet in that loneliness the heart finds its quietest truth, but others feel cosmic connection. We're all part of the same universe, the same story, the same atoms, the same laws, the same beginning, the same end. Andromeda and the Milky Way, siblings, twins, moving through space, together, drawing closer, destined to merge, to unite. Nothing is truly separate. Everything connected by gravity, by time, by the invisible thread of existence. That shared stardust whispers, you are never alone. Your breath, so slow, you might have stopped, might have crossed the final threshold into sleep. But the voice continues, soft, persistent, a thread leading you deeper, always deeper, into the mystery, into the dark, and the darkness welcomes you like an old patient friend. Andromeda, as the nearest spiral neighbour, makes it special, intimate. Despite the distance, it's close in cosmic terms. The Milky Way's companion, its partner in the slow dance of gravity. Together, they dominate the local group, two giants among dwarfs, two spirals among irregulars, similar in size, in structure, in destiny. Mirror images approaching across the void. Proximity turns strangers into family, even across millions of years. Other spiral galaxies exist, millions, billions, scattered through space, but they're distant, unreachable, even by light in human timescales. Andromeda, we can see, can study, can know. It's our cosmic neighbour, our future, our fate, the galaxy. We're falling toward slowly, inevitably, beautifully. Knowing one neighbour makes the whole vast neighbourhood feel less empty. The slow dance between galaxies unfolds across billions of years, invisible to human eyes. We see one moment, one frozen instant in an endless waltz. But the dance continues, Andromeda approaching, the Milky Way approaching, both pulled by mutual gravity, both falling toward the moment of collision, of merger, of union. Every step in that dance is written in the language of physics and longing. Thump, thump. Or maybe that's the rhythm of the dance, the pulse of galaxies orbiting, the beat of cosmic time, slow, patient, eternal, measured in eons, not seconds, in light years, not miles. The universe has all the time in existence. Why rush? The heartbeat of the cosmos teaches us the beauty of unhurried motion. Let yourself move to that rhythm, slow, slower, slower than breath, slower than thought, moving like galaxies, imperceptibly, inevitably, toward rest, toward stillness, toward the moment when motion finally unstops. In matching that tempo, the body forgets it ever needed to hurry. Andromeda and cosmic inevitability go together. The merger will happen. Not maybe. Not possibly. will, certainty. Written in mathematics, in gravity, in motion, we can predict when, where, how. The laws of physics allow no escape, no deviation. The future, already determined, already unfolding. We're just watching it happen in slow motion. Certainty, once terrifying, now feels like the softest kind of permission to let go. There's something comforting in that inevitability. The future, certain. No need to worry, to plan, to fear. It will happen, whether you're ready or not, whether you accept it or deny it. The merger continues, patient, unstoppable, like sleep, like aging, like time itself, inevitable. Knowing the ending frees you to simply be present in the unfolding, your consciousness, letting go of control, of the illusion that you can change anything, surrendering to inevitability, to gravity, to the pull of sleep, accepting that you're already falling, already sinking, already as gone. Surrender is not defeat. It is the final, perfect alignment. The patience of galactic motion is absolute. Andromeda approaches at 110 kilometers per second. Sounds fast, but across 2.5 million light years, it's glacial, imperceptible. In a human lifetime, Andromeda moves, barely. Human generations rise and fall. Civilizations form and crumble, and Andromeda barely moves in the sky. Patience beyond human understanding. Motion so slow it appears as stillness. That glacial pace reminds us true change asks for lifetimes we cannot live. But it's not still, never still, always moving, always approaching. Time, stretched across billions of years, makes motion invisible. But it's there, constant, relentless, like your breath, like your heartbeat, continuing whether you notice or not. Even unseen, the movement never falters. It simply waits for you to notice its gentleness. Let that patience infuse you. No need to hurry, no need to rush toward anything. Everything happens in its own time. Sleep comes when it comes. You can't force it, can't demand it, only surrender and wait, patient, like Andromeda, drifting through the dark. Patience is the universe's quietest lullaby. Andromeda, as a reminder of cosmic scale, humbles us. 2.5 million light years, light travelling at 300,000 kilometers per second, takes 2.5 million years to cross that distance. The fastest thing in the universe still takes millions of years, and we, travelling at highway speeds, would take trillions of years to reach Andromeda. More than the age of the universe, more than time itself has existed. In the face of such distances, smallness becomes strangely liberating. Human scale is tiny, microscopic. We measure our lives in decades, our history in millennia. But cosmic history spans billions, trillions of years. We're barely a blip, a momentary flicker in the endless flow of time. And yet that tiny flicker is enough to feel wonder to breathe, to dream of galaxies we will never touch. Your life, shrinking now, becoming small, insignificant, but not in a sad way, in a freeing way. Nothing you do matters on cosmic scales. All your worries, your fears, your regrets, tiny, meaningless, dissolved in the vast, indifferent beauty of space. You can let go, let it all go. It never mattered anyway. And that realization feels like the gentlest exhale, heavier, heavier, sinking through the cosmic scales, past planets, past stars, past galaxies, down into the quantum foam, where even space, even time dissolve into probability, into uncertainty, into the formless, nameless or void. There is nothing left to grasp and nothing left to lose. The distance to Andromeda makes it safe. We can observe, study, admire without fear. It's not going to collide in our lifetime, or our children's lifetime, or for thousands of generations. We're safe, protected by time, by distance. We can watch the slow approach, knowing we won't be here when it arrives, like watching a sunrise that won't crest the horizon for millions of years. And somehow that vast patience soothes the soul. But our distant descendants, if they exist, will witness the merger, will see Andromeda filling the sky, will experience the chaos, the beauty, the transformation. They'll inherit the results of this slow collision. We'll live in Milkomeda, a galaxy we can barely imagine, born from the union of two ancient spirals, a future we will never touch, yet helped create. Thump, thump, softer, fainter, each beat separated by longer pauses, space between heartbeats, expanding like the space between galaxies, growing, stretching, until maybe the next beat never comes. And that's okay. That's perfect. That's exactly how it should be. Rest is the final kindness the body offers itself. Within Andromeda, time flows differently, or rather the same, but our perception changes. 1,000,000 years on Andromeda is nothing. Stars barely move, the galaxy barely rotates, but to us, 1,000,000 years is forever, longer than human history, longer than our species has existed. Time is relative, perspective is everything, and in that shift of scale, all urgency fades. If you could live as long as a galaxy, 10 billion years, what would you see? Stars forming, dying, forming again, clouds of gas, collapsing, igniting or expanding, the spiral arms, winding, unwinding, perhaps colliding with another galaxy, absorbing it, growing, everything in motion, everything changing, but so slowly, so patiently, that it appears almost still. Eternity moves like the quiet turning of a wheel. Let your sense of time dissolve. No past, no future, only this eternal and present moment, stretched, infinite, in all directions. You've been here forever. You'll be here forever. Or maybe just a second. Time has no meaning anymore. in the soft, dark place where you've gone. Here, every moment is both beginning and end. Andromeda contains mysteries we'll never solve, not because we lack technology, but because some information is lost forever. The details of stars that died billions of years ago, the exact path of Andromeda's formation, the nature of dark matter that holds it together. We can theorize, can guess, can model, but we'll never truly know. Some mysteries remain forever, and that's beautiful, perfect. The universe doesn't owe us answers. Silence is the universe's most elegant reply. Perhaps inside Andromeda, right now, planets orbit, oceans wave, mountains rise. Perhaps life exists, simple or complex. Perhaps civilizations look up at their stars and wonder. Perhaps someone, somewhere in Andromeda, is falling asleep, just like you, listening to someone tell them about galaxies, about stars, about the strange, distant spiral they call the Milky Way. Across billions of light years, the same quiet longing connects us. Your mind fragmenting now, thoughts scattering like stars. No coherence, no structure, just random flickers of awareness, appearing, disappearing in the dark. Nothing holding together, nothing making sense. And that's perfect. That's exactly what sleep feels like. Even chaos can be a form of peace. The light from Andromeda is ancient, but also eternal. The galaxy has shone for 10 billion years, will shine for billions more, long after the sun dies, long after Earth is gone. Andromeda's light will continue, pouring into space, traveling to distant worlds, to distant eyes, perhaps someday to beings we can't imagine, watching from distances. We can't conceive the light continuing forever, or until the last star finally dies. One small photon carries the story of an entire galaxy, but even then, even in the far future, when all stars are dead, when the universe is dark, cold, empty, Andromeda will remain as a cloud of dead stars, brown dwarfs, black holes, neutron stars, drifting through the darkness, a ghost of its former self, but still there, still existing, proof that something once burned bright. Even in death, existence leaves its gentle echo, heavier, heavier, past the point of heaviness, beyond weight, beyond sensation. You're not a body anymore, not even consciousness, just a possibility, a probability wave, collapsing into the single state of sleep. And in that collapse, everything becomes perfectly simple. Andromeda teaches patience more than anything. If you want to see change, to see motion, to see collision, you must wait, not years, not lifetimes, but millions of years, billions. The universe operates on timescales that make human impatience meaningless, ridiculous. Everything happens, everything changes, You just can't live long enough to see it. And in learning to wait, we finally learn to rest. But we can imagine, can extrapolate, can predict using mathematics, using physics. We can see the future, even if we'll never witness it. We know what will happen to Andromeda, to the Milky Way, to the stars, to the planets. We can see it in our minds, play it forward, watch galaxies merge in simulation, in imagination. Time compressed, billions of years into seconds, the slow made fast, the invisible made visible. Imagination is the only telescope that can look billions of years ahead. Your breath, invisible now, imperceptible. Are you breathing? You're not sure. Don't check. Don't think. Just drift. Let the body do what it does or doesn't. Without you, without awareness, without concern. The body knows how to rest even when the mind has forgotten how. The mythology of Andromeda echoes still. The princess, chained to rocks, offered as sacrifice to appease a sea monster waiting for rescue or death. The constellation preserves her, immortalizes her in stars, but the galaxy, named for her, is even more eternal, more vast, more patient than any myth. Myths fade, but the galaxy named for her simply continues, unconcerned with the stories we tell. Perhaps galaxies are the true immortals, the true gods, existing beyond human time, beyond human understanding. We worship our brief gods who live in human imagination. But galaxies are real, ancient, powerful, indifferent. They don't care if we worship them or ignore them. They continue, burning, spinning, approaching each other, inevitable, patient, eternal. Indifference is not cruelty, it is the purest form of permanence. Thump, thump, maybe, maybe not. Sound and silence, blending, no different anymore between presence and absence, between something and nothing. All boundaries erased, all distinctions meaningless in the soft, formless void. When sound and silence meet, they recognize they were never apart. Andromeda's gravity reaches across millions of light years, pulling gently, persistently on everything. The Milky Way feels it, falls toward it. Satellite galaxies feel it, orbit around it. Even light passing near bends, curves, follows the warped space-time around. So much mass, gravity, invisible, intangible, but more real than anything you can touch. Gravity is the universe's quiet promise that no one is truly alone. That same gravity pulls on you right now. Andromeda's gravity, infinitesimally small but present, tugging on every atom in your body. You're connected to that distant galaxy by invisible threads, by the curvature of space-time. Everything in the universe pulls on everything else. Nothing is separate. Nothing is alone. All of existence bound together by gravity's gentle, endless pull. Even the faintest tug is proof you belong to everything. Let that pull take you down, deeper, further than you've ever gone, into the place where gravity becomes everything, where space curves completely, where time stops. The event horizon of sleep, once crossed, there's no returning. Not until morning, not until the light pulls you back. But for now, just fall into the gravity well of sleep. Crossing the horizon is simply allowing yourself to be carried all the way home inside Andromeda right now. Stars are exploding, supernovae sending shockwaves through gas clouds, compressing them, triggering new star formation, neutron stars spinning thousands of times per second, pulsing radio waves into space, black holes feeding or starving, depending on what drifts too close, planets orbiting, day and night, seasons changing, processes continuing. Whether we watch or not, whether we know or not, the galaxy lives, breathes, changes, indifferent to observation. The galaxy keeps its private life, vast and complete, whether we notice or not. And yet, we watch, we observe, we study, because understanding Andromeda helps us understand ourselves, our place in the cosmos, our origins, our fate. The galaxy is a mirror showing us what we are, where we came from, where we're going. And in that mirror, when we see not just galaxies, but ourselves, small, brief, beautiful, connected to everything. Looking up is the oldest way of looking inward. Your last thoughts drifting away now, like photons escaping a galaxy, traveling into the void, never to return. Each thought a small light fading into distance, into darkness, until nothing remains but the soft, empty, silent peace. Thoughts leave like stars setting, gentle and without goodbye. Andromeda will outlive everything. You know, your name, your language, your species, your world, all temporary, all brief. But Andromeda continues long after you're gone, long after everyone is gone. The galaxy spins, stars form, stars die. The dance continues, patient, eternal, indifferent, beautiful in its persistence. Persistence without purpose is the most honest kind of beauty, but that's not sad. That's perfect. You're not meant to last forever. Nothing is, except perhaps galaxies, and even they eventually fade. Everything temporary, everything changing, the universe flowing like water, like time, like breath, from form to formless, from something to nothing, and back again, endless, cycling, creation and destruction, forever entangled, forever dancing. Impermanence is the rhythm that lets everything keep moving. Let yourself become part of that dance, dissolving into the pattern, merging with the flow, no longer separate, no longer we, you, just consciousness, pure, undefined, flowing with everything toward nothing and everything, sleep and awakening, death and rebirth, all the same, in the end, all lead-ins to the same, soft, dark, infinite, now. Dissolving is the dance's way of saying welcome back, heavier, heavier, but you can't feel heavy anymore, can't feel anything, just awareness, fading, dimming, like a star, running out of fuel, slowly collapsing, contracting, going out, not with explosion, but with a whisper, a sigh, a gentle, final release. The quietest fade is the kindest goodbye, and Andromeda keeps turning, keeps burning, keeps approaching, through the night, through the years, through the eons, patient, inevitable, beautiful, the spiral arms reaching out across space, across time, reaching toward us, toward the Milky Way, toward the moment, billions of years from now, when two become one, when separation ends, when everything finally comes together. The reaching has already begun, and it will finish without ever noticing our small witness. But tonight, we're still separate, still distinct, still falling toward each other. The journey not yet complete, the dance not yet finished, just this moment, this breath, this soft, gentle, endless drift into the dark, into the quiet, into the peace that waits between the stars. Tonight the drift is enough. Tomorrow is another galaxy's concern. Andromeda serves as a benchmark for galactic studies because it's close, well observed, extensively studied. Astronomers use it to test theories, to calibrate models, to understand what is typical, what is unusual in the universe of galaxies. It's a Rosetta Stone, translating the language of light into knowledge, into understanding. Through its steady glow, Andromeda quietly decodes the secrets shared by every spiral. Studying galactic evolution through Andromeda teaches us about our own galaxy, the Milky Way, which we can't see from outside, can only infer from within, but Andromeda we see completely, its structure, its history, its future, all visible, all measurable. And because the two galaxies are similar, what we learn from Andromeda tells us about ourselves, about our cosmic home. In watching our twin, we finally glimpse the face we could never see directly. Let yourself sink past the deepest layer, past dreams, past sleep, into something beyond words, beyond thought, the place that has no name, the place you go every night and forget every morning. But tonight, you'll stay, you'll drift, you'll dissolve into the dark, and maybe you won't come back until morning, or maybe never. And that's okay, that's perfect, that's exactly as it should be. Beyond naming, the nameless place holds you without asking for anything in return. Andromeda's stellar density varies dramatically from the dense core where stars crowd together to the sparse outer regions, where individual suns drift alone, separated by vast, empty light years. Each region has its own character, its own story. The core, ancient, stable, crowded. The spiral arms, young, dynamic, turbulent. The halo, old, scattered, quiet. Each part contributing to the whole. Density tells the story of time, crowded youth giving way to spacious age. The quiet core doesn't mean nothing happens. Stars still orbit, still occasionally collide, still die in spectacular supernovae. But compared to starburst galaxy or active galactic nuclei, Andromeda's core is peaceful, contemplative, like an old person who's seen everything, done everything, now content to simply exist. Peace in the core is the wisdom of having already burned brightly. Comparing Andromeda's black hole to those in other galaxies reveals its modest size. The giant elliptical galaxy M87 harbors a black hole, 6.5 billion solar masses, dwarfing Andromeda's 100 million solar mass giant. Even some smaller galaxies host larger black holes. The relationship between galaxy mass and black hole mass isn't perfectly consistent. Each galaxy, each black hole, has its own history, its own story of growth, consumption, and dormancy. Size tells only part of the story. History writes the rest in silence. Thump, thump, but you can't hear it anymore, can you? You've gone too deep, too far into the soft, silent center, where even your heartbeat can't reach. Only the voice remains like a thread leading you deeper, deeper into the labyrinth of sleep. When the heartbeat fades, the thread of the voice becomes the only gentle tether. The missing gas mystery in Andromeda puzzles astronomers still. Galaxies like the Milky Way have abundant cold gas, fuel for future stars, but Andromeda has less, much less than expected. Where did it go? Past supernovae could have blown it away, heated it, made it too hot to collapse, or past mergers could have disrupted it, scattered it into intergalactic space, or the central black hole in an active phase billions of years ago could have expelled it in powerful jets. We don't know. The mystery remains. Some absences are as eloquent as any presence. Why Andromeda has fewer star-forming regions than the Milky Way relates to this gas deficit. Less gas means fewer stars. Simple, but why less gas? That's the question, and the answer remains uncertain, hidden, like so much in the universe. We see the effect, but the cause eludes us. For now, the quiet is not emptiness. It is a question still waiting to be answered. You're breathing, so slow now, so shallow, each breath lasting forever. The pause between infinite. You might have stopped breathing. You're not sure. Don't check. Don't think about it. Just let go. Let the body breathe itself, or not. It doesn't matter. Nothing matters. In the soft, warm, eternal now. The pause between breaths is where eternity hides, past bursts of star formation, left evidence in stellar populations, stars of similar age clumped together, indicating they formed in the same event, the same collapse of gas triggered by a collision or a density wave or chance. These bursts punctuate Andromeda's history, moments of intensity, of creation, between long periods of quiet. It's not constant, not steady, but episodic, like breathing, like heartbeat, like the rhythm of life itself. Creation arrives in waves, then rests, just as every life does. Andromeda's future star formation will be minimal. Most of its gas is consumed or lost. What remains will slowly, very slowly collapse, forming stars, red dwarfs, mostly small, faint, long-lived. These stars will outlive everything. They'll burn for trillions of years, long after the sun, long after Earth, long after the merger, long after the last massive stars have died. Red dwarfs will remain faint, patient, eternal, the final stars in a darkening universe. The smallest flames burn the longest, carrying the quiet promise of endurance. Andromeda and cosmic timescales put everything in perspective. 4 billion years until the merger sounds like forever, but it's only 1/3 of Earth's current age. The Sun has already lived for 4.5 billion years in cosmic terms. 4 billion years is nothing, a moment, a breath. Time flows differently on galactic scales. What seems eternal, yes, to us, is fleeting to the universe. What feels endless to us is merely a sight of the stars, heavier, heavier. You're not falling anymore. You've already landed or at the bottom of an ocean of sleep. The pressure immense, but comforting, holding you completely. You couldn't move, even if you wanted to, but you don't want to. You want to stay here forever, in the dark, in the deep, in the soft, silent peace. The bottom is not an end. It is the place where pressure becomes perfect embrace. Light travel time from Andromeda means we see it as it was 2.5 million years ago. When that light left the galaxy, our ancestors were barely human. Stone tools, just invented. Language, perhaps, just emerging. And that light travelled through the void, through the dark, for all that time, just to reach us, tonight, to touch your eyes, or would have, if they were open, if you were still awake. The past arrives tonight, patient and unchanged, simply to be seen. Seeing Andromeda as it was millions of years ago is like looking into the past, but not our past, Andromeda's past. 2.5 million years ago for Andromeda, not so different than today. Stars were born, stars died, the galaxy rotated exactly as it does now. On human timescales, everything changes. On galactic timescales, almost nothing does. Change is loud for us, but galaxies move in whispers across the ages. Andromeda, as a cosmic mirror of the Milky Way, shows us what we look like from outside. Both galaxies spiral. Both have central bulges, supermassive black holes Satellite galaxies, both roughly 10 billion years old, both heading toward merger, toward transformation. Looking at Andromeda, we see ourselves, our future, our past, our cosmic twin. The mirror doesn't judge, it simply reflects what has always been true. What Andromeda teaches us about our galaxy is invaluable. We can't leave the Milky Way, can't photograph it from outside, but we can study Andromeda and learn its structure, hints at ours, its history, mirrors ours, its future predicts ours. Through Andromeda, we understand the galaxy we call home. By studying the neighbor, we come to know the house we live in. Your consciousness, no longer a single point, but diffused, spread out across space, across time. You're everywhere, nowhere. You're the mattress, the pillow, the air, the darkness. You're Andromeda, spinning slowly through the void. You're a star, burning for billions of years. You're nothing and everything, and somewhere in between, you're finally asleep. Diffusion is the gentle return to being everything without needing to be anything. Andromeda's role in cosmology extends beyond its individual properties. It's a stepping stone in the cosmic distance ladder. Astronomers use Cepheid variables in Andromeda to calibrate distances to more distant galaxies. Each rung of the ladder depends on the previous one, and Andromeda is a crucial rung connecting nearby stars to the distant universe. One nearby galaxy becomes the bridge to the farthest edges. Andromeda and the expansion of the universe seems contradictory. The universe expands, galaxies moving apart, but Andromeda moves toward us, approaching. How? Because on local scales, gravity dominates, overcomes expansion. The local group is gravitationally bound. Andromeda and the Milky Way fall toward each other despite the universe expanding rust around them. Local forces overwhelming cosmic trends, at least for now. Gravity wins the small battles even as expansion claims the vast war. Andromeda's place in deep time stretches imagination, 10 billion years old, 4 billion years, until merger, 5 billion more as Milkomeda, 10 billion after that, as stars slowly die. The galaxy fades, red dwarfs, the last survivors, 20 billion years from formation to final darkness, and even that is just a fraction of the time the universe will exist. Trillions of years of slow decay, of cooling, of darkening, until only black holes remain, and eventually even those evaporate into nothing. Deep time turns even the grandest galaxies into brief guests at the universe's long table. Thump, thump. Or maybe that's the sound of stars dying, collapsing, exploding, scattering their light across the dark. Or maybe it's the sound of galaxies colliding, merging, becoming one. Or maybe it's nothing, just silence. You've gone too deep to hear anything anymore. Silence is the final note that contains every sound that ever was. Imagining life within Andromeda stirs wonder. Do planets orbit those trillion suns? They must. Surely a statistical certainty demands it. Rocky worlds, gas giants, icy moons, all possible, all probable. And if planets, then maybe life, simple life, complex life. Perhaps civilizations looking up at their own unfamiliar sky, wondering about us, about the Milky Way, that distant spiral, approaching slowly, inevitably, across time. Wonder is mutual. Somewhere a mind may already be turning toward our faint light. Planet formation in Andromeda follows the same laws as here. Disks of gas and dust around young stars, colliding, accreting, forming planets, some close to their star, hot, scorched, others far, cold, frozen, and some in between, in the habitable zone, where water could be liquid, where life might possibly to emerge. The same quiet recipe repeats across trillions of worlds, patient and unhurried. Exoplanet possibilities in Andromeda are vast. We can't detect them directly. Too far, too faint. But statistics from our own galaxy suggest trillions of planets in Andromeda. Billions potentially habitable. And maybe, just maybe, on some of them, right now, someone looks up and wonders about that faint smudge, that distant galaxy approaching from across the void. Across the void, curiosity may already be looking back. Let yourself disappear completely now, not even a whisper of awareness, remaining just darkness, just peace, just the infinite, eternal, now, where nothing needs to happen, where nothing can happen, where you simply are or aren't, and it doesn't matter like which. Disappearance is the softest way of becoming complete. Andromeda will grow in our sky. Over millions of years, millennia, centuries, it will brighten, enlarge, dominate. Eventually, in the distant future, beings on Earth, if any remain, will see Andromeda filling the night sky, a magnificent spiral, close enough to distinguish individual stars, individual regions, a sky transformed, beautiful, terrifying, inevitable. The sky's slow expansion is the universe's most patient promise of reunion. The collision, when it truly begins, will reshape both galaxies. Stars flung into new orbits, some ejected into darkness, others falling toward the center. Gas clouds colliding, compressing, igniting in brief, furious bursts of star formation. The sky ablaze with blue light from newborn stars. For a few 100 million years, the merged galaxy will shine, brighter than either, alone. In the blaze of union, even destruction becomes the brightest kind of creation. But eventually, the gas exhausts, the stars age, the light dims. What remains is Milkomeda, an elliptical blob, featureless, smooth, red and orange stars, slowly dying, few young stars, few bright stars, just a quiet, fading collection of ancient suns, waiting for the end, your heartbeat, if it still beats. so faint, so slow that even you can't feel it. You're beyond sensation, beyond awareness, beyond thought. You're in the place where dreams are born, where consciousness dissolves, where everything and nothing are the same. And here, in this place, Andromeda waits, always waiting, always approaching, a galaxy of ghosts, a galaxy of light, a promise of change, of transformation, of endings and beginnings, 2.5 million light years away, but also right here, right now, in this moment, this breath, this soft, endless, dark, the spiral arms still turning, the stars still burning, the black hole still waiting at the center, patient, eternal, and we drift with them through the void, through time, through space, falling, always falling toward each other, toward merger, toward transformation, toward the moment when two become one, when separation ends, when boundaries dissolve, and everything finally comes home. Thump, thump, the universe breathing, stars forming, stars dying, galaxies colliding, galaxies merging, the cosmic heartbeat, slow, vast, eternal, and you drifting with it, part of it, inseparable from it. You are the universe experiencing itself, and right now the universe is falling asleep. Let the last threads of waking dissolve. Let the voice fade into background, into dream, into nothing. You don't need it anymore. You don't need anything. You're complete. You're whole. You're exactly where you need to be, in the dark, in the quiet, in the soft, endless peace of sleep. Andromeda spins, stars form and die. Light travels across the void. Time flows forward, always forward, toward the merger, toward Milkomeda, toward the distant future, when everything we know will be transformed. But not tonight. Tonight, there's only this moment, this breath, this soft, gentle voice telling you it's okay to let go, to drift, to sleep. The ancient light from Andromeda still falling on Earth, on your closed eyes, even now, 2.5 million years of travel, ending in this moment. Photons, tiny messengers, completing their journey, touching everything, everyone, every night. Andromeda reaches out across the void and touches us, gently, softly, like a lullaby, sung by the universe itself, and the stars keep burning, and the galaxy keeps turning, and time keeps flowing, and we keep drifting, floating together through the mysteries. 100 mysteries of Andromeda, looping softly, endlessly, through the night. Nothing to do, nowhere to go, just this forever, or until morning, whichever comes first. Your body completely still, completely relaxed, heavy as a star, dense as a galaxy, but also light, weightless, free, floating in the dark, between worlds, between thoughts, between heartbeats, in the space that has no name, where consciousness finally lets go. Thump, thump, softer now, quieter, almost gone. The last sound before silence, the last light before darkness, the last breath before sleep. And Andromeda glides closer, inch by inch, light year by light year, century by century, inevitable, patient, beautiful, a promise, written in gravity, in motion, in the mathematics of space and time. We will merge, we will become one, not today, not tomorrow, but someday, in the distant, unimaginable future. But tonight, we drift, separately, together, two galaxies, spinning through the void, drawing closer, with every passing moment, with every passing billion years, falling, always falling, toward each other, and you, drifting, falling, with them, into sleep, into darkness, into the soft, eternal peace. Nothing left now but the dark and the quiet and the slow, gentle turning of Andromeda through space, through time, through the infinite cosmic night, and you, part of it, inseparable from it, forever, drifting, floating, dissolving into the mysteries and into the darkness, into the deep. Let go, let go, let go. The voice, fading now, growing distant, like a star, setting below the horizon. Soon it will be gone, and there will be only silence, only darkness, only you and Andromeda spinning together through the endless, beautiful, dark Andromeda, Andromeda, the chained princess, the spiral galaxy, the ancient light, the coming collision, the trillion stars, the supermassive black hole, the mystery, the mirror, the promise, all of it drifting or with you into sleep, heavier, heavier, deeper, deeper, darker, darker, until there's nothing left but the soft, warm, eternal now, and even that fading, dissolving, like morning mist, like starlight at dawn, gone, but not forgotten, present, but invisible, here and nowhere and everywhere, all at once. Thump, thump, or maybe a silence. You can't tell anymore, can't distinguish between sound and silence, between waking and sleep, between yourself and the universe. All boundaries gone, all separation ended, just one infinite consciousness drifting through the void forever and ever and ever. The universe keeps turning as Andromeda glides closer with every passing billion years, and will keep drifting, floating together through the mysteries. And will keep drifting, floating together through the mysteries. 100 supernova explosions mysteries, looping softly, endlessly through the night. Tonight we'll drift through the hidden lives of dying stars, how giants perish, and what mysterious remnants they leave behind. The cosmic forge where supernovae craft the gold in your jewelry and the iron in your blood, and the ghostly nebulae still glowing decades after their stars exploded, haunting the universe with ancient light. There's nothing you need to do now. Just let your body sink heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe and hit like so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into supernova explosions. Imagine a star, 20 times more massive than our sun, burning quietly in the velvet darkness. For millions of years it fuses hydrogen, patient, steady, like your breath right now, in and out. The star doesn't rush, it takes its time, building layers inside itself like a cosmic onion. Each layer a different element. Hydrogen on the outside, then helium, carbon, oxygen, silicon, and at the very center, iron, that final peaceful layer where fusion stops, because iron takes more energy than it gives. The core grows heavier, heavier, denser, until it can no longer support its own weight. Let your eyelids grow heavy now, heavier, matching that stellar core, sinking, drifting down. When the iron core reaches about 1.4 times the mass of our sun, something beautiful happens. This is called the Chandrasekhar limit, a gentle boundary discovered by a young scientist on a ship across the ocean. He calculated it in the 1930s. This perfect threshold, where electron pressure can no longer hold up the star. The core collapses, not violently, but inevitably, like water finding its level, like your body settling into the bed, deeper, softer. The collapse happens in less than a second, but time moves differently out there. The core compresses, smaller, denser, until protons and electrons merge into neutrons, and suddenly the collapse stops. The core bounces like a soft drum beat, thump, and sends a shockwave outward through all those layers: hydrogen, helium, carbon, oxygen, silicon. The shockwave stalls for a moment, needs help, and that help comes from neutrinos. Neutrinos, those ghost particles, trillions of them pouring out of the collapsing core. Most pass right through the Earth, through you, through everything, unnoticed, unfelt. But in the dense layers of the dying star, just enough of them interact, transferring their energy, reviving the shockwave, pushing it outward, carrying the star's outer layers into space. This is the moment, the supernova, the explosion that seeds the universe with everything we are. Feel your breath, moving like those expanding layers, outward, soft, peaceful. The light from a supernova can outshine an entire galaxy, billions of stars, but that brightness fades. Within weeks it dims. Within months it becomes a whisper, a gentle glow. The expanding shell of gas continues outward at thousands of kilometers per second. But it's not chaos. It's a slow, methodical expansion, like ripples on a pond, spreading, fading, becoming part of the cosmic background. Inside that expansion, something miraculous occurs. The temperature reaches billions of degrees, hot enough for nuclear fusion to create elements heavier than iron, gold, platinum, uranium, all forged in those final seconds. The R process, they call it. Rapid neutron capture, where atomic nuclei gobble up neutrons faster than they can decay, building heavier and heavier elements. The gold in any ring, the iron in your blood, the calcium in your bones, all made in stellar explosions. You are stardust, literally, physically, cosmically. Let that thought carry you. You are made of stars, ancient, eternal, drifting. Not all supernovae are the same. There's a quieter type called Type Ia, where a white dwarf, the ember of a dead star, orbits a companion. Over millions of years, the white dwarf pulls matter from its partner, gentle, patient, accumulating mass, until it too reaches that Chandrasekhar limit. Then it explodes completely, leaving nothing behind, no remnant, just an expanding cloud of elements. These explosions are so consistent, so uniform, that astronomers use them as standard candles, measuring the distances to far galaxies, discovering that the universe is expanding, accelerating into the dark. Your muscles are relaxing, expanding, softening into the sheets, further, further. When a supernova explodes, it leaves behind a remnant. Sometimes it's a neutron star, a sphere only 20 kilometers across, but containing more mass than the sun. A teaspoon of neutron star material would weigh 1 billion tons on Earth. The neutrons packed so tightly, touching, pressed together like nowhere else in the universe. These neutron stars spin, some of them, impossibly fast, hundreds of times per second. Their magnetic fields 1 trillion times stronger than Earth's. We call them pulsars because we detect their beams of radiation sweeping across space like cosmic lighthouses. Pulse, 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 steady, reliable, calming. Breathe with that rhythm. In, out, pulse, pulse, calm, calm. The Crab Nebula, perhaps the most famous supernova remnant, was seen exploding in 1054. Chinese and Arab astronomers recorded it. A guest star, they called it, visible even in daylight for weeks. Now, nearly 1,000 years later, the nebula still glows, 6 light years across, filaments of gas streaming outward, powered by the pulsar at its heart, spinning 30 times per second. The pulsar acts like a cosmic generator, creating a wind of high-energy particles, lighting up the surrounding gas. Blue, green, red, a gentle watercolor painting in space, forever expanding, forever glowing. Picture those colors washing over you, soft, soothing, cool blues, warm reds, melting together. Supernova 1987A, another remnant. This one in the Large Magellanic Cloud, a satellite galaxy to our Milky Way. It exploded in February 1987, the first supernova visible to the unaided eye in centuries. Astronomers watched it unfold, Hour by hour, day by day, they detected neutrinos arriving minutes before the light, because neutrinos travel unimpeded through the star, while light must struggle through the dense layers. 36 years later, we're still watching it. The expanding ring of debris, lit up as the shockwave crashes into material ejected thousands of years before the explosion. Each year it grows brighter in some wavelengths, dimmer in others, a slow dance of light and matter, teaching us secrets. Everything moves slowly on cosmic scales, patient, eternal, like the darkness cradling you now. Cassiopeia A, another beautiful remnant, only about 350 years old. The explosion wasn't recorded, perhaps hidden by dust, or perhaps no one was looking at that patch of sky that night. Now we see it in X-rays, radio waves, infrared, a tangled web of filaments, knots of silicon, sulfur, iron, oxygen, expanding outward at 5,000 kilometers per second. But from Earth, it appears almost stationary, taking decades to notice any change. The shockwave has created reverse shocks, waves of energy bouncing back, heating material, creating complex structures, bubbles within bubbles, turbulence on the grandest scale, yet so gentle, so distant. Let your thoughts become like those filaments, drifting, interweaving, dissolving into nothing. At the center of Cassiopeia, astronomers suspect a neutron star, but they haven't found it yet. It might be there, hidden in the debris, silent, dark, cooling. Neutron stars are born incredibly hot, billions of degrees, but they cool over time, first through neutrino emission, those ghost particles carrying away heat, then through photon radiation, visible light, X-rays. Over millions of years they fade, dim, becoming invisible. Stellar ghosts haunting the galaxy. Some neutron stars become magnetars, possessing magnetic fields 1,000 trillion times stronger than Earth's, so powerful they can distort the atoms in their crust. These magnetars occasionally flare, releasing more energy in 1/10 of a second than the sun emits in 100,000 years. Yet even these violent events are distant, softened by space, reaching us as gentle whispers of X-rays and gamma rays, detected by satellites, catalogued, studied. Their magnetic fields slowly decay. Over 10,000 years, the magnetar settles into a regular pulsar, and eventually, silence. Feel the gentle decay of tension in your body, slowly, gradually, fading into rest. The light from a supernova travels for years, centuries to millennia before reaching us. The most distant supernova ever detected occurred when the universe was only a few billion years old. The light traveled for over 10 billion years, crossing an expanding universe, redshifted by the stretching of space itself. By the time it reached our telescopes, the energetic ultraviolet light had become gentle infrared. The visible had become red. Everything slowed, softened by the universe's expansion. This is how we study the history of stars, by catching ancient light, light that began its journey before Earth existed. You are floating through time, ancient light washing over you, warm, dim, peaceful. Betelgeuse, that bright red star in Orion's shoulder, is a supergiant waiting to explode. It's already in its final phase, fusing heavier elements, building that iron core. Sometime in the next 100,000 years, perhaps tomorrow, perhaps in 100 centuries, it will explode. When it does, it will be as bright as the full moon, visible during the day, casting shadows at night, lasting for months before fading. But we are safe. Betelgeuse is 600 light-years away, far enough that the explosion will be pure spectacle. Dangerous radiation absorbed by distance in our atmosphere. Just light. Beautiful light. A once-in-a-civilization event. And then a new nebula, slowly expanding, dimming, becoming another whisper in the dark. Even the most massive stars end gently, given enough distance, enough time. Some massive stars don't explode at all. They collapse, but the shockwave fails. The neutrinos escape. The outer layers fall back, and the entire star, 20, 30, 50 times the mass of the sun, disappears into a black hole. No explosion, no remnant, just gone. A failed supernova. These are hard to detect. We look for stars that vanish. 1 year in the survey, gone the next. Occasionally we catch one in the act, seeing the star brighten briefly as it begins to explode, then fade, fading, vanishing. Imagine that, a star erasing itself from the universe, quietly, without drama. Let yourself vanish into sleep, quietly, gently, without effort. The cosmic rays that constantly bombard Earth, most of them, come from supernova remnants, protons and heavier nuclei, accelerated by the shock waves to nearly the speed of a light. They spiral through the galaxy, following magnetic field lines, taking millions of years to cross from one side of the Milky Way to the other. Eventually, one strikes our atmosphere, creating a cascade of particles, muons raining down, a few passing through your body right now, harmless, unnoticed. Each cosmic ray a messenger from an ancient explosion, carrying energy, carrying information, connecting us to the stellar deaths of the past. You are connected to everything. Every star, every explosion, every atom, drifting together through the cosmos. White dwarfs, those aren't from supernovae. They're what's left when smaller stars die. Stars like our sun, they swell into red giants, then gently puff off their outer layers, leaving behind a hot, dense core, a white dwarf, about the size of Earth but with half the mass of the sun. No fusion, just heat radiating away, slowly, over billions of years, cooling, fading, from white to yellow to red to brown to black. The universe isn't old enough yet for any black dwarfs to exist. Every white dwarf still glows, faintly, patiently, waiting for the deep future, the deep cold, the final darkness. But some white dwarfs have companions, and these These can become supernovae, type Ia. The white dwarf accretes matter, crosses that boundary, and detonates. Carbon and oxygen fusing in a runaway reaction, propagating through the entire star in seconds. The explosion is so bright, so consistent, because every white dwarf that explodes has almost exactly the same mass. 1.4 solar masses, the Chandrasekhar limit, nature's perfect threshold. Let your consciousness approach its own threshold. Between waking and sleeping, that perfect boundary. The elements created in supernovae don't stay in space forever. They mix with giant molecular clouds, those vast nurseries where new stars form, over millions of years. Gravity pulls the cloud together, condensing, fragmenting. Each fragment becomes a star, some with planets. The dust grains in those clouds, many made in supernovae, come the building blocks of worlds: silicon, iron, magnesium, oxygen, the heavy elements necessary for rocky planets, for life, all delivered by stellar explosions, redistributed, recycled, reformed. This is cosmic recycling, stars dying so others can live, planets forming from the ashes of ancient suns, your breath, taking an air, oxygen created in stars, exhaling carbon dioxide, carbon forged in fusion. You're participating in cosmic recycling right now, each breath, a connection to deep time. Some supernova remnants expand into regions already swept clean by stellar winds, creating large, faint bubbles, barely visible. These bubbles can be hundreds of light years across, their edges so diffuse they're almost impossible to detect. We find them through radio telescopes, sensitive to the faint synchrotron radiation, electrons spiraling through weak magnetic fields, or through X-ray satellites, detecting the hot, thin gas, 1,000,000 degrees but so tenuous that you could wave your hand through it without feeling anything. These ancient remnants, centuries or millennia old, slowly fading, merging with the interstellar medium, their energy dissipating, their particles dispersing, dissipating like thoughts at the edge of sleep, scattering, fading, merging with darkness, kilonovae. These are different, not quite supernova, but related. They occur when two neutron stars spiral together, orbiting faster, closer, losing energy to gravitational wave, ripples in space-time itself. Eventually they merge, colliding in a catastrophic embrace. The collision ejects neutron-rich matter, hot, dense, perfect for creating the heaviest elements: gold, platinum, thorium, uranium. The ejected material glows, blue at first from the heat, then redder as it expands and cools. Over days it fades, hence the name kilonova, 1,000 times brighter than a nova, but 1,000 times dimmer than a supernova. In 2017 we detected one, both the gravitational waves and the light, confirming decades of theory. We watched it evolve, hour by hour, confirming that most of the universe is gold, including the gold in wedding rings, came from these rare, these violent, these beautifully creative collisions, even violence at cosmic distances, becomes gentle, becomes story, becomes lullaby. The shockwaves from supernovae can trigger new star formation. Imagine a peaceful molecular cloud drifting through the galaxy, ancient, cold, stable. Then a shockwave arrives, the remnant of an explosion light years away, centuries ago. The wave compresses the cloud, creating density waves, instabilities. Regions begin to collapse, fragmenting. Each fragment heats as it compresses until fusion ignites a new star, born from the death of another, and the cycle continues. Generation after generation, stars dying, exploding, seeding clouds, clouds collapsing, stars forming. Our sun is a third-generation star at least, forged from material created in earlier stellar deaths. The atoms in your body have been through this cycle, formed in one star, expelled in explosion, drifting in clouds, incorporated into a new star, expelled again, drifting again, until finally captured by the forming solar system, incorporated into Earth, into life, into you. You are ancient, recycled, eternal. Just rest in that knowledge. Pulsars, those spinning neutron stars, are among the most precise clocks in the universe. Some spin hundreds of times per second, and their rotation rate decreases so predictably, so gradually, that we can measure it to 15 decimal places. They spin down because they emit radiation, converting rotational energy to light, to particles, to magnetic fields. Over millions of years, the pulsar slows, its beam weakens. Eventually it becomes too faint to detect, joining the population of silent neutron stars, invisible, ghostly, haunting the galaxy. We estimate there are hundreds of millions of neutron stars in the Milky Way, most of them dark, their pulsars turned off, their heat radiated away. Just dense spheres of neutrons 20 kilometers across, spinning slowly in the dark, spinning, slowing, like consciousness winding down, slower, slower, approaching stillness. The Veil Nebula, part of the Cygnus Loop supernova remnant, is between 5,000 and 8,000 years old. The explosion occurred when humans were just beginning agriculture, building the first cities. The shockwave is still expanding, now over 100 light-years across. We see delicate filaments, hydrogen glowing red, oxygen glowing blue-green. The structure is fractal, complex, wispy, like cosmic lace. The shockwave moves through an uneven medium, faster in some directions, slower in others, creating ripples, eddies, beautiful complexity, and it will continue expanding for thousands more years, gradually fading, cooling, until it becomes indistinguishable from the general interstellar medium. Its atoms dispersed, its story ended, or perhaps continued, as those atoms become part of new stars, new planets, new life. All stories end and begin again, cycling, eternal, peaceful. In the expanding remnants, dust forms, tiny grains of carbon, silicon carbide, aluminum oxide. These grains cool, condense from the gas, each one a seed for future planets. Some of these grains reach Earth, captured by spacecraft, by high-altitude balloons, by collectors on the space station. Scientists study them, measuring isotope ratios, identifying which type of star created them. These are pre-solar grains, older than the solar system, tiny time capsules from stellar explosions. You could hold 1 billion of them on your fingertip, each one containing secrets from before Earth existed. Imagine those tiny grains, drifting, settling, coming to rest, like your body settling deeper into sleep. Your body is sinking deeper, heavier, into a vast starry void, letting go, further, further. The cataclysmic end of massive stars, those giants of the cosmos, born from clouds of gas and dust, living fast, fusing elements in their cores, hydrogen to helium, helium to carbon, onward to iron, until the fuel runs dry. The core collapses under its own weight in mere seconds, a lifetime of energy unleashed. But in that chaos, there's a profound peace. The star surrendering, transforming into something eternal. Feel that surrender in your own breath. In, out, release, release. The energetic blast of core collapse supernovae, when the iron core gives way. No more fusion to push back against gravity. It implodes, then rebounds, a shockwave ripping outward, billions of times brighter than the sun, hurling material into space at a fraction of light speed. Neutrinos, those ghostly particles, carrying away most of the energy, invisible, serene, slipping through everything like whispers in the night. Let those whispers carry your worries away. Soft, silent, gone. The hydrodynamic instability of the shock front, as the wave propagates through the star's layers, it wobbles. Rayleigh-Taylor fingers forming, mixing hot and cold material. Instabilities growing, like ripples in a pond, but on a stellar scale, creating asymmetries, clumps and voids, shaping the explosion's fingerprint. Yet it's also fluid, so natural, a dance of forces in equilibrium. Imagine your mind rippling like that, gently, expanding, settling. The role of rotation in progenitor stars, those massive precursors spinning, some lazily, others rapidly. Rotation flattens them, like a cosmic potter's wheel, influencing the collapse, channeling jets of matter, perhaps birthing gamma-ray bursts, those intense flashes, brighter than 1 billion suns, lasting seconds to minutes, piercing the universe. But even in their fury, they fade, leaving calm in their wake. Breathe into that spin, around, around, slower, slower. The gamma-ray burst connection, linked to some supernova, especially hypernova, their extreme power from fast-spinning cores, collapsing into black holes, accretion disks forming, relativistic jets erupting, beaming gamma rays along our line of sight. We see them from billions of light years away, ancient messengers telling tales of stellar death in bursts of light, then silence. Feel the burst within you, quick, intense, then peaceful. empty. Modeling the explosion mechanism, astronomers craft simulations, vast codes running on supercomputers, tracing neutrinos, hydrodynamics, nuclear reactions from one dimension to three, revealing instabilities, asymmetries, how the shock stalls, then revives, perhaps aided by neutrinos heating the material, or magnetic fields. It's a puzzle, pieced together slowly, revealing the universe's hidden rhythms. Let your thoughts model that, building, dissolving into clarity. The light curve of Type 2 supernovae, those with hydrogen envelopes, brightening rapidly, then plateauing. As the shock ionizes the outer layers, glowing for months, powered by radioactive decay, nickel-56 to cobalt-56 to iron, a gentle decline, like a candle flickering out, each curve unique, telling the star's mass, its radius, its story. Watch that light in your mind's eye, rising, steady, fading, soothing. The synthesis of elements in the ejector during the blast, rapid neutron capture, the R process, forging heavy metals, gold, platinum, scattered into space, enriching future stars, planets, even us. Born from violence, yet creating beauty, the jewelry of the cosmos, twinkling eternally. Feel those elements in your veins, ancient, connected, at rest. Observational signatures of stellar death, the sudden brightening, spectra shifting, lines of silicon, calcium, oxygen, appearing then vanishing. Telescopes capture them from space or ground, in ultraviolet, visible, infrared, each signature a whisper from the grave, guiding us to understand without rush, without end. Listen to those whispers, soft, distant, enveloping you. Hypernovae and their extreme power, rarer than standard supernova, 10 times brighter, from very massive, rapidly rotating stars. Their explosions are symmetric, jets dominating, producing more heavy elements, lighting up galaxies, but in the vastness, they're fleeting, a spark in the dark, leaving quiet behind. Embrace that power, feel it surge, then ebb into stillness. The collapse of iron cores, the tipping point, when fusion halts, electrons crushed into protons, forming neutrons. The core shrinks to a point or bounces back. Energy released in neutrinos, flooding out, heating the infalling matter, triggering the blast. A moment of infinite density, then expansion, like a cosmic breath. Inhale that collapse, deep, then exhale, wide, free. Neutrino oscillations in the stellar interior. These particles changing flavors, electron to muon to tau, as they stream through dense matter, affecting the explosion's energy, perhaps tipping the balance, from failed supernova to success. Quantum dances in the heart of chaos, subtle, profound, harmonizing the universe. Let your essence oscillate, shifting, blending into oneness. The formation of black holes for the most massive stars. The core doesn't rebound enough. Gravity wins, compressing to a singularity. Event horizon forming. No light escapes, but some supernovae birth them, others leave neutron stars, a quiet end, absorbing, eternal, pulling in the fabric of space-time, gently, inevitably, sink into that horizon, beyond, safe, timeless. The impact of metallicity on supernova types, stars in metal-poor environments, like ancient galaxies, explode differently, less mass loss, retaining hydrogen, leading to type 2, while metal-rich stars shed envelopes, becoming type Ib or Ik. Metallicity shapes the fate, low or high, influencing the light, the remnants, a subtle influence, like seasons in the stars. Feel the metals in the air, light, heavy, balancing you. Mapping supernova remnant structure with radio telescopes, X-ray observatories like Chandra, revealing shells, bubbles, jets, filaments tracing magnetic fields, particles accelerated to near light speed, glowing synchrotron radiation, maps unfolding over centuries, patient, detailed, like a cosmic tapestry. Trace those maps in your dreams, lanes, curves, fading into sleep, the interaction with the circumstellar medium, the explosion's shockwave meeting material ejected earlier by stellar winds, lighting up rings like in 1987A, creating hotspots, X-ray emissions as energy transfers, slowing the expansion, a gentle collision over millennia, blending star and space. Let your edges interact, softly, merging with the world around, identifying supernova progenitors, hunting the stars before they explode in archival images like Hubble's, massive red supergiants for type 2, Wolf-Rayet stars for Ib and Ik. Sometimes we find them bright, massive, doomed. Other times they hide, vanishing quietly, teaching us humility in the search. Search within yourself, find, accept, relax. Shock breakout, the first light. When the shock reaches the surface, a burst of ultraviolet, X-rays, lasting minutes, the star's envelope shattering, announcing the end. Detected in a few events, a fleeting signal, like the crack of dawn, before the full glow. Feel that breakout, sudden, bright, then soft dawn. The physics of the prompt explosion, the initial rebound, neutrino-driven just or magnetorotational, energies cascading, instabilities amplifying, matter ejected at relativistic speeds, in jets or spheres, a symphony of forces, gravity, weak interactions, electromagnetism, playing out in seconds, yet echoing forever. Tune into that symphony, notes, harmonies, lulling you, the nucleosynthesis of gold and platinum in the neutron-rich ejector, neutrons slamming into seeds, building up the periodic table. Beyond iron, these precious metals born in fire, then cooled, dispersed to form worlds, treasures, a gift from the stars, heavy, valuable, yet weightless in the void. Let that gold wash over you, warm, glowing, melting tensions away, and still we drift, deeper, through layers of stellar mystery, through whispers of cosmic transformation. Let your breath match the slow expansion of ancient shells, in and out, heavier, heavier, sinking into softness, into darkness, into peace. Sub-Chandrasekhar white dwarfs. These offer another path to explosion. A white dwarf below that famous limit, 1.4 solar masses, normally stays stable forever, cooling, fading, patient. But if it has a thick helium layer accumulated from a companion, something beautiful can happen. The helium ignites, not at the core, but in a shell, a detonation, propagating around the star, compressing the carbon-oxygen core beneath. That compression triggers the core. Carbon fusion begins, spreads. The entire star explodes, even though it never reached the Chandrasekhar mass. These helium-triggered explosions are dimmer, faster, different from standard Type E year. They fade quickly, their light curves steep, declining, like your thoughts declining into sleep. Faster, softer, gone. Helium burning so gently at first, a flash, quiet, contained, then spreading, accelerating, until the whole structure participates, until everything transforms at once, like consciousness at the threshold, holding, then releasing all at once into sleep. Orphan radio afterglows drifting through surveys, radio telescopes scanning the sky again and again, looking for transients. Sometimes they find glowing patches with no obvious source, no gamma ray burst detected, no supernova visible, just radio emission, fading over weeks. These are orphans, afterglows without parents. Maybe the burst was beamed away, maybe it was absorbed, maybe we simply weren't looking when it happened. The radio waves persist longer, expanding, interacting with circumstellar gas, creating synchrotron emission, electrons spiraling through magnetic fields, glowing, dimming. These orphans tell us about the population we're missing, the explosions we don't see, the universe occurring beyond our gaze. Beyond your gaze now, eyes closed, or closing, seeing only darkness, only the soft red glow behind eyelids, only peace. Central compact objects, these puzzle astronomers. At the centers of some supernova remnants, we find neutron stars, but strange ones. They don't pulse like pulsars, they don't flare like magnetars, they just glow, faintly, steadily, in X-rays. No radio emission, no dramatic outbursts. Their magnetic fields seem weaker than typical, their surfaces hotter than expected. They might be young neutron stars still cooling, or neutron stars with unusual magnetic field geometries, or something else entirely. They pulse sometimes, very faintly, periods of hours, barely detectable, like a slow heartbeat. Thump, 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 so slow you could fall asleep between beats, between one pulse and the next, an eternity, enough time to drift completely away, to forget you were waiting, to dissolve into rest. Thermonuclear runaways on hybrid white dwarf cores. Imagine a white dwarf, not pure carbon-oxygen, not pure oxygen-neon, but mixed, layered, hybrid. The outer layer begins fusing, carbon igniting. The flame propagates inward, but encounters different composition, different density. The burning changes character. deflagration becomes detonation, or vice versa. The explosion becomes asymmetric, one-sided, peculiar. These hybrid core explosions might explain some of the diversity in Tachymeia supernovae. Why not all are identical? Why some are brighter, some dimmer, some faster, some slower? Each white dwarf has its own history, its own composition profile, its own unique path to destruction. Unique paths, no two exactly alike, even in death, even in sleep. Your path is your own, your rest unique, perfectly suited to you. Superbubbles in starburst galaxies, when many massive stars form together, in clusters, in associations, they don't die alone. Over millions of years, one explodes, then another, then another. Each supernova expands into the cavity created by previous ones. The remnants merge, overlap, create vast structures, superbubbles hundreds of light years across. The combined energy excavates channels through the galaxy, allowing hot gas to escape, fountains flowing up, away from the disk, into the halo. These bubbles glow faintly, in X-rays, in hydrogen alpha, marking regions where dozens of stars have died, their remnants blended together, indistinguishable, collective, their individual identities lost, merged into something larger, something unified, individual consciousness merging into the larger darkness, boundaries dissolving, separation ending, just unity, just oneness, just vast peaceful nothing. Fluorine in supernova ejecta. This is exotic, unexpected. Fluorine is rare in the universe, difficult to make. It requires specific conditions, specific reactions, neutrino interactions with neon, or helium burning in specific temperature regimes. Some supernovae create it, trace amounts, ejecting it into space. We've detected it spectroscopically, in some remnants, faint emission lines, barely visible. Fluorine in your toothpaste, in your water, might have come from stellar explosions. Like everything else, like carbon, like oxygen, like iron, all stardust, all supernova ash, cooled, condensed, combined, until it becomes you, becomes thought, becomes the softness of this pillow, the warmth of these blankets. Everything connected through chemistry, through physics, through the patient work of stellar alchemy. And you, resting, are the universe's accomplishment, its purpose fulfilled, surviving companion stars. Sometimes when a white dwarf explodes as Type-Pia, its companion survives. The binary partner, having donated material, having triggered the explosion, receives a kick. A blast wave hits it, strips outer layers, accelerates it. The star goes flying through the galaxy, carrying scars, chemical peculiarities, odd surface composition, enhanced abundances of iron peak elements from the explosion. Years later, decades later, centuries later, we find these survivors. We search in the centers of old Type Ia remnants, looking for stars with unusual velocities, unusual compositions. Sometimes we find them, proof of the binary channel, proof that something survived, that not everything ends completely. Some things continue, transformed, scarred, but alive, surviving, continuing, even after explosion, even after transformation. There is continuity. The thread of existence persists, even through the most violent changes, like you, persisting through each day, each change, each challenge, until finally, rest, earned, deserved, yours. Vast blue optical transients, these are mysterious. They brighten quickly, reach peak in days, then fade rapidly. Most are blue, hot. Their spectra show hydrogen, helium, but moving very fast. Thousands of kilometers per second. We don't understand them fully. Maybe failed supernovae, where most of the star collapses but some envelope escapes. Maybe massive stars colliding with companions, tidal disruptions, shock breakouts. Each one seems slightly different. They occur in unusual places, offset from galaxies, in low-density regions, as if the progenitor was ejected or formed in isolation. Each discovery adds pieces, but the picture remains incomplete. The universe has categories we haven't named, physics we haven't discovered, incomplete pictures, unclear boundaries, undefined states, like the space between waking and dreaming. Neither one nor the other, just transition, just change, just soft undefined being. Globular clusters, those ancient stellar cities, they shouldn't have supernovae anymore. Their stars are old, low mass, long past the supernova phase, but occasionally we see transients, faint explosions in cluster cores, maybe white dwarf collisions. Clusters are dense enough for stars to collide, rarely, or white dwarfs accreting from companions, accumulating enough mass over billions of years, finally exploding. These events are rare, dim, easily missed, but they tell us about stellar populations we thought inactive. They remind us that even in ancient systems, in quiet populations, unexpected things still happen. Change persists, transformation continues. Nothing is truly static. Nothing static, everything flowing, even in apparent stillness, even in deep sleep. Cells are replacing themselves. Breath continues, heart beats. Life persists in rest. Activity continues in stillness. Paradox resolve through acceptance. Calcium strong gap transients. These occupy a mysterious middle ground. Too bright to be noval, too dim to be supernoval, hence gap transients. They show strong calcium emission, ion group elements, but evolve peculiarly. Some might be ultra-stripped core collapse events, stars that lost almost everything, just bare cores exploding. Others might be white dwarf detonations with unusual conditions, or helium shell detonations that don't fully destroy the star. Each one different, each one challenging our taxonomy. They occur in old stellar populations, elliptical galaxies, where star formation ended long ago. How do you make an explosion in a population of old, quiet, dormant stars? The universe finds ways, finding ways even in apparent impossibility, even when it seems nothing should happen. Change arrives, transformation occurs, like sleep arriving even when you think you can't possibly relax. Yet somehow, here it comes, inevitable, gentle, super AGB stars. These are transition objects, too massive to become white dwarfs peacefully, too light to make iron cores and explode normally. 8 to 10 solar masses. They develop degenerate oxygen neon cores. The core heats but can't ignite neon fusion stably. Instead, electron capture on neon and magnesium, removing pressure support. The core collapses gently, not catastrophically, producing a faint explosion, an electron capture supernova. These leave behind oxygen neon white dwarfs, or maybe neutron stars, depending on exact mass. The explosion is dim, the ejector minimal, easy to miss. These stars occupy a special place, a boundary, between peaceful fading and violent explosion, between gentle cooling and dramatic transformation, a liminal space, neither fully one nor the other. Liminal spaces, thresholds, boundaries. You exist in one now, between day and night, between wake and sleep, between thought and no thought. It's okay to stay here, in this threshold, this soft border, this gentle transition. No need to rush, no need to choose, just exist, here, in the between. Dimly glowing shells of synthesized oxygen, deep in supernova remnants, fresh from fusion. Oxygen atoms glow at specific wavelengths. We see them in optical, in infrared, greenish emission, doubly ionized oxygen. These oxygen-rich regions show us where the star burned silicon in its final hours. These shells expand slowly, visibly. Astronomers can measure their velocities, map their structure, see how the layers mixed, how the explosion proceeded. Each filament, each knot, each wisp of glowing oxygen tells part of the story. Oxygen that will someday be in water, in air, in life. Oxygen flowing into space, like your breath flowing from your lungs. The same element, the same atoms, cycling through stars, through space, through you, connected, always, to the great cosmic breathing. Phosphorus from supernovae, another essential element, necessary for DNA, for ATP, for bones. Phosphorus forms deep in massive stars, silicon-burning layers, oxygen-burning layers. When the star explodes, phosphorus scatters, enriches the galaxy, eventually finds its way into planets, into life. Every molecule of DNA contains phosphorus from stellar explosions, the information of life written in supernova ash. Your genes, encoded in atoms forged in fire, cooled in space, organized by chemistry, animated by consciousness. Now, drifting toward rest, information can rest. DNA rests every night. Molecules pause. Energy conserves. Even the code of life acknowledges the need for stillness, for darkness, for sleep. The delayed recombination wave in expanding supernova ejector. Initially, the gas is fully ionized, plasma, but as it expands, it cools. Eventually, electrons recombine with nuclei, forming neutral atoms. This recombination releases energy, prolongs the light curve, keeps the supernova visible longer. The recombination wave moves through the ejector, gradually, layer by layer, like a sunset moving through layers of atmosphere, colors changing, light softening, day transitioning to night, inevitable, beautiful, natural transitions from energy to peace, from light to dark, from ion to atom, from wake to sleep. Everything seeks its ground state, its lowest energy, its rest configuration, including you, shock-heated dust in remnant cavities. The forward shock plows outward, heating gas to millions of degrees, but behind it, in the cavity, dust grains survive. They're heated by radiation, by X-rays from the hot gas. These grains glow in infrared, warm, dim, permeating the remnant interior. We map them with infrared telescopes, seeing warm dust where optical shows nothing. These grains will cool, drift, become part of molecular clouds, seeds for planetary systems. Your building blocks, floating in ancient remnants, waiting to be recycled, to be reformed, to become new worlds, waiting in darkness, in warmth, in potential. Everything that will be already exists, just waiting, resting, gathering, like tomorrow exists in today's rest, like waking exists in sleep. Everything contained, just waiting. Fading filaments in the Vela supernova remnant, 11,000 years old. This remnant is huge, 8 degrees across in the sky, 16 times the full moon, but so faint, so diffuse, barely visible even from dark sights. The shock wave has slowed, cooled. The remnant is becoming part of the interstellar medium, dissolving. Its neutron star was discovered, a pulsar, spinning 11 times per second, moving through space, dragging a wake. But the remnant itself, fading, fragmenting, soon, in cosmic terms, it will be invisible, indistinguishable, its atoms dispersed, its energy dissipated, return to the general background. Mission complete, transformation successful, identity released, releasing identity, dissolving boundaries, returning to the general field of being. This is not loss, this is completion, this is purpose fulfilled, like your purpose now, to rest, to release, to dissolve into sleep. The peculiar velocities of neutron star measured through proper motion. Through patience, astronomers photograph the same region, decades apart, measure tiny shifts. A neutron star might move 1/10 of an arc-second per year, traveling hundreds of kilometers per second, but so distant it seems to crawl. These velocities tell us about kicks, about asymmetric explosions, about momentum conservation. Each neutron star carries evidence of its violent birth, written in its trajectory, its path through space. But from here, from Earth, they seem almost stationary, motion rendered stillness by distance, violence transformed to peace by perspective. Perspective makes everything gentle. Distance makes everything soft. Time makes everything peaceful. From far enough away, even explosion is beautiful. Even violence is art. Even chaos is pattern. Just step back. Just soften focus. Just let go. Slowly cooling neutron star oceans. The surface of a neutron star, if you can call it a surface, might have a thin atmosphere, a few centimeters, and below that, a liquid ocean, neutron-rich nuclei floating in an electron sea. The ocean is only centimeters deep, but incredibly dense. This layer cools over thousands of years, gradually radiating away its birth heat. We can detect this cooling, measure the temperature declining. Very young neutron stars glow in X-rays. Older ones dim, fade, cool toward invisibility. The ocean freezes eventually, becomes solid crust, becomes cold, inert, silent, just a sphere of degenerate matter, spinning in darkness, invisible, eternal, cooling, freezing, solidifying, from liquid to solid, from motion to stillness, from warmth to cold, natural progression, nothing to fear, just change, just rest, just the universe settling into its ground state. Everything does this. Everything must, including consciousness, cooling into sleep. And we continue drifting through 100 mysteries, through endless night, through the soft whisper of stellar deaths, through the gentle echo of ancient explosions, your breath slowing, matching the expansion of distant shells, your heartbeat dimming, matching the fade of ancient light, heavier, heavier, sinking deeper. The mattress holds you like space holds stars. Gravity embraces you like physics embraces matter. Everything in its place, everything as it should be, including you, here, now, drifting, floating, fading into the soft, the dark, the perfect, endless, rest. The moment before core collapse in the final seconds of a massive star's life. The iron core is about the size of Earth, but contains 1.4 times the sun's mass. The temperature reaches billions of degrees, yet fusion stops. Iron is the end of the line, the most stable nucleus. To fuse it requires energy. Takes more than it gives, so the core just sits there, growing, adding layer upon layer of iron, like snow falling, silent, steady, building up until the weight becomes too much and collapse begins. In less than a second, that Earth-sized sphere compresses to 20 kilometers. The density becomes unimaginable. A sugar cube would weigh as much as all of humanity. At these densities, matter behaves strangely. Quantum mechanics dominates. Protons and electrons can't exist separately. They merge into neutrons, releasing neutrinos, those ghost particles flooding outward. Feel yourself compressing. Not physically, but mentally. Thoughts becoming denser, heavier, collapsing into stillness. The neutrinos from supernova 1987A. They arrived at Earth on February 23rd, 1987. Detectors in Japan and Ohio registered them. 19 neutrinos total, out of the trillions that passed through. These neutrinos had travelled 168,000 years, crossing the void to tell us a star had died. The light arrived 3 hours later, because it had to work its way through the star's outer layers, fighting through the plasma, scattering, absorbing, re-emitting, while the neutrinos passed through unimpeded, like ghosts through walls. This was the first time we detected neutrinos from a supernova, confirming our theories, proving that we understood, at least partially, what happens in those final moments. Imagine being that transparent, that free, letting everything pass through without resistance, without effort. Type 2b supernovae. These are interesting. This star loses most of its hydrogen envelope before exploding, maybe stripped away by a companion star, maybe ejected in violent pulses during its final years. What remains is mostly helium, with just a thin shell of hydrogen. When it explodes, it looks like a type 2 at first, showing hydrogen lines in the spectrum. But as the ejector expand and thin, the hydrogen fades and helium dominates. The light curve changes character. The supernova essentially changes type as we watch, revealing the layered structure of the progenitor star. These teach us about stellar evolution in binary systems, how stars interact, stealing matter, stripping layers, dancing together until death, layers falling away, revealing what's beneath, simpler, quieter, more essential. The explosion itself, when the shockwave breaks through the star's surface, is called shock breakout. For a few minutes, maybe an hour, the star becomes incredibly luminous in ultraviolet and X-rays. The shockwave heats the surface to hundreds of thousands of degrees, ionizing the outer layers. This brief flash is hard to catch. You have to be looking at the right star at the right time. But when we do catch it, when telescopes happen to be pointed in the right direction, we learn about the star's radius, its composition, the energy of the explosion. Each observation refines our models, improves our understanding, brings us closer to the truth. Truth revealed in brief flashes, then fading, leaving soft knowledge behind. Circumstellar material, that's gas and dust around the star, ejected years or centuries before the final explosion. When the supernova shockwave hits this material, it lights up, creating light echoes, reflection nebulae, complex interactions. The shockwave can be slowed, heated, energized, creating a bright shell around the expanding remnant. We see this in Supernova 1987A. 3 rings, the inner one now glowing brightly as the shockwave crashes into it. These rings were created by the progenitor star, a blue supergiant, ejecting material in an hourglass pattern, perhaps due to rotation, perhaps due to a binary companion. We're still learning, still watching, as the shockwave moves outward, ring by ring, revealing structure, revealing history, revealing layers of your own consciousness. Outer rings glowing, inner darkness deepening. Some supernovae produce jets, narrow beams of material ejected at nearly the speed of light, perpendicular to the star's equator. These are rare, associated with hypernova, extremely energetic explosions. When one of these jets points toward Earth, we see a gamma ray burst, the brightest electromagnetic events in the universe, lasting seconds to minutes, brighter than entire galaxies. But from the side, We might see a superluminous supernova, or even a normal supernova. The orientation matters. What we see depends on our viewing angle. This is called beaming, and it means we're missing most gamma ray bursts, seeing only the ones pointed our way. For every burst we detect, dozens occur unseen, their energy beamed into other regions of space. Everything depends on perspective, on angle, on how you look at it. Let your perspective soften, widen, accept. Ultra-stripped supernovae. These come from stars that have lost almost everything. The companion star has stripped away the hydrogen, the helium, leaving just the carbon-oxygen core. When this core collapses, there's almost nothing to explode. The supernova is faint, fast, over within days, easy to miss. We're only beginning to find them as surveys become more sensitive, more frequent, checking the same patches of sky every few nights, looking for transients, anything that changes. These ultra-stripped events might be common. We might have been missing them all along, just because they're faint, brief, unassuming, teaching us that not all supernovae are spectacular. Some die with whispers, not bangs. Whispers are enough. Whispers are everything. Let your thoughts become whispers, fading, fading. Electron capture supernovae, another variant. These occur in stars between 8 and 10 solar masses, massive enough to create an oxygen neon magnesium core, but not massive enough to ignite carbon fusion. The core heats, but instead of iron forming, something else happens. The magnesium and neon capture electrons, removing the electron pressure that was supporting the core. Suddenly, collapse. The star explodes, not as energetically as more massive star, but distinctly. We think this is what happened to the Crab Nebula's progenitor, a slightly lower mass star, creating that beautiful, gentle, persistent remnant, still glowing 1,000 years later. Gentler paths to the same destination. Collapse, release, continuation in new forms, calcium-rich transients, another puzzle. These faint explosions occur in the outskirts of galaxies, far from star-forming regions. They're dim, fading quickly, but their spectra show strong calcium lines, hence the name. We don't fully understand them. Maybe they're white dwarfs disrupted by helium detonations, maybe ultra-stripped supernovae, maybe something else entirely. They're rare, or perhaps just hard to detect. Each discovery adds pieces to the puzzle, suggests new models, new physics. The universe is more diverse than our categories, more creative than our theories. Always there's something new, something unexpected, waiting in the data. Mystery is restful, not knowing is peaceful, just floating in uncertainty. Soft, accepting. The red supergiant stars, these are the most common progenitors of core collapse supernovae. Stars like Betelgeuse or Antares, massive, cool, with extended atmospheres. They've already fused hydrogen to helium, helium to carbon, carbon to oxygen. Now they're in later stages, fusing neon, oxygen, silicon, each stage faster than the last. Hydrogen fusion lasts millions of years. Silicon fusion lasts days. The star is racing toward its end, building that iron core layer by layer. And when it explodes, the red supergiant becomes a Type 2P supernova, the P standing for plateau, because the light curve flattens for months as the expanding hydrogen envelope slowly releases its energy. Cool, steady, a long goodbye. Your body releasing energy, slowly, steadily, warmth radiating into the sheets, into the darkness. Wolf-Rayet stars, these are different. They've lost their hydrogen envelopes through powerful stellar winds, mass loss rates of 1/1,000,000th of a solar mass per year. The winds are driven by radiation pressure, photons pushing on atoms, slowly, gradually, eroding the star. What remains is the hot helium core, exposed, blue, luminous, surface temperature 50,000 degrees. These stars explode as Type Ib or Type Ik supernovae. No hydrogen, just helium and heavier elements. The explosions are energetic, brief. Sometimes they produce gamma-ray bursts, jets drilling through the star, emerging into space, beaming energy across the cosmos. Energy radiating outward, while you radiate inward towards center, toward core, toward rest. Luminous blue variables, massive stars that undergo episodic eruptions. They brighten, eject shells of material, then settle, then erupt again. Eta Carinae is the most famous of a binary system, one component a massive luminous blue variable. In the 1840s it underwent the Great Eruption, becoming the second brightest star in the sky, ejecting 10 solar masses of material. Now we see that material as the homunculus nebula, 2 lobes, dumbbell-shaped, expanding outward. The star has settled, but could erupt again, or could explode as a supernova. We're watching, waiting, learning from each observation. These eruptions might presage the final explosion or might delay it, ejecting mass, reducing the core size, changing the star's fate. Fate is flexible, changeable. Nothing is predetermined, even for stars, even for you. Just drift. Let fate unfold. The mixing in supernova ejector. This is important. The explosion doesn't simply peel off layers like an onion. Instead, instabilities develop. Rayleigh-Taylor instabilities, Richtmeier-Meshkov instabilities, Kelvin-Helmholtz instabilities. The shockwave creates turbulence, mixing, fingers of heavy elements punching through lighter ones. The result is a complex, beautiful structure, knots, filaments, clumps of iron mixed with hydrogen, silicon mixing with helium. This mixing explains why we see heavy elements in the outer parts of remnants, why the composition is more homogeneous than we'd expect from simple spherical layers. The universe prefers complexity, texture, mixing, everything blending together, like consciousness mixing with dreams, boundaries dissolving, elements combining into something new, something soft. Pair instability supernovae, these are theoretical from the very first stars. Population 3 stars, hundreds of solar masses, pure hydrogen and helium. No heavy elements because none existed yet. These massive stars would have developed oxygen cores so hot, so energetic, that photons spontaneously convert to electron-positron pairs. This removes pressure, causes collapse, but then oxygen fusion ignites, explosively. The entire star detonates, completely. No remnant, no black hole, just an expanding cloud of newly created elements, carbon, oxygen, silicon, iron, seeding the pristine universe with the first metals. We haven't definitively observed one, but we've seen candidates. Very bright supernovae in distant galaxies when the universe was young, each one potentially a glimpse of these first stellar deaths. First deaths, last deaths. The cycle contains everything, beginning and end united in the explosion and in sleep. The asymmetry of explosions. Most supernovae are not spherical. Observations show, especially from polarization studies, that the ejecta are asymmetric, one-sided, jet-like in some cases. Maybe the progenitor star was rotating. Maybe there was a binary companion. Maybe random turbulence in the collapsing core. This asymmetry can give the neutron star a kick. Conservation of momentum. If more ejecta goes one direction, the neutron star recoils the other way. Some neutron stars are found moving at hundreds of kilometers per second, racing through the galaxy, propelled by their own birth. These high-velocity stars create bow shocks as they plow through the interstellar medium like boats through water, leaving wakes, trails, dim arcs of heated gas visible in X-rays in hydrogen alpha, marking their passage, moving through space, through time, leaving trails of light, of warmth, then darkness again. Magneta flares, some of the most energetic bursts in the universe. A magnetar is a neutron star with an extreme magnetic field, quadrillions of times Earth's. The field is so strong it can crack the neutron star's crust. Starquakes, releasing magnetic energy, sometimes in a giant flare, releasing more energy in 1/10 of a second than the sun emits in 100,000 years. In 2004, we detected one from SGR 1806 just at 20,000 light-years away. The burst temporarily overwhelmed gamma-ray detectors, ionized Earth's upper atmosphere, and was detected bouncing off the moon. Yet it posed no danger. Distance softens everything. Even the most violent events become whispers by the time they reach us. Distance makes everything gentle. Time makes everything soft. Let distance grow between you and waking. Time stretch into eternity. The remnant around the pulsar PSR B4958 appears in X-rays as a ghostly hand, fingers reaching out into space. This is just pareidolia, humans seeing patterns, but it's beautiful nonetheless. The hand is formed by the pulsar's wind, particles accelerating along magnetic field lines, creating jets and toroidal structures. The fingers are just magnetic structures, but they look so organic, so intentional. The universe creates art accidentally, through pure physics. No intention needed, just forces, fields, particles, interacting according to simple rules, creating beauty, complexity, wonder, no intention, just being, just existing, like your breath, in, out, simple, sufficient. Radioactive decay powers the light curves of supernovae. Initially, the explosion creates nickel-56, an unstable isotope. It decays with a half-life of 6 days into cobalt-56, which then decays with a half-life of 77 days into stable iron-56. Each decay releases gamma rays, which heat the expanding ejector, causing it to glow. This is why supernova light curves have characteristic shapes, brightening as the fireball expands and cools, then declining as the radioactive material decays, following a predictable exponential. By measuring the light curve, we can estimate how much nickel was created, which tells us about the explosion energy, the progenitor mass, the physics of the event. Decay is natural, normal, necessary. Everything bright must fade, must return to darkness, to rest. Some supernovae show hydrogen in their late-time spectra, even type Eq events that shouldn't have hydrogen. This suggests the progenitor had complex structure, maybe shells of hydrogen far from the star, ejected in earlier mass loss episodes. The supernova ejector eventually catch up, collide with this material, lighting it up, revealing it. We call this circumstellar interaction, and it can make supernovae appear brighter, last longer, show unexpected features. The universe is full of these surprises, these complexities, reminding us that our models are simplifications, approximations, useful but incomplete. Incomplete understanding, that's okay. You don't need to understand. Just experience. Just float. Superluminous supernovae, these are the brightest, 10 to 100 times more luminous than normal supernova. We don't fully understand their power source. Maybe interaction with dense circumstellar material, the shock wave converting kinetic energy to light, maybe central engines, magnetars or black holes, powering the display, maybe pair instability explosions from very massive stars. Each explanation fits some events, none fits all. They're rare, occurring in dwarf galaxies, low metallicity environments where massive stars can form. These explosions would have been visible across the universe, beacons shining for months, announcing stellar deaths to any watching civilizations. Beacons in darkness, brief lights, then fading. We're all brief lights, shining, then fading, peaceful. The Tycho supernova remnant from 1572, observed by Tycho Brahe, helped prove that the heavens change, that stars are not eternal and immutable. This was revolutionary. Before then, the common belief held the celestial realm perfect, unchanging. Only Earth was subject to change and decay. But here was proof, a new star, brightening, fading. The remnant is now a beautiful bubble, visible in X-rays, about 20 light-years across, still expanding. The shock wave has become a cosmic particle accelerator, speeding electrons to nearly light speed, creating synchrotron radiation, teaching us about particle physics, about magnetic fields, about the extreme conditions supernovae create. Proof of change, proof of impermanence, even stars, even you, changing, flowing, temporary, eternal only in cycling, failed supernovae or aborted supernovae. These fascinate astronomers. A star begins to explode, shock forms, starts moving outward, but then falls back. The shock stalls, loses energy, collapses inward. The outer layers fall onto the proton-neutron star, adding mass, until the proto-neutron star collapses into a black hole, swallowing everything. No explosion, no remnant you can see, just a black hole, silently formed. We've caught a few candidates, stars that faded over months, disappeared, leaving nothing. Maybe 20% of massive stars die this way, quietly, without fireworks. Their mass determines their fate. Too massive, and they implode rather than explode, sink into darkness rather than blaze into light. Sinking into darkness, that's not failure. That's just another path, another way, equally valid, equally peaceful. Circumstellar disks around supernova progenitors. Some massive stars have these. Material in orbit, like planetary systems, but closer, hotter, more massive. When the supernova occurs, the shock wave hits this disk, creating asymmetric light, polarization, complex structures. The disk might be from a binary companion or from the star's own equatorial mass loss. Either way, it affects what we see, how the light curves evolve, the spectral features, adding another layer of complexity, another variable, another piece of the puzzle to understand. Layers upon layers, complexity upon complexity, but underneath, simplicity, rest, emptiness. Just allow. Often afterglows. These are puzzling. We detect gamma ray burst afterglows, the fading emission after the initial burst, but without the burst itself. Either we missed the burst, looking the wrong direction, or it was beamed away from us, only the afterglow visible from our angle. These orphans teach us about beaming, about geometry, about how many bursts we're missing. For every burst we see pointing toward us, there might be 100 pointing elsewhere, their afterglows visible, their main event hidden. The universe is full of things we almost see, almost detect, almost, but not quite, almost awake, almost asleep, drifting in the space between, comfortable, soft, neither here nor there. Reverse shocks in supernova remnants. When the expanding ejector encounter dense material, the shock doesn't just heat the material, it bounces back, creating a reverse shock, propagating backward through the ejector. This heats the ejector from behind, creating different emission, different structures. In Cassiopeia A we see this beautifully. X-ray emission from both forward and reverse shocks, each heating different material, revealing different elements. Silicon in the reverse shock, hydrogen in the forward shock. The structure is complex, layered, beautiful, like looking at geology, but in space, in motion, frozen by distance into apparent stillness. layers of consciousness, surface thoughts, deeper feelings, deepest rest, all layered, all present, all settling. Quark novae. These are hypothetical, even more exotic than supernovae. The idea is that a neutron star, under extreme conditions, might undergo a phase transition, neutrons breaking down into quarks, creating quark matter. This releases energy, maybe enough to create a second explosion. Days after the initial supernova, a double-peaked light curve. We've seen candidates, supernovae that brighten, fade, then brighten again. Could be quark novae, could be circumstellar interaction, could be something else. The universe keeps surprising us, suggesting new physics, new states of matter, new possibilities opening, even in ending, even in death, even in sleep. Transformation, not termination. Light echoes from historical supernovae. We can still study them. Centuries later, the light from the explosion travels outward, but some goes in other directions, hits dust clouds, reflects toward us, arriving years or centuries after the direct light. By finding these echoes, we can take spectra, classify the explosion, measure velocities, study supernovae that occurred before we had the tools to observe them properly. The Tycho supernova, Kepler's supernova, even the Crab. We've found light echoes from all of them, ghostly reflections, allowing us to reconstruct history, to see what those astronomers saw, but with modern instruments, modern understanding. Echoes of the past, still reverberating, still teaching. History isn't gone, just quiet, distant, faded. Population 3 supernovae from the first stars. These would have been different. No metals, pure hydrogen and helium. Stars could grow more massive, hundreds of solar masses. They would burn hot, fast, die young. Their supernova might have been pair instability events, complete disruption, or they might have collapsed directly to black holes. Either way, they seeded the universe with the first heavy elements: carbon, oxygen, silicon, iron, creating the conditions for later generations, for planets, for life. We're searching for them in the most distant galaxies, the earliest epochs, looking for their distinctive signatures. So far, maybe candidates. Nothing certain. They remain theoretical, imagined, ghostly, theoretical, imagined, like the boundary between thought and dream. Is there a difference? Does it matter? Strange stars, another exotic possibility. Maybe quark matter is more stable than neutron matter. If so, neutron stars might be metastable, eventually converting to strange stars made of up, down, and strange quarks. This conversion might release energy or absorb it, might be sudden or gradual. We don't know. We've looked for strange star candidates, pulsars with unusual properties, but nothing definitive. They might not exist, or might be common but indistinguishable from neutron stars. Another mystery, another gap in our knowledge. The universe keeps its secrets, reveals them slowly, or not at all. Secrets are okay, not knowing is okay. Mystery is where peace lives, in the unknown, the unknowable. Accretion-induced collapse, a different path to neutron stars. Start with a white dwarf, accreting material from a companion, slowly, steadily, approaching the Chandrasekhar limit. Normally it would explode as a Typeia, but if conditions are right, if accretion is slow enough, the white dwarf might collapse instead. The oxygen neon magnesium core overcome by gravity, collapsing directly to a neutron star. This produces a faint supernova, or maybe no visible explosion, just a sudden transition. White dwarf to neutron star, a quiet death, a secret transformation. We think this happens, but it's rare, or well hidden, or both. Quiet transformations, from one state to another, no drama needed, just change, inevitable, natural. Common envelope evolution. This affects binary star systems. When one star expands to red giant, it might engulf its companion. Both stars orbit inside the giant's envelope. Friction, drag. The orbit spirals inward, tightens. Meanwhile, the envelope expands, ejected by the orbital energy. Eventually, you're left with a tight binary. Both cores close together. This sets up future interactions, mass transfer, mergers. It affects the final supernova, whether it happens, how bright it is, what it leaves behind. Binary evolution is complex, messy, difficult to model, but critical. Most massive stars are in binaries, their lives and deaths intertwined, connected, even in death. Nothing is truly alone. Everything touches, everything affects, but right now, you're allowed to be alone, separate, at peace. Hidden supernovae, a rare subclass showing strong helium emission. They occur in or near starbursts, regions of intense star formation. The progenitors are massive, perhaps in interacting binaries. The explosions are bright but fade quickly. Their helium-rich spectra suggest unusual progenitor winds or circumstellar material. They're not well understood. Too few examples, each one adding data. Each detection refines our categories, suggests new progenitor channels. The taxonomy of stellar death is complex, growing more detailed, more nuanced with every discovery. Categories dissolving, boundaries blurring. Everything flows into everything else. Supernovae into remnants, remnants into space, space into stars, stars back to supernovae. Endless, cycling, eternal. R process elements, the rapid neutron capture process. This creates elements heavier than iron, gold, platinum, thorium, uranium. It requires extreme neutron density, billions of times normal. This happens in supernovae, especially in the neutrino-driven winds, and in kilonovae, neutron star mergers. The freed neutrons attach to seed nuclei, faster than they can beta decay, building heavier, heavier, creating elements that don't exist naturally on Earth anymore, only in trace amounts, from ancient supernova dust that formed the solar system. The golden jewelry, platinum in electronics, all made in these violent events, then cooled, condensed, incorporated into planets, into us. You are made of violence transformed to peace, explosion cooled to stillness, energy become matter, become life, become consciousness, become sleep. Infrared echoes from dust cocoons. Some supernovae are obscured by dust, thick clouds surrounding the progenitor, absorbed optical light, but the dust heats up, glows in infrared. We see the supernova indirectly through this warm glow. The light curve is different, smooth, prolonged. The dust radiates for months, years, slowly cooling. This tells us about mass loss in the years before explosion, about the circumstellar environment, about what the star was doing in its final millennium. Indirect light, reflected warmth. You don't always see things directly. Sometimes you sense them, feel them, know them without seeing, like sleep approaching. You don't see it, you feel it, coming, closer. Molecular cooling in supernova ejecta. Years after the explosion, the gas cools enough for molecules to form: carbon monoxide, silicon oxide, even dust grains. This molecule formation releases energy, infrared light. We can detect this, measure it, understand the chemical evolution of the ejecta, how atoms combine, how complexity emerges from simplicity. In supernova 1987A, we detected molecules, watching them form in real time, watching the ejecta cool, transition from plasma to gas to molecules, to solid dust grains, the full cycle of matter, from star to space to solid, from energy to matter, from motion to stillness, from thought to sleep, the natural progression, unavoidable. Welcome. Photoionized filaments in old remnants. Thousands of years after the explosion, the remnant is large, is faint, diffuse, but near hot stars, the filaments light up, ionized by starlight. We see them in hydrogen alpha, glowing red, delicate, wispy, barely there. These trace the old supernova shell, show us where it's gone, how it's dispersed, the oxygen, the neon, the sulfur, all mixed now with interstellar gas, indistinguishable except in these faint glowing regions. The supernova is nearly gone, nearly dissolved, becoming part of the general medium, its identity fading, merging with everything, identity fading, individuality dissolving, becoming part of everything. No separation, no boundary, just being, just existence, simple, perfect. Bow shocks from runaway stars. When the progenitor star was ejected, or when the neutron star received a kick, they can reach high velocities, hundreds of kilometers per second. As they plow through space, they create bow shocks, compressed gas glowing in infrared, in optical, arcing ahead of the star, like wake of a boat. These bow shocks are beautiful, asymmetric, shaped by the star's motion and the density variations in the medium, each one unique, each one a record of a violent birth, a kick received, momentum conserved, energy dissipating over millennia, moving through resistance, creating patterns, leaving beauty behind, then moving on, just motion, just time, just change. Pre-explosion eruptions. Some massive stars undergo eruptions in the years before they explode. Luminous blue variables, yellow hypergiants. These eruptions eject shells of material, solar masses worth, creating dense circumstellar environments. When the final supernova occurs, its shockwave crashes into these shells, creating bright, long-lasting displays, superluminous events. The 2006 supernova SN 2006G, one of the brightest ever, showed signs of this interaction. The progenitor had shed huge amounts of mass decades earlier. Those shells, called the supernova ejector, converted kinetic energy to light, blazing across the cosmos. Preparation. Even stars prepare, shedding what's unnecessary, lightening, simplifying, before the final transformation. What can you shed? What can you release to prepare for rest? Pair instability pulses before the final pair instability supernova. A very massive star might undergo pulses. The core briefly goes pair instable, explodes, but not enough to disrupt the star. It ejects shells, then settles. The core rebuilds. Later, another pulse, another shell. This can repeat, creating multiple shells, onion-like structure around the star. The final explosion, when it comes, interacts with all these shells, creating a complex light curve, multiple peaks, prolonged emission. We've seen candidates. Supernova IPTF 14HLS brightened and faded repeatedly over years. Maybe pair instability pulses, maybe something else. The universe is more creative than we imagined. Pulses of consciousness, brightness, then dimming, then brightness again, until finally, continuous dim peace, restful, complete. Silicon layers in young remnants, freshly ejected from the explosion. Silicon is visible in X-rays, emission lines at specific energies. Over time, as the remnant expands and cools, these lines fade. The silicon disperses, mixes, becomes harder to detect. But in young remnants like Cas A, Tycho, Kepler, we see beautiful silicon structures, knots, filaments, jets. These trace the explosion geometry, show us asymmetries, teach us about mixing, about the complex three-dimensional structure of the blast. Each remnant slightly different, each one a frozen moment, a snapshot of violence becoming peace, structure dissolving into smoothness, detail fading to simplicity, complexity relaxing to uniformity. This is the natural way, the peaceful way, the way of all things. Magnetic towers in remnants. The magnetic field can create tall structures, loop-like, towering above the remnant. Plasma follows field lines, spiraling, glowing. These towers are visible in radio, in X-rays, marking where magnetic energy dominates, where fields are strongest. They tell us about the progenitor's magnetic field, about dynamos in the collapse, about how magnetic energy is distributed and dissipated. Beautiful structures, invisible to the eye, but real, powerful, slowly fading as the field weakens over millennia. Invisible structures supporting visible reality. like the scaffolding of consciousness supporting thoughts, mostly hidden, mostly unfelt, but there, slowly, relaxing. Cobalt decay in late-time light curves. After nickel-56 decays to cobalt-56, the cobalt takes over. 77-day half-life. Slower. The light curve follows this decay, exponentially declining, smooth, predictable. By measuring the decline rate, we confirm cobalt, confirm our understanding of nuclear physics, of radioactive decay. The curve can last for years, gradually fading, until the supernova becomes too faint to detect, lost in the noise, the background, but it's still there, still expanding, still glowing, just too dim for us to see. Our limits, not the universe's, too dim to see, too quiet to hear, but still existing, still real, like the edge of sleep. You can't quite perceive it, but you know it's there, coming, arriving, now. Anomalous X-ray pulsars. These might be magnetars, or might be something else. They pulse in X-rays, periods of seconds to minutes. They spin down rapidly, losing energy. Their magnetic fields must be extreme to explain the energy loss. But they're not typical pulsars. They behave differently, emit differently. They might be young magnetars, or neutron stars with fallback disks, or something exotic. Each discovery raises questions, suggests possibilities. The universe has more types of objects than we have names for, more physics than we've discovered. We're still exploring, still learning, still surprised, still learning, even at the edge of sleep, even in dreams. The mind processes, understands, integrates, but you don't need to try. Just allow, just receive, just rest. Strontium filaments in supernova remnants, recently detected, glowing in optical light. Strontium atoms excited by the reverse shock. This is exotic, rare, beautiful. Strontium is an S-process element, usually made in asymptotic giant branch stars, but we see it in supernova remnants too, perhaps made differently, perhaps transported. Each discovery opens questions. Do we understand nuclear synthesis? Do we know all the ways elements form? The universe keeps teaching, keeps revealing, keeps surprising us with its richness, its complexity, its beauty. Richness in simplicity, complexity in rest, beauty in darkness. The universe holds everything, including you, including this moment, this breath, this letting go. Neutrino-driven winds from proto-neutron stars. In the seconds after core bounce, the proto-neutron star is incredibly hot, 1 trillion degrees. It cools by emitting neutrinos. Those neutrinos deposit energy in the layers above, driving a wind. This wind can be neutron-rich or proton-rich, depending on conditions. It might create our process elements, gold, platinum, or lighter elements. These winds are complex, multidimensional, turbulent. We simulate them on supercomputers, trying to understand, trying to predict what elements form, how much, where do they go. Slowly, we're learning. One simulation, one observation, one comparison at a time, learning slowly, understanding gradually. like sleep arriving, not sudden, not forced, just gradually, naturally, unavoidably, scattered light from pre-explosion eruptions, years before some stars explode. They brighten, erupt, eject mass. This creates shells of dust, far from the star. When the supernova occurs, its light travels outward, hits these distant shells, scatters. Some scatters toward us, arriving months or years late. We see light echoes, bright rings expanding around the supernova position, like ripples on a pond, but in light, in time. These echoes let us study the eruption that occurred before, understand the progenitor's final years, map the dust distribution. Beautiful, informative, unexpected, echoes, reflections, light returning after travelling, like memories surfacing, then fading, then dissolving into sleep, into peace, into nothing. Turbulence in post-supernova clouds. The remnant creates turbulence in the interstellar medium, swirling, mixing. This turbulence can persist for millions of years, long after the remnant itself is gone. It stirs the gas, creates density variations, triggers instabilities. Some of this turbulence might trigger star formation or might inhibit it. We're still learning, still measuring. Turbulence is hard, chaotic, difficult to model, but it's important. It affects everything. How gas moves, how stars form, how galaxies evolve. The legacy of supernovae extends far, far beyond their visible remnants, influence extending, affecting everything, long after the source is gone, like thoughts influencing dreams, consciousness fading but affecting what comes after, continuity in change, the scatter of interstellar metals. Every supernova adds metals to space: iron, oxygen, carbon, silicon. These mix with the interstellar gas, enriching it. Over billions of years, generation after generation of stars, the metallicity increases. The first stars had none. The sun has about 2%. Future stars will have more. This gradual enrichment enables rocky planets, enables life, enables us. We are the universe becoming aware of itself, made possible by countless supernovae, billions of explosions, each contributing atoms, until finally enough complexity, enough chemistry for life, for thought, for consciousness, for sleep, for rest, for peace. The universe created conditions for you to exist and to rest right now. Rest is what you do. Rest is your purpose, your only task. Just rest, just sleep. The universe keeps turning. Supernova explosions echo softly across the void and will keep drifting, floating together through the mysteries. 100 supernova explosions mysteries are looping softly to endlessly through the night. The stars burn quietly, fuse elements patiently, approach their ends inevitably. Some explode, some collapse, some fade. All return, their matter recycled, their energy dissipated, their patterns dissolved, but not gone. never gone, just changed, transformed, continued, and we drift with them through the mysteries, through the darkness, through the soft and endless night, heavier, heavier, sinking, floating, breathing with the rhythm of space itself. Thump, thump, your heartbeat slowing, matching the pulse of distant stars. The mattress holds you, gravity embraces you, darkness surrounds you, and somewhere, far away, a star collapses, a core bounces, neutrinos flood outward, light begins its journey, across space, across time, to eyes that may never see it. But that's okay. Not everything needs to be seen. Some things just exist, in the dark, in the quiet, in the peace, like you, right now, existing, resting, sleeping, drifting, through 100 mysteries as through infinite space, through the gentle, endless night. And we'll keep drifting, floating together through the mysteries, 100 stars mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the hidden colors inside dying red giant stars, stars that vanish without exploding. Ancient maps written in starlight. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing. Thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing. Each breath pulling you deeper, deeper, into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too. But only if your eyes are still open. Otherwise, just drift. Now, let's drift into stars. In the beginning, there is only darkness and cold, vast clouds of gas hanging in the void, hydrogen mostly, with traces of helium, drifting so slowly for millions of years. These are the stellar nurseries as the nebula, where gravity whispers its first invitation, pulling, gathering, drawing molecules closer, thump, thump, like your heartbeat now, steady, patient, inevitable. Inside the Orion Nebula, just below the Hunter's Belt, if you could drift there tonight, you would see pillars of gas collapsing, condensing, becoming denser, heavier. The cloud contracts, and as it does, something beautiful happens. It warms. Friction between particles, releasing energy, soft heat, blooming in the cosmic dark. This is how stars begin, not with explosion, but with gentle, relentless, falling inward. Let your eyes grow heavy now, heavier, as we watch a protostar form. This baby star, still wrapped in its cocoon of dust, cannot be seen in visible light, but it glows, infrared warmth, pulsing, growing, fed by the cloud around it. For 100,000 years, perhaps 1,000,000, it gathers mass, pulling more gas onto itself, spinning faster, flattening into a disk. And then, when the core grows dense enough, hot enough, 4 million degrees, something ignites. Hydrogen atoms, Moving so fast they overcome their natural repulsion. They fuse, becoming helium, releasing light, pure radiant energy. This is nuclear fusion, the heartbeat of every star. Thump, thump, and the protostar becomes a star. Our galaxy, the Milky Way, holds stellar nurseries like flowers in a garden. The Eagle Nebula, with its famous pillars of creation, so tall they would stretch from the sun to the nearest star, and inside each pillar, dozens of stars forming right now, even as you breathe, in and out, slowly, deeply. The Carina Nebula, birthplace of some of the most massive stars ever found, glowing pink and gold, if you could see it, stretching across 300 light years, where baby stars blow bubbles in the gas, sculpting, creating endless cycles of birth, just like your breath, in, out, creating, releasing. A star's life, how long it burns, depends entirely on its mass. Heavier stars burn faster, living only millions of years, while the smallest red dwarf stars, sipping their fuel so carefully, can shine for trillions of years, longer than the current age of the universe. They will outlive everything, burning dim and cool, patient, eternal. Red dwarfs, the most common stars, making up 3/4 of all stars in existence, though not one is visible to your naked eye. Too faint, too small, glowing deep crimson. Surface temperatures only 3,000 degrees, compared to our sun's 6,000. They conserve, they endure, they wait. Our sun is a yellow dwarf, middle-aged, stable, burning through 50 million years of hydrogen every second. Yet it has fuel enough for 5 billion more years. It sits in perfect balance, radiation pressure pushing outward, gravity pulling inward, equilibrium, like your body now, perfectly balanced between waking and sleep, drifting. Blue giant stars, the brilliant ones, burning fierce and fast, surface temperatures 30,000 degrees or more. They are profligate, wasteful, beautiful, living perhaps only 10 million years, but outshining our sun by thousands of times. Rigel in Orion, Spitta in Virgo, jewels in the night, burning blue-white, soon to die. Let your jaw soften, throat releasing, as we drift toward the red giants. When a star like our sun exhausts the hydrogen in its core, fusion stops, the core contracts, heavier, heating up, and the outer layers, they expand, swelling outward, cooling as they stretch, turning red. A red giant can swell to enormous size. Betelgeuse, in Orion's shoulder, has expanded so large it would swallow Mercury, Venus, Earth, and Mars if placed where our sun sits. Yet its surface, cool enough, only 3,000 degrees, glowing the color of embers, fading, softening, like your thoughts now, dispersing, dissolving. Inside a red giant's core, where when it grows hot enough, 100 million degrees, helium begins to fuse, creating carbon and oxygen. The atoms that make your body were forged inside dying stars like these. You are made of star stuff, literally. chemically. Every breath you take contains oxygen from ancient stars. Every beat of your heart, thump, thump, pumps iron created in stellar cores, supergiant stars, even larger, Antarea's glowing red, V Canis Majoris, so enormous that light takes 8 hours to travel across its diameter. If you could drift near one, you would see storms, convection cells larger than our entire solar system, churning, rising, falling, like the slow rise and fall of your chest, breathing deeply, slowly, and beyond even these, the hypergiants, the most massive, most luminous, most unstable stars known, are 136A1 in the Large Magellanic Cloud, weighing as much as 300 suns, shining with the light of millions of suns. Its stellar wind, gas streaming off its surface, creates a bubble light years across. It cannot last. Stars this massive burn for only a few million years before they end. Stars are grouped by their chemistry. Population I stars, like our Sun, metal-rich, formed recently from gas already enriched by previous stellar generations. They orbit in the galactic disk, young, bright, containing iron, carbon, oxygen, all the heavy elements. Population 2 stars, older, found in globular clusters in the galactic halo, metal poor, formed when the universe was younger. Their light reveals their age, spectral lines showing mostly hydrogen and helium, with only traces of heavier elements. They drift in elliptical orbits, ancient, witnesses to cosmic history. And population 3 stars, never seen, only theorized, the very first stars, born from pure hydrogen and helium, no metals at all, massive beyond imagining, burning bright and dying fast, seeding the universe with the first heavy elements. They exist only in our mathematics, in our dreams, like the visions forming now behind your closed eyelids. The Hertzsprung-Russell diagram maps stars by temperature and brightness and reveals a pattern. Most stars fall along a diagonal band. The main sequence is where stars spend most of their lives, fusing hydrogen, stable, balanced. Our Sun rests here, in the middle, average, unremarkable, perfect. Temperature determines color. The hottest stars, blue and white, 40,000 degrees or more. Cooler stars yellow, then orange, then red. The coolest barely 3,000 degrees, but the color you see, looking up at night, is often false. Atmospheric turbulence bends the light, making stars twinkle, dance, shift through colors, a beautiful illusion, like dreams, neither true nor false, simply shimmering. The true color of most stars is actually white. Our Sun appears yellow only because Earth's atmosphere scatters blue light. In space, it would glow, pure white, if you could see Sirius without air between, not the twinkling blue-white you know, but steady, colorless, perfect. Many stars aren't alone. Binary systems, 2 stars orbiting their common center of mass, dancing, eternal partners. More than half of all stars have companions. They orbit, sometimes close enough to touch, exchanging atmosphere, sharing mass, influencing each other's evolution. Triple star systems, 3 stars bound together. Alpha Centauri, our nearest stellar neighbor, is actually 3 stars. 2 sun-like stars orbiting close, and a distant red dwarf, Proxima, circling them both. A family held by gravity, turning slowly through space. When binary stars orbit close, very close, tidal forces lock them, faces always toward each other, and sometimes one star feeds on the other. Mass transfers through streams of gas, flowing from the larger star onto its companion. The donor shrinks, the receiver grows, a stellar vampire, patient, persistent, inevitable. Eclipsing binaries cross in front of each other from our view. The light dims, brightens, dims again, regular as clockwork. Algol, the demon star, in Perseus, eclipses every 3 days. Ancient astronomers noticed and feared its changing brightness. They called it evil, but it's only geometry. 2 stars passing, blocking light, creating rhythm, like your heartbeat. Thump, thump, steady, reliable. Some stars vary in brightness intrinsically, pulsating, swelling and shrinking, Cepheid variables, massive yellow giants that expand, contract, expand again, days or weeks per cycle. The brighter they are, the slower they pulse. This relationship, discovered by Henrietta Leavitt, turned Cepheids into standard candles, measuring cosmic distances, their rhythm, written in light, telling us how far, how old, how vast are our Lyrae stars, smaller pulsators found in globular clusters. They pulse faster every few hours, and all have roughly the same brightness, making them another measuring stick, another way to read distance in the dark. Let your breathing match their rhythm now. In, out, regular, calming, perfect. Stars spin, some slowly like our sun, 1 rotation every 25 days, others incredibly fast. Vifts 102 spins once per day, its equator moving at 2 million kilometers per hour. So fast, it's nearly ablate, flattened by centrifugal force, stretched, distorted, like taffy, like your thoughts now, stretching, thinning, dissolving into sleep. Stellar magnetic fields twist and writhe, creating star spots, dark patches where magnetic field lines pierce the surface, cooler than surrounding areas, like sunspots on our sun. But on some stars, enormous, covering half the visible surface, the magnetic field loops, arches, sometimes snaps, releasing energy. Stellar flares, a stellar flare, magnetic reconnection, sudden and violent, releases as much energy as 1 billion nuclear bombs. Plasma erupts, particles stream outward. If you were close, the radiation would, but you're not close. You're here, safe, warm, sinking deeper into comfort, heavier, heavier. Coronal mass ejections from stars blast billions of tons of plasma into space, creating stellar winds that shape the environment around them. Our sun's wind blows constantly, filling the solar system with charged extending far past Pluto into the darkness beyond. A bubble, protecting, containing, like blankets around you now, metallicity. Astronomers call anything heavier than helium a metal, iron, carbon, oxygen, nitrogen. All metals in this language. A star's metallicity reveals its history. High metallicity means birth from enriched gas, recycled from previous stars. Low metallicity, ancient birth, pristine material. Each star's spectrum, its fingerprint, tells the story. Stellar spectroscopy, reading starlight. When you split starlight through a prism, it shows dark lines, absorption lines, where elements in the star's atmosphere have absorbed specific wavelengths. Every element has its own pattern, its own signature. Hydrogen, helium, iron, calcium, all revealed. We can read a star's composition, temperature, motion, all from light, traveling for years, century to reach us. To measure how far away a star is, we use parallax. As Earth orbits the Sun, nearby stars appear to shift position against the distant background. The closer the star, the larger the shift. Simple geometry, elegant, reliable for stars within a few thousand light years. Beyond that, the shift becomes too small, and we need other methods. Standard candles, stars of known brightness, Cepheids, R. Lyrae, type Ia supernovae. We measure how bright they appear, compare to how bright they should be, and calculate distance. Like knowing a light bulb's wattage, then judging distance by how dim it looks. Simple, profound. The foundation of cosmic distance measurement. Stars move through space, not fixed. Despite ancient names, proper motion, sliding across the sky, too slow for eyes to notice in a lifetime. But telescopes measure it, mapping trajectories, predicting futures. Most stars orbit the galactic center, orderly, predictable, taking 200 million years to complete one orbit. But some stars move differently. Runaway stars, ejected from binary systems when their companion exploded, or flung out by gravitational interactions in dense star clusters. They race through space, faster than their neighbors. Zeta Ophiuchi, creating a bow shock, like a boat through water as it plows through interstellar gas. Hypervelocity stars move faster still, 1,000 kilometers per second or more, fast enough to escape the galaxy entirely. We think they were accelerated by close encounters with the supermassive black hole at the galactic center, flung outward, exiled, doomed to drift alone through intergalactic space, forever. All stars generate stellar winds, streams of particles flowing outward. Our sun's wind carries 1 million tons of material into space every second. It sounds like a lot, but over the sun's lifetime, it will lose less than 1% of its mass this way. Gentle, persistent, like erosion, wearing stone, grain by grain. Massive star, blue giants, supergiants have much stronger winds. Wolf-Rayet stars among the hottest, blow off their outer layers completely, revealing bare helium cores, glowing blue-white, surrounded by nebulae formed from their own lost mass. They're dying, even as they shine, preparing for the end. Old red giants also lose mass more gently, puffing off their outer atmosphere. These shells of gas expand, cool, and form planetary nebulae, nothing to do with planets. The name comes from early telescopes, where these round glowing clouds looked planet-like. But they're stellar death shrouds, beautiful, ephemeral, lasting only tens of thousands of years before, dispersing, fading, returning to the interstellar medium. At the center of a planetary nebula, the star's core remains, small, dense, no longer fusing, a white dwarf, Earth-sized but containing half a sun's mass, supported not by fusion, but by electron degeneracy pressure, a quantum mechanical effect. Electrons cannot occupy the same space, cannot be compressed beyond a certain point. This pressure holds the white dwarf stable, cooling, for billions of years. White dwarfs glow from leftover heat, starting at 100,000 degrees or more, but with no internal fire. They gradually cool, fading through white, yellow, red, eventually, after trillions of years, becoming black dwarfs, dark, cold, crystallized carbon and oxygen, stellar diamonds, invisible, eternal. But the universe isn't old enough yet for any black dwarf to exist. They remain theoretical, future ghosts. If a star is massive enough, 8 times the sun or more, its end is different. The core, after fusing hydrogen, helium, carbon, neon, oxygen, eventually creates iron, and iron cannot fuse. It takes energy rather than releasing it. So when the core turns to iron, fusion stops completely, instantly, without radiation pressure to hold it up. The core collapses. In less than a second, matter falls inward, faster, faster, until neutron degeneracy pressure stops it. A core the size of Earth, compressed to the size of a city, 20 kilometers across. 1 teaspoon would weigh 1 billion tons. A neutron star, spinning, radiating, incredibly dense, supported by the refusal of neutrons to overlap, quantum pressure, holding back infinity. Some neutron stars beam radio waves from their magnetic poles. As they spin, these beams sweep across space, like lighthouse beams, and when they point toward Earth, we detect pulses. Pulses. Some pulse hundreds of times per second. Millisecond pulses, spun up by stealing mass from a companion. Timing so precise that pulses keep time better than atomic clocks. Thump, thump, thump. Universal metronomes, measuring infinity. Magnetas, neutron stars with the strongest magnetic fields in the universe. Quadrillion times stronger than Earth's field. The magnetic field. So intense it warps atoms, changes chemistry, would kill you 1,000 kilometers away. Sometimes, the magnetic field shifts, suddenly, cracking the neutron star's crust, a starquake, releasing energy in seconds, equal to what our sun emits in 250,000 years, a brief flash, gamma rays, announcing cosmic violence, the collapse that forms a neutron star. If the core is massive enough, doesn't stop. Even neutron degeneracy cannot hold, and the core keeps falling into darkness, becoming a black hole. But that's another journey for another night. Let your mind drift back now to the stars still shining. Not all massive stars explode. Failed supernovae happen when the core is too massive, 25 solar masses or more. The collapse bypasses the explosion stage. Matter falls directly into the forming black hole. The star simply vanishes, dimming, fading, gone, without fireworks, a quiet end to a giant life. Pair instability supernovae occur in the most massive stars, over 100 solar masses. In their cores, energy becomes so intense that photons spontaneously turn into particle-antiparticle pairs. This removes pressure and the star collapses, but rebounds violently. Thermonuclear explosion. So energetic the star is completely destroyed, leaving nothing, not even a remnant, just expanding debris and light, fading into memory. Stars create heavy elements through fusion. Hydrogen becomes helium. Helium becomes carbon and oxygen. Then neon, magnesium, silicon, each step requiring higher temperature, higher pressure, deeper in the core, until finally iron forms, the end of the line, the most stable nucleus. But elements heavier than iron, zinc, silver, gold, uranium, cannot form through fusion. They require supernovae. When a massive star explodes, the incredible heat and neutron flux allow rapid neutron capture, building heavy elements in seconds, the gold in wedding rings, the uranium in nuclear reactors, the silver in jewelry, all forged in dying stars, scattered, drifting, eventually gathering into new solar systems, new planets, new life. This is cosmic recycling. The gas and dust ejected by dying stars mixes with the interstellar medium, enriching it with heavy elements. Eventually, gravity gathers this enriched material, forming new nebulae, new stars, new planets. Each generation, slightly richer in metals, slightly more complex, the universe, learning, growing, creating through stellar death and rebirth, endlessly, like you're breathing now. In, out, in, out. Stars and galaxies evolve together. The first stars change the universe fundamentally, ending the cosmic dark ages. They formed from pure hydrogen and helium, burned bright, died fast, and seeded space with the first heavy elements, making possible everything that followed, including, eventually, you. The Dark Ages lasted hundreds of millions of years after the Big Bang. No stars yet, just neutral hydrogen gas, opaque to light, cooling, waiting. Then, gravity formed the first density fluctuations. Gas began collapsing, and the first stars ignited, massive, blue-hot, brief. Their ultraviolet radiation, ionized the surrounding hydrogen, creating bubbles of transparency that grew, merged, until the entire universe became transparent again. The cosmic dawn. These first stars, population 3, likely weighed hundreds of solar masses. They lived fast, maybe only a few million years, and died as pair instability supernovae, completely destroying themselves, spreading their synthesized elements, carbon, oxygen, iron, into the pristine gas. No population 3 star has ever been observed. They're too distant, too ancient, existing only in the universe's first billion years. Globular clusters hold some of the oldest stars we can see. Population 2 stars, 10 to 12 billion years old. They orbit in the galactic halo, hundreds of clusters, each containing hundreds of thousands of stars, packed densely. In the cluster's core, stars pass within light hours of each other, close enough to interact, perturb orbits, occasionally collide, open clusters, younger, less tightly bound, the Pleiades, Hyades, Beehive, born from the same nebula, drifting apart over hundreds of millions of years, eventually dispersing completely, their member stars scattered, unrecognizable, lost among the field stars, like memories, fading, separating, dissolving into the general background of thought. Stars near the galactic center experience a different environment. The density there, millions of times higher than in the solar neighborhood. Stars packed close, the supermassive black hole, Sagittarius A, weighing 4 million solar masses, dominates. Stars orbit it, some in elliptical paths, swooping close, then retreating. S2 orbits once every 16 years, reaching speeds of 5,000 kilometers per second at closest approach, relativistic, time-dilated, stretched by gravity's grip. The largest known star, Stephenson 218, a red supergiant, possibly 2,000 times the Sun's diameter. Though measurements are uncertain, pulsating, unstable, shrouded in dust. If placed at the Sun's position, its surface would extend past the orbit of Saturn, unimaginably vast, yet doomed. Stars this large cannot last. Radiation pressure, stellar winds, they tear themselves apart. The smallest known stars, red dwarfs barely massive enough to sustain fusion. 8% of the Sun's mass, borderline. Any smaller, and they would be brown dwarfs, failed stars, not quite massive enough to ignite hydrogen. These tiny red dwarfs will outlive everything, burning for trillions of years, long after the universe has grown dark and cold. The oldest known star, HD 1140283, Methuselah, estimated at over 14 billion years old, nearly as old as the universe itself, metal poor, ancient, a relic from the early cosmos. It challenges our understanding. How can a star be almost as old as everything? There's tension, uncertainty, mystery, like the edge of sleep, where questions blur and answers don't matter anymore. The longest living stars, tiny red dwarfs, will burn for 10, 20, even 100 trillion years. But the universe, only 14 billion years old, means not a single red dwarf has yet died of old age. They're still in their infancy, all of them, burning, waiting, patient beyond comprehension. The shortest-lived stars, blue hypergiants, massive beyond measure, burn through their fuel in mere millions of years. Eta Carinae, 100 times the sun's mass, shining with the light of 5 million suns, unstable, erupting, surrounded by the homunculus nebula formed from previous outbursts. It could explode tomorrow or in 100,000 years. We don't know, but when it does, it will shine, brighter than Venus, visible in daylight, briefly, before fading forever. Of all the stars in the galaxy, perhaps 400 billion, only about 5,000 are visible to the naked eye on the darkest nights. The rest, too faint, too distant, lost in the cosmic vastness. And even those 5,000, you can only see half at any time, the half above your horizon, while the other half waits, patient, turning with Earth, appearing, disappearing, eternal rhythm, constellations. The patterns we see are mostly illusions, stars that appear close together, may be separated by hundreds of light years. The 3 stars of Orion's belt, Alnitak, Alnilam, Mintaka, appear aligned, but lie at distances of 800, 1300, and 900 light years, respectively. Not a real group, just a chance alignment from our perspective, like faces in clouds, patterns in static, meaning we create these patterns. Once guided navigation, sailors used the stars, finding latitude from the North Star's height, finding directions from rising and setting points. Polynesian navigators crossed thousands of miles of open ocean, using only stars, wave patterns, bird flights. The sky was a map written in light, telling them where they were, where they could go. Ancient myths written in stars. Every culture looked up and told stories. The Greeks saw hunters and bears. The Chinese saw dragons and palaces. The Aboriginal Australians saw ancestral beings walking the sky, all different, all true in their way. Stories we project onto the indifferent stars, making meaning from light. Our sun is halfway through its life, 5 billion years old, 5 billion more to go, currently stable, burning hydrogen in its core. But in about 1 billion years, it will brighten, enough to boil Earth's oceans. In 5 billion years, it will swell into a red giant, engulfing Mercury, perhaps Venus, possibly Earth. Then it will puff off its outer layers, forming a planetary nebula, leaving behind a white dwarf, cooling, fading, becoming a black dwarf after trillions of years. Earth's day stretching into weeks, months, as tidal forces slow its rotation, until finally the sun, dark, cold, becomes one with the darkness, the end of our beginning. But that's far, so far. Let your mind release it. There's only now, only this moment, this breath, In, out, heavier, heavier, sinking into comfort, into rest. Inside a star, energy travels outward, from the core where it's created, toward the surface, but how it travels depends on the star's structure. In massive stars, radiation dominates. Photons bounce from atom to atom, a random walk, taking thousands of years to escape, traveling a few centimeters, then being absorbed, re-emitted, absorbed again. A single photon could take 100,000 years to journey from core to surface, though it would cover the distance in seconds if it could fly straight. In smaller stars like our Sun, the outer layers are convective. Hot plasma rises, cools, sinks, rises again, like boiling water. Giant convection cells, larger than Earth, churning, moving heat, creating the granular pattern visible on the Sun's surface. Each granule a convection cell, rising hot plasma in the center, falling cooler plasma at the edges, lasting minutes, replacing, renewing, endlessly. The radiative core, deeper down, where photons bounce, is calm, stable, pressure and temperature increasing steadily toward the center. At the very core, our Sun's core, temperature reaches 15 million degrees, pressure 200 billion times Earth's atmosphere. Here, hydrogen fuses, releasing energy, light, heat, the power that warms Earth, that enables life, But your thoughts are drifting now, following the light, outward, upward, into dreams. Stellar opacity, how opaque a star's material is, determines how easily photons can escape. Higher opacity, more scattering, slower energy transport. Iron, in the outer layers of some stars, increases opacity, trapping energy. This can trigger instability, pulsations, as pressure builds and releases, rhythmic, like breathing, like the slow pulse of your heartbeat now. Thump, thump, steady, distant, luminous blue variables. Massive unstable stars undergo enormous eruptions, shedding solar masses of material. Eta Carinae's great eruption in the 1840s briefly made it the second brightest star in the sky, though it lies 7,500 light-years away. The eruption ejected 10 solar masses, creating the homunculus nebula. We still don't understand why. Instability in giants, mysteries unsolved. Wolf-Rayet stars show emission lines, not absorption. Their cores exposed, hydrogen envelope blown away by fierce stellar winds, burning helium and heavier elements. Surface temperature 50,000 degrees. They live fast. Only a few 100,000 years in this phase before exploding as supernovae, their winds, enriching space with nitrogen, carbon, oxygen, building blocks for future worlds, carbon stars, cool red giants, where carbon becomes more abundant than oxygen in the atmosphere. This changes everything. Carbon molecules dominate. Carbon monoxide. Polyatomic carbon chains. The star glows deep red. Sutai, surrounded by dust shells of pure carbon, graphite and carbonaceous compounds, drifting outward, seeding space. Some of this carbon eventually found its way into you. Oxygen-rich stars, more common, where oxygen exceeds carbon, form different dust, silicates, compounds like those in Earth's crust. These stars create the minerals that eventually form rocky planets. The oxygen you breathe was exhaled by dying stars billions of years ago. Each breath connects you as to stellar death, to cosmic cycles, to infinity. Breathe in, breathe out, slowly, deeply, releasing everything. Barium stars show unusual amounts of barium and other heavy elements in their spectra. They're always in binary systems. Their companion, now a white dwarf, was once a giant star that created barium through neutron capture, then transferred this enriched material before dying. Evidence of stellar vampirism, mass transfer, interaction. Even dead stars shape the living. Chemically peculiar stars break the patterns, some rich in mercury, europium, other rare elements, some depleted in helium, enriched in helium. We don't always know why. Stellar evolution is complex, mixing, diffusion, radiation pressure, magnetic fields, all influencing what rises, what sinks, what shows on the surface. Each star slightly different, slightly unique, like snowflakes, like dreams. Infinite variation, stellar aging leaves markers. The ratio of carbon to nitrogen changes as stars evolve. Lithium depletes, rotation slows as stars age, magnetic braking, stellar winds carrying away angular momentum. By measuring these markers, we can estimate a star's age, reading stellar time in chemistry and motion. Let your body age now, but backward. Feel yourself growing younger, lighter, muscles softening, face smoothing, until you're so young, so new. You haven't been born yet, just potential, just energy, waiting in the dark. This is the ultimate relaxation, returning to before, to nothing, to peace. In the far future, trillions of years from now, star formation will cease, the universe will expand, galaxies drift apart, gas becomes too diffuse to collapse. The last stars will form, ignite, burn, and die. Eventually, only brown dwarfs and red dwarfs remain, burning dimmer, dimmer. The stars will fade, one by one, until the universe goes dark. No more light, no more heat, just black holes and dead stars, drifting through expanding void. The stelliferous era will end, and a darker age begins, but that's so far, unimaginably far. Let it go. Release the future. There's only now, only this darkness, behind your eyelids, comfortable, warm, safe. Stars in stellar halos orbit the galaxy in elongated paths, taking them far above and below the galactic disk. These are ancient stars, population 2, metal poor, formed when the galaxy was young. They remember what we've forgotten, the galaxy's violent youth, when it consumed smaller galaxies, scattering their stars into the halo, where they orbit still, lonely, separate from the disk, witnesses to deep time. Our galaxy has consumed dozens of smaller galaxies, their stars, now part of the Milky Way, but on different orbits, moving differently than disk stars. Stellar archaeology, reading motions and chemistry, can identify which stars came from which conquered galaxy. The Sagittarius dwarf elliptical galaxy, currently being absorbed, its stars streaming, mixing, disappearing into our galaxy's population. Cosmic assimilation, merger, inevitable. Some stars visible to the naked eye have planets. We know this now. Thousands of exoplanets discovered, orbiting other suns. Some stars, like Fomalhaut, surrounded by debris disks, dust and planetesimals, visible in telescopes, evidence of planetary systems, forming or existing. Each star, potentially a sun to other worlds, other skies, other eyes looking up. Your eyes are closed now, or should be. Let them stay closed, sealed gently, pressure releasing, darkness complete. You don't need to see, just feel the weight of your body heavier, heavier, melting into the mattress, becoming one with stillness. Stellar convection zones in the Sun extend from 70% of the radius outward to the surface. This churning layer generates the Sun's magnetic field through the dynamo effect. Moving charged plasma creates electric currents, which create magnetic fields, which affect the plasma motion, a feedback loop sustaining itself, reversing every 11 years. Sunspot cycles, magnetic pole flips, regular, mysterious, beautiful mathematics emerging from chaos. Energy transport depends on stellar mass, low mass stars, fully convective, stirring their entire interior. This means they can burn all their hydrogen, not just the core, making them even longer lived. High mass stars, radiative throughout most of their interior. Only their outer layers convect, energy trapped deeper, leaking out slowly, building pressure, creating instability in the most massive stars. The stellar mass-luminosity relation tells us that luminosity increases dramatically with mass. A star 10 times more massive shines thousands of times brighter. This is why massive stars die young, burning through fuel, like a fire with too much oxygen. Brilliant, wasteful, brief. While small stars conserve, endure, outlast. Some stars don't behave. Classical B stars, B-type stars that show hydrogen emission lines, indicating surrounding gas disks. They rotate so fast, near breakup velocity, flinging material into orbit around themselves, creating disks that absorb and re-emit light. Why they rotate so fast, unclear. Perhaps they're merger products, or were spun up by a companion. Mysteries, accumulating like stars, too many to count. Your heartbeat has slowed now. Thump, thump, longer between beats. Your metabolism slowing. Body temperature dropping slightly. This is healthy. This is sleep approaching. The edge of consciousness, where everything becomes soft, indistinct, acceptable. Stellar mergers happen sometimes, especially in dense star clusters. Two stars, orbiting too close, spiral inward, tidal forces shredding them until they merge, becoming one. The result, a blue straggler, a star that appears younger than it should. Too massive, too blue for the cluster's age. It's been refreshed, born again through fusion of bodies. When stars collide, the results depend on their masses and velocities, sometimes complete disruption, sometimes accretion and growth. In the dense cores of globular clusters, collisions might happen once every 1,000 years, building strange objects. We've found stars with unusual compositions, likely collision products, each one evidence of cosmic violence, smoothed over, disguised as normalcy. Mass transfer in binaries can be stable, slow, drip by drip, through the Lagrange point where gravity balances, or unstable, rapid, common envelope evolution, where one star swells so large it engulfs its companion. The companion orbits inside, spiraling through the giant's atmosphere, friction, heating, ejecting the envelope entirely, leaving two cores orbiting close, a white dwarf and main sequence star, or two white dwarfs, or a neutron star and companion. Stellar intimacy at its most extreme. Sometimes, when a white dwarf accretes matter from a companion, the hydrogen piles up on its surface, pressure building, temperature rising, until it ignites. Not fusion in a controlled core, but runaway fusion on the surface. A nova, brief explosion, blowing off the accreted layer. The white dwarf survives, continues accreting, building to another nova. Years or decades later, recurrent novae, pulsing, erupting, caught in a cycle they cannot escape. If the white dwarf accretes enough mass, approaching 1.4 solar masses, the Chandrasekhar limit, electron degeneracy pressure, can no longer hold it up. The entire star undergoes runaway carbon fusion in seconds. Thermonuclear explosion, type Ia supernova, completely destroying the white dwarf, leaving nothing. These supernova, all roughly the same brightness, making them excellent standard candles, measuring cosmic distances, revealing the accelerating expansion of the universe, dark energy. But those are thoughts for waking minds. Your breathing is shallow now, barely moving, chest rising, falling, so slightly. This is good, this is right. Let it slow even more. Each breath, taking longer, until you almost forget to breathe, and then remember, and take another, soft, shallow breath. Stellar spectroscopy reveals motion through the Doppler shift. Light from approaching stars shifted toward blue, receding stars toward red. This tells us stellar velocities, orbital motions in binaries, rotation rates, even the convection cells on the sun rising toward us, sinking away, blue shifted, red shifted, motion written in light if you know how to read. Radial velocity measurements have discovered most exoplanets. A planet's gravity tugs its star, making it wobble slightly. The star's spectrum shifts, blue, red, periodic. revealing the planet's mass and orbit. Even though we can't see the planet, we see its effect on the light. Gravity's fingerprint, invisible touch, making visible the hidden. Some stars are spectroscopic binaries, too close to resolve, even in powerful telescopes, appearing as single points, but their spectra show two sets of lines, shifting back and forth as they orbit, revealing the double nature, hidden but knowable, like your consciousness now, single but containing multitudes, thoughts, dreams, memories, all orbiting in the dark. The first stars in the universe changed everything. Before them, the universe was simple: hydrogen, helium, trace lithium, that's all. After them, carbon, oxygen, nitrogen, iron, all the complexity, all the chemistry, all the possibilities, and came from stars dying. Life is made of stardust, literally, not metaphorically. The calcium in your bones, forged in stellar cores, the oxygen you breathe, stellar fusion product. You are a way for the universe to know itself, to feel, to dream. Let yourself dissolve into that awareness. You're not separate from stars. You're made of them, part of the same cosmic cycle: birth, life, death, rebirth. Your atoms, once inside a star, will someday return to stars. Everything is borrowed. Everything returns. Nothing is lost, only transformed. Stellar nucleosynthesis follows the curve of nuclear binding energy. Fusion releases energy up to iron, beyond iron. Fusion requires energy, so stellar cores stop at iron, but supernovae provide that energy during collapse and explosion, allowing formation of heavier elements: gold, platinum, uranium, all requiring supernovae. Your gold ring, if you wear one, contains atoms forged in unimaginable violence, now circling your finger, quietly, marking time, marking love, marking impermanence. The origin of elements tells a story. Hydrogen and helium from the Big Bang, lithium, beryllium, boron from cosmic ray spallation, carbon, oxygen, nitrogen from stellar fusion, iron from supernova cores, gold, uranium from neutron star mergers. Each element has a birthplace, a story. Everything from somewhere going somewhere else. Cosmic recycling is efficient over billions of years. Gas ejected by dying stars mixes with the interstellar medium. Shock waves from supernova compress this gas, triggering new star formation. The cycle continues. Each generation of stars, slightly enriched, the universe, learning, complexity increasing, until, eventually, stars with planets, planets with water, water with life, life with consciousness, consciousness, wondering about stars. Your consciousness is fading now. Thoughts, slowing, becoming, dreamlike, random associations, memories mixing with imagination. This is sleep, approaching, welcoming. There's nothing to fear, nothing to do. Just let go. Heavier, heavier, sinking into the dark, galactic evolution, driven by stars. Their light ionizes gas, their winds create bubbles and shells, their supernovae shock and heat the interstellar medium. They create heavy elements that enable planet formation. They regulate star formation through feedback. The galaxy is not static, but alive, changing, shaped by stellar birth and death over billions of years. The first starlight ended the cosmic dark ages about 100 million years after the Big Bang. Before that, the universe was opaque, neutral hydrogen absorbing all ultraviolet light. The first stars, massive and hot, ionized bubbles around themselves. These bubbles grew, merged, eventually fuller. The entire universe be ionized and became transparent. Cosmic dawn. We can't see those first stars, but we see their effect in the cosmic microwave background, in the formation of galaxies, in the chemistry of ancient stars. Globular clusters are time capsules. They're stars, all formed together billions of years ago. By studying them, we learn about stellar evolution, watching stars at different life stages, all the same age, like a snapshot of a population. Some are on the main sequence, some are red giants, some white dwarfs, all telling the story of stellar aging, death, transformation. Stars in globular clusters experience cosmic density. In the core, hundreds of stars per cubic light year, compared to less than one in the solar neighborhood. This density leads to interactions, close encounters, collisions, binary formation, exotic objects, blue stragglers, millisecond pulsars, low-mass X-ray binaries, all products of stellar interaction in the cosmic crowd. Open clusters are younger, less tightly bound. The Pleiades, barely 100 million years old, still embedded partially in the nebula of their birth. Hot blue stars haven't yet died. Eventually, tidal forces from the galaxy will disperse them. Their stars, scattered, indistinguishable from field stars. The sun might have formed in an open cluster 4.5 billion years ago. Its siblings, long since separated, scattered across the galaxy, unknowable, lost. Imagine your body dissolving, atoms separating, drifting apart, each atom finding its own path through space, eventually ending up in different stars, different planets, different people. You scattered, dispersed, but not destroyed, just redistributed. This is what happens to everything eventually. Release into the inevitable. Some stars near the galactic center orbit the supermassive black hole so closely that relativistic effects are measurable. S2 orbits every 16 years. At closest approach, gravity so strong, time slows measurably. Clocks on S2 would run slower than ours. General relativity confirmed by watching stars dance around darkness. The record-breaking massive star, R136A1, weighs about 300 solar masses near the theoretical maximum. At this mass, radiation pressure nearly tears the star apart. Its stellar wind, so powerful, It loses a solar mass every few million years. It cannot last. Already, it's probably shrinking, losing mass. In a few million years, it will explode or collapse, leaving behind a black hole, maybe 100 solar masses. The most massive stars become the most massive remnants, the smallest known stars. EBLMJ Eurofive-Facer 57a, barely larger than Saturn. Only 8% of the Sun's mass, barely massive enough for fusion. Its surface, cool, 2000 degrees, glowing deep red, almost invisible. But it will outlive everything, burning for trillions of years, patient, eternal. The universe's last candles when everything else has gone dark. Methuselah star HD 10283 appears almost as old as the universe. This creates paradox, tension, but measurements have uncertainties. The star's age, uncertain by 1 billion years. The universe's age, uncertain by hundreds of millions. Within uncertainties, they reconcile, barely. Still, it reminds us how little we truly know, how much remains mysterious, unresolved. Let that uncertainty calm you. You don't need answers, just acceptance of mystery, of not knowing. Stars visible to the naked eye from Earth, about 5,000, but you have never seen that many. Light pollution, haze, horizon. On a perfect dark night, from a mountaintop, you might see 3,000. Most people in cities see dozens, maybe hundreds. The stars fading, not dying, just hidden by our light. Still there, waiting, patient, shining, whether we see them or not. Constellations are cultural, arbitrary. The Big Dipper, called the Plough in Britain, the Saucepan in Australia, part of Ursa Major, the Great Bear in Greek tradition. But Chinese astronomers saw different patterns. Aztec astronomers, different still, all looking at the same stars, seeing different stories, all equally valid, all equally invented. The stars don't know, don't care what we call them. They simply are. Let your thoughts become like that, simply existing, without narrative, without meaning, just sensation, breathing, heartbeat, pressure, warmth. Nothing more needed, nothing more wanted, just being in darkness, in silence, in peace. Ancient navigation by stars required memory, knowledge passed down. Polynesian navigators memorized star paths, rising points, setting points. They knew when Arcturus rose, they were at a certain latitude. When Sirius set, they should turn, sailing thousands of miles by starlight and memory, finding tiny islands in vast ocean. The stars were map and compass, unchanging guides in trackless water. But stars do move, proper motion, gradually changing constellations. 10,000 years ago, the Big Dipper looked different. 10,000 years hence, different still. Dubhe, moving one direction, Alcade another. Eventually, the dipper shape will deform, unrecognizable. All patterns, temporary, all structures, dissolving over time. Your body knows this, cells replacing, atoms exchanging. You are not the same physically as 7 years ago. Every atom replaced, yet you remain somehow. Same pattern, different material, like constellations, like stars, like everything. Ship of Theseus, are you still you? Of course. And also, no. Let the paradox dissolve into sleep. Myths written in stars, Greek heroes placed in the sky, Orion, the hunter, Scorpius, the scorpion, eternally opposite. When one rises, the other sets. The story says Scorpius killed Orion, so they were placed apart forever. But it's just coincidence, geometry, our pattern-seeking minds making meaning from random arrangements, beautiful but arbitrary. Aboriginal Australians saw the dark spaces between stars as constellations, the emu in the sky, formed by dark nebulae. In the Milky Way's band, visible only from the southern hemisphere, only with dark skies, they navigated by darkness as much as light, recognizing absence as meaningful as presence. Learn from this. In sleep, we navigate darkness. We find rest in absence of light, absence of thought, absence of effort. The darkness is not enemy, but friend. Embrace it, sink into it, let it hold you completely. Nothing to fear, only release. How do we know how old a star is? They don't wear rings like trees. They don't shed layers. We can count. We must be clever, patient, reading subtle signs, written in light, in motion, in vibration. Let your body settle deeper as we explore the methods of stellar dating. Each technique a whisper, a clue, revealing deep time. Gyrochronology uses rotation to estimate age. Young stars spin fast, rotating in days or even hours, but over time, stellar winds carry away angular momentum. The star slows predictably, measurably, like a spinning top, gradually losing speed. A star's rotation period, combined with its mass, reveals its age with reasonable precision. The sun rotates once every 25 days at its equator. This tells us it's middle-aged, about 5 billion years. Young stars in the Pleiades, only 100 million years old, spin every few days. Ancient stars in globular clusters rotate every 50, 60 days. Slower, slower, like your thoughts now, winding down, losing momentum, approaching stillness. But rotation alone isn't enough. We need more, deeper information from inside the star where we cannot see. So we listen to stellar sound waves, to vibrations, traveling through stellar interiors. Astroseismology, the study of stellar earthquakes, or rather, starquakes. Sound waves making stars ring like bells. Feel your body resonating with your heartbeat. Thump, thump, the bed beneath you, vibrating slightly up with each pulse. Stars do this too, but with sound waves. propagating through their gaseous bodies. These waves, created by turbulence in convective zones, bounce, reflect, interfere, creating standing wave patterns, oscillations, visible on the surface, stellar sound waves, too low for ears, far below human hearing, periods of minutes, hours, days. We detect them through Doppler shifts, the star's surface, moving toward us, then away, rhythmically, parts rising, parts falling, the star breathing, pulsing, revealing its secrets. Through vibration, these oscillations tell us everything. The waves travel at different speeds, through different density, temperatures as compositions. By measuring thus many oscillation modes, we map the stellar interior like a CT scan, but using sound instead of X-rays, revealing the size of the core, the depth of convective zones, the density profile, the internal rotation, everything from surface vibrations. Let your awareness vibrate now, oscillating between waking and sleeping, neither fully one nor the other, just pulsing gently back and forth like stellar sound waves, like ocean tides, rhythmic, hypnotic, endless, stellar interior mapping through astroseismology reveals differences we couldn't see otherwise. Two stars, identical in brightness, temperature, surface chemistry, might have completely different interiors, one with a large convective core, one without, one rotating rapidly inside, one slowly. The surface hides complexity. Only vibrations reveal truth. Our sun oscillates in millions of different modes, each mode a different pattern of standing waves. Some waves penetrate deep, sampling the core. Others stay shallow, probing outer layers. By measuring them all, we know the sun's interior better than Earth's. We've mapped it completely, precisely, beautifully. A star, transparent through sound, surface granulation, visible on the sun. Those cellular patterns are convection cells, hot plasma, rising in centers, cooling, sinking at edges, each granule about 1,000 kilometers across, lasting 10 minutes before dispersing, reforming continuously. The surface boiling, churning, transporting heat from below. These granules create turbulence, which generates sound waves, which create the stellar oscillations. Everything connected: convection, sound, oscillation, revelation, a chain of cause and effect, leading from stellar interior to our telescopes, to our understanding. Let understanding fade now. You don't need to know, just feel the rhythm, the pattern, the endless vibration. Stellar limb darkening, noticed when viewing. The sun's disk, the center, appears brighter than the edges. This happens because, looking at the center, we see deeper into hotter layers. Looking at the edge, we see only the cooler surface. The effect tells us about temperature gradients, atmospheric structure, opacity. Simple observation revealing deep complexity. different wavelengths show different amounts of limb darkening, blue light more pronounced than red. This tells us temperature changes with depth, each colour sampling a different layer. By measuring carefully, we reconstruct the temperature profile of the stellar atmosphere. Invisible structure made visible through patient observation. Stellar albedo. How much light a star reflects. Wait, stars don't reflect, they emit. But in binary systems, one star's light can fall on another, some fraction absorbed, some scattered. The albedo depends on atmospheric properties, surface features. For most stars, albedo is low. They absorb more than reflect. But measuring it in eclipsing binaries tells us about stellar atmospheres, yet another way to probe what cannot be seen directly. Your mind is absorbing these words, some fraction retained, most slipping away, forgotten immediately. This is perfect. You don't need to remember. Just let information wash over you like starlight, falling on your closed eyelids, warming but not illuminating. Star formation efficiency puzzles astronomers. In a giant molecular cloud, thousands of solar masses of gas, only a few percent become stars, the rest dispersed or remains as gas. Why so inefficient? What stops star formation before the cloud is consumed? The answer is feedback. Massive stars, once formed, disrupt their nursery. They emit intense ultraviolet radiation, ionizing surrounding gas, creating H2 regions, glowing pink in photographs. This ionized gas heats up, expands, pushing outward, compressing some regions, dispersing others. The first stars prevent later stars from forming. Self-limiting process. Stellar winds from young massive stars blow bubbles in the molecular cloud, sweeping gas away, reducing density, making further collapse difficult. Then supernovae. When the first massive stars die, exploding, shock waves blast through the cloud, shredding it, dispersing it. Star formation stops. The cloud destroyed by its own children. But sometimes feedback triggers new star formation instead of preventing it. Triggered star formation occurs when shock waves from supernovae or stellar winds compress adjacent gas, increasing density locally, starting collapse. That wouldn't have happened otherwise. Creation through destruction, birth from violence. Let your muscles be shocked and deeper relaxation, each breath a wave, releasing tension, each exhale dispersing tightness, nothing forced, just allowed. Gentle compression leading to release. The body knows how to let go. If you stop interfering, shock waves in starbirth, visible in many nebulae. The Orion Nebula shows bow shocks around young stars, glowing arcs where stellar winds meet ambient gas, compressing it, heating it, making it shine. These shocks can trigger further star formation in the compressed layers, cascading through the cloud, sequential star formation, generations of stars, each triggering the next. Feedback from massive stars dominates galactic evolution. Their ionizing radiation, their winds, their supernovae inject energy into the interstellar medium, heating it, stirring it, preventing too rapid star formation, regulating the process. Without feedback, galaxies would form stars too quickly, exhausting their gas in 1 billion years. Instead, star formation continues for billions of years. Feedback creates sustainability, balance through violence, ionizing radiation from stars, photons energetic enough to strip electrons from atoms. Only the hottest stars emit significant amounts. O-type stars, surface temperatures 40,000 degrees or more. Their ultraviolet light, invisible to eyes, but powerful. Each photon carrying enough energy to ionize hydrogen. These photons create bubbles of ionized gas around massive stars, Strömgren spheres, perfectly spherical, in uniform gas, irregular in reality, shaped by density variations, stellar winds, motion. The Orion Nebula glows because of 4 hot stars, the trapezium at its center. Their ultraviolet light ionizes the gas. The electrons recombine with protons, emitting visible light, mostly red from hydrogen. This is why emission nebulae glow pink, not reflection, not starlight scattered, but fluorescence, gas, absorbing ultraviolet, emitting visible, transformation of invisible to visible. Stars shaping nebulae everywhere. The Eagle Nebula's pillars, sculpted by radiation from nearby massive stars, photoevaporation, peeling away the pillars' outer layers like wind, eroding rock but using light instead of air. The pillars shrink over thousands of years, eventually thus consumed completely, disappeared. Temporary structures captured by telescopes, existing only briefly in cosmic time. Inside the pillars, small dense knots resist evaporation. These are eggs, evaporating gaseous globules, each one possibly a forming star, protected temporarily by surrounding material, but the radiation catches up eventually, dispersing the cocoon, exposing the young star, or destroying it. Before birth completes, star formation, racing against destruction. Some win, some lose. Your thoughts are evaporating now, like gaseous globules exposed to light, thinning, dispersing, leaving behind only darkness, no resistance necessary. Let them go. Each thought temporary, none worth holding, all evaporating into the dark. Bow shocks around fast stars form when runaway stars plow through interstellar gas like boats through water. They push gas aside, creating compression waves. The gas, heated by compression, glows infrared, visible in Spitzer images, red arcs, pointing backward, showing the star's motion. through space. Zeta Ophiuchi creates a spectacular bow shock. Moving at 24 kilometers per second, 30 times faster than a rifle bullet, the shock spans several light years, glowing like a cosmic wake. The star itself, hot, blue, massive, ejected from its binary system when its companion exploded, now fleeing alone, creating beauty from tragedy. These fast stars, runaway stars, can escape their birth clusters young, travel hundreds of light years before dying, seeding distant regions with heavy elements when they explode, spreading stellar products far and wide, galactic mixing through stellar motion. Everything connects. Eventually, nothing stays isolated. Everything disperses. Feel yourself dispersing. Thoughts, sensations, sense of self, all spreading, thinning, losing coherence. This is not death. This is sleep. This is rest. This is not necessary. Let it happen. Let go. Completely. Stellar debris disks surround many young stars, dusty pancakes of material left over from star formation. This material eventually forms planets, or is blown away, or falls into the star. We see these disks in infrared. The dust, warmed by starlight, glows, revealing circumstellar structure, invisible light. Beta Pictoris, one of the first debris disks discovered, edge on from Earth. A thin line extending hundreds of AU, gaps in the disk suggest planets sweeping material from their orbits. We've even imaged one planet directly, a giant world, young, hot, still glowing from formation. The disk is a laboratory showing us planet formation in action. These disks fade over time, collisions grinding dust to smaller particles, radiation pressure blowing particles outward into space. After 10 million years, most disks dissipated. The planets, if any, already formed. The system cleaned up, mature. Our solar system once had such a disk 4.5 billion years ago. Now, only trace amounts remain. Asteroid belt, Kuiper belt, remnants of what was circumstellar envelopes, different from disks. These are spherical shells around evolved stars, red giants, blowing off their outer atmospheres slowly, gently. The gas expands, cools, molecules form, dust condenses. The envelope grows, becoming enormous, light years across, eventually dispersing into interstellar space. IRC plus 10216, a carbon star, has the thickest circumstellar envelope known. The star itself, invisible, buried inside layers of dust. We see only the envelope, glowing infrared, pulsing as the star beneath pulsates. The star dying, cocooned in its own exhalations. Soon, the envelope will dissipate, revealing a white dwarf at the center. The transformation complete. Planetary nebulae are circumstellar envelopes lit up when the central star becomes hot enough. Its ultraviolet light ionizes the previously expelled gas, making it glow. Beautiful colors: red from hydrogen, green from oxygen, blue from helium. These nebulae expand over thousands of years, fading as they spread, thinning until invisible. The gas returned to the interstellar medium, enriched, changed, ready for recycling. Let yourself be recycled now. Energy that was you, returning to the universe. Tension dispersed, thoughts dissolved, self forgotten. Only breath remains in, out, slow, shallow, barely there. Stellar death timeline depend entirely on mass. Low mass stars, red dwarfs, burn for trillions of years, gradually cooling, shrinking, fading, never exploding, never creating planetary nebulae, just cooling forever, becoming black dwarfs eventually, though the universe isn't old enough yet for any to exist. Solar mass stars, like our sun, live 10 billion years, stable on main sequence 9 billion years, then red giant phase 1 billion years, helium burning 100 million years, asymptotic giant branch 1 million years, planetary nebula 10,000 years, white dwarf forever. The timeline accelerating toward the end, like life, slow beginning, rapid conclusion. Massive stars, 8 solar masses or more, live fast, die young. Main sequence 10 million years, red supergiant 1 million years, helium burning 100,000 years, carbon burning 1,000 years, neon burning 1 year, oxygen burning 6 months, silicon burning 1 day, then iron core and collapse in less than a second. The end. Sudden, violent, spectacular. The most massive stars, over 100 solar masses, live only 2 or 3 million years. Barely time to orbit the galaxy. Once born, lived, died. In cosmic eye blink, their entire existence, shorter than Earth's ice ages, shorter than human civilization, brief but important. They create heavy elements, they shape galaxies, they trigger star formation. Their brevity makes them crucial. Your consciousness is brief too, in cosmic terms, infinitesimal, decades at most, then gone, like a massive star, bright, brief, returning to darkness. Does it matter how long you exist, or only that you existed? Questions for waking hours, not for sleep. Let them dissolve, unanswered, into the dark. The stellar death timeline for intermediate mass stars, 2 to 8 solar masses, includes additional phases. After helium burning, they don't ignite carbon. Core shrinks, heats, but never reaches ignition temperature. Layers burn in shells. Hydrogen and helium. The star becomes highly unstable, pulsating, shedding mass, thermal pulses every few thousand years. dramatic, chaotic, unpredictable. These thermal pulses dredge up fusion products from deep inside, carbon, nitrogen, heavy elements created by neutron capture. They appear on the surface, changing the spectrum, enriching the wind. Some stars become carbon stars during this phase. Others, barium stars, technetium stars, all showing internal products brought to surface, internal becoming external, hidden, revealed. Your internal state is becoming external, relaxation spreading outward from core to surface, muscles releasing, skin softening, face smoothing, the boundary between inside and outside blurring. You're not contained anymore. You're spreading, expanding, merging with surroundings. Eventually, after enough thermal pulses, the envelope is gone, expelled completely, the core exposed, hot, tiny, dense. Ultraviolet light ionizes the expelled gas, creating planetary nebula, lasting 10,000 years, then fading. The white dwarf remains cooling over billions of years. The end of intermediate stars, gentle, beautiful, compared to supernova violence. Stellar death is not ending, but transformation. The matter doesn't disappear. It spreads, enriches, mixes, seeds, new stars, new planets, new life. Perhaps nothing ends, really, just changes form, like you, changing form from wakiness to sleeping. Not death, just transformation into another state. Sound waves still echoing through stars, vibrations continuing long after we stop listening. Stars still forming in nebulae despite feedback. Bow shocks still glowing around runaway stars. Debris disks still circling. Young stars. All these processes continuing, whether observed or not. The universe doesn't need witnesses. It simply is. And you don't need to witness anymore. Let your observation cease. Let awareness fade. You've seen enough, learned enough, experienced enough. Now, rest, release into the darkness that existed before stars, that will exist after stars. Eternal darkness, welcoming, infinite home, dating stars through gyrochronology, astroseismology, chemistry, rotation, all methods converging on truth. But truth doesn't matter in sleep. Only surrender matters. Only letting go. Only drifting deeper into silence, into stillness, into nothing. The stars will keep vibrating, keep spinning, keep dying while you sleep. And that's perfect. That's how it should be. The universe continuing while you rest. No guilt, no worry, no need to stay awake. Just permission to fade completely, totally. Now, our sun, in 5 billion years, will swell, engulfing the inner planets. Its outer layers puffed away, forming a planetary nebula, the core contracting, becoming a white dwarf, Earth-sized, glowing, cooling over billions of years. Eventually, after timescales longer than the current age of the universe, it will crystallize. Carbon and oxygen arranged in lattice structures. A stellar diamond, cold, dark, invisible, floating through space forever, but between now and then, 5 billion years of stability, warmth, light, the sun, reliable, steady, rising, setting, day after day, generation after generation, species after species. It has been there for everything. Every dinosaur, every tree, every human thought. Its light, reaching Earth in 8 minutes, having travelled from the core for 100,000 years. Each photon, ancient, when it finally touches your skin. Let your skin relax now. Pores opening, releasing, tension flowing out into the air, into space. You don't need to hold anything anymore. Let the sun, the stars, the universe hold you instead. They're so much stronger, so much more patient. They will outlast all worry, all fear, all pain. In 1 billion years, the sun's increasing luminosity will evaporate Earth's oceans, the planet becoming Venus-like, hot, dry, lifeless. But life might have moved by then to the moons of Jupiter, to the stars, or might be gone, evolved beyond recognition, or extinct. The universe continues regardless. Stars don't mourn, don't celebrate. They simply burn and die, and in dying, create the conditions for new stars, new planets, possibly new life. The cycle continues, whether witnessed or not. Your breathing is so quiet now, barely audible, barely felt. This is the edge, the boundary between waking and sleep. You can cross it any time. There's no effort required. Just stop trying, stop listening, stop following. Let the words wash over you. There's meaningless. You're like rain, like waves. Just sound fading into silence. Stellar opacity determines much. High opacity stars trap radiation, building pressure, leading to pulsation. Low opacity stars release energy smoothly, remaining stable. Iron in stellar atmospheres increases opacity dramatically. This is why the iron bump creates instability in massive stars. Energy trapped, then released, creating the pulsations we see in Cepheids, in our Lyrae, in other variables. The star breathing in and out, swelling, contracting, a cosmic bellows. Inside massive stars, layers form like an onion, hydrogen fusing in a shell, surrounding helium fusing core, surrounding carbon fusing region, surrounding neon, oxygen, silicon, and finally iron. Each layer at different temperature, different pressure, different time scale. The silicon burning layer lasts only days before creating enough iron to doom the star, while the hydrogen layer might burn for thousands of years. These layers don't mix generally. Density stratification keeps them separate. Heavy elements sink, Light elements rise, but sometimes in convective zones, mixing occurs, dredge up, bringing fusion products to the surface, changing the star's spectrum, revealing us what's happening in the depths, like dreams, bringing unconscious material into awareness, briefly, before it sinks again. Your unconscious mind is taking over now. The rational mind, quieting, releasing control. You might notice thoughts becoming strange, illogical. This is normal. This is healthy. The dream state approaching. Let it come. Don't fight. Don't analyze. Just observe and let go. Luminous blue variable, the most massive, most luminous, most unstable stars. They vary erratically, sometimes dimming, sometimes erupting. We don't fully understand them. They shouldn't exist. Theoretically, radiation pressure should blow them apart. Yet they persist for thousands of years, defying expectations. Ita Carinae, Piscigni, Estoradus, beautiful, mysterious, doomed, Wolf-Rayet stars, exposed cores showing emission lines of ionized helium, nitrogen, carbon, oxygen, depending on their type. Their winds blow at thousands of kilometers per second, faster than hurricanes, faster than sound, faster than thought, carrying away several Earth masses per year, the star dissolving into space, even as it shines, dying, but spectacularly, beautifully, creating complex nebulae, planetary nebulae, but the terms are blurring now, the definitions sliding, merging into dream logic. Feel your body, merging with the mattress, boundaries dissolving. Where do you end and the bed begin? Hard to say, not important. You're becoming part of the room, part of the darkness, part of space itself, expanding, diffusing like stellar wind, like nebulae, spreading, thinning, disappearing into vastness. Carbon stars create dust. Carbon combines with itself, forming chains, rings, graphite particles. These drift into space, cooling, condensing. Eventually, some might become parts of planets, parts of life. Carbon, the basis of organic chemistry, mostly came from carbon stars. The diamond on someone's finger, the graphite in a pencil, the carbon in DNA, all stellar exhalations breathed out by dying giants. Billions of years ago, oxygen-rich stars, the majority, create silicate dust, silicon, oxygen, forming compounds like quartz, like sand. The grains drift outward, accumulate, eventually end in protoplanetary disks. They stick together, forming asteroids, planets. Earth's crust is mostly unsilicate minerals from ancient stars. The ground beneath you, the walls around you, made of stardust. Everything connected, everything starborn. Barium stars reveal binary evolution. The barrier, too heavy to form in the current star, must have been transferred from a companion, now dead. Evidence of past interaction, past intimacy, past merger or mass transfer. The star carries the memory in its spectrum, in its chemistry, written permanently in starlight, like scars, like memories testifying to what was. Your memories are fading now, becoming unimportant. What happened today, yesterday, last year, doesn't matter. In this moment, all that matters is letting go, sinking deeper into formless, timeless peace. Memories like stars, distant, faint, flickering out one by one until only darkness remains. Chemically peculiar stars challenge understanding. Magnetic fields might separate elements by atomic weight, causing stratification or perhaps unusual nuclear processes in their cores. We're not certain. Each peculiar star, a puzzle, potentially revealing new physics or just cosmic randomness, creating outliers, exceptions, beautiful aberrations, stellar aging markers, change over time. Lithium, destroyed by fusion, depletes in old stars, and carbon to nitrogen ratio changes as CNO cycle processes material. Rotation slows due to magnetic braking. Metallicity increases with galactic evolution. From all these, we deduce age, though with uncertainty, always uncertainty. We measure, we estimate, we guess. The universe keeps its secrets, partially, gracefully. Far future, stelliferous era ending. No more star formation, existing stars burning out one by one. First, the massive blue giants, already gone. Then, solar-type stars, white dwarfs cooling. Finally, only red dwarfs, burning for trillions of years. But even they, eventually, exhaust their fuel. The last star will flicker out in 10 or 100 trillion years. The universe going dark, entering the black hole era where only gravity shapes the void. But before that, so long before that, incomprehensible timescales, let them wash away. You don't need to think about endings, not now. Just this breath, this moment, this soft sliding into sleep. Stellar halos contain the galaxy's oldest citizens, population 2 stars, metal poor, ancient. They orbit in eccentric paths, plunging through the disk, then soaring far above, then plunging again. Elliptical orbits formed when the galaxy was young, violent, chaotic, before the disk settled, before spiral arms formed. These stars remember. They carry the galaxy's history in their motion, their chemistry, their age. Some halo stars might have come from other galaxies, consumed by the Milky Way in ancient mergers, their orbits retrograde, opposite the disk's rotation, their chemistry slightly different, telling of foreign birth. They've been integrated, assimilated, part of our galaxy now, but their origin remains visible to those who know how to look. You contain histories too, in your DNA, genetic memory of ancestors, in your neurons, childhood experiences, in your body, scar tissue, growth rings, marks of time. But right now, let history dissolve. You're not the past, you're not the future, you're just this moment, this breath, This slow descent into nothing. Planets around other stars, now numbered in thousands. We've found hot Jupiters, super-Earths, ice giants, rocky worlds, some inhabitable zones where water could be liquid, some around multiple stars where sunsets show 2 or 3 suns simultaneously, each planetary system unique, teaching us what's possible, what's common, what's rare. Fomalhaut has a debris disk, visible in telescopes, dust, planetesimals, possibly planets, orbiting. The disk has a gap carved by unseen planets, sweeping their orbits clean. We infer presence from absence, like detecting a person by their shadow, gravity's footprint in the dust, your footprint on the world. What does it matter? Everything you've done, everyone you've known, will be forgotten. Eventually, stars don't remember, planets don't care, the universe, vast and ancient, pays no attention, and this is freeing. There's no pressure, no expectation. You can just be and then not be, and it's all perfectly fine. Stellar magnetic fields generated by dynamo action in convective zones, charged plasma moving in rotation and convection creates electric currents which create magnetic fields which affect the plasma. Feedback loop, self-sustaining. The sun's field flips every 11 years. Sunspot cycle, magnetic activity, rising and falling, predictable, yet chaotic in detail. Some stars have much stronger fields, magnetic stars, with field strengths thousands of times. The suns. These fields affect stellar structure, can halt convection, create chemical peculiarities, produce enormous star spots, covering half the star, caged by its own magnetic field, shaped, constrained, unable to evolve. Normally, you're not constrained, not anymore. The day's obligations released, tomorrow's worries irrelevant. You're free to float, to drift, to sink into infinite softness. Nothing holding you except gravity, gentle, irresistible, pulling you down into sleep. Classical B star, rotating rapidly, near breakup velocity, centrifugal force, nearly overcoming gravity, they fling matter into orbit, forming disks of gas around their equators. These disks absorb stellar light, re-emit it, creating emission lines in the spectrum. Why so fast? We think perhaps stellar mergers, or mass transfer, or just formation with high angular momentum. Mystery remaining. When stars collide in dense clusters, the outcome depends on impact parameter, head-on collision, complete merger, possible supernova, glancing blow, mass stripping, formation of binary. Most collisions, partial, chaotic, creating blue stragglers, rejuvenated stars, appearing younger than their cluster mates, evidence of violence hidden beneath normal appearance, like trauma, buried deep, invisible except to those who know where to look. But you don't need to look anymore. Eyes closed, completely darkness, total. Let your other senses fade too. Sound becoming irrelevant, touch minimal, smell forgotten, taste gone, only a faint awareness of existing, and even that slipping away. Mass transfer in close binaries through Roche lobe overflow. When one star expands, becoming a giant, its outer layers cross the boundary where the companion's gravity equals its own. Material streams through the inner Lagrange point onto the companion, sometimes steady, sometimes unstable. Common envelope evolution, spiral in, merger, or tight binary formation. Recurrent novae, white dwarfs accreting from companions, building hydrogen layers until ignition. Thermonuclear runaway on the surface. Explosion, ejecting the layer. The white dwarf survives, continues accreting. Years later, another nova, T. Pixidis, Oris Oppiuchi, Euscorpi, erupting every few years or decades, recycling matter between stars, eternal dance of give and take. Your heartbeat so slow now, thump, thump, long pauses between beats. This is fine, this is healthy, this is deep relaxation, approaching sleep, the body conserving, resting, preparing for dreams or nothing, just void. If a white dwarf accretes enough, reaching the Chandrasekhar limit, 1.4 solar masses, electron degeneracy can't hold, carbon fusion ignites throughout the star simultaneously. Runaway thermonuclear supernova type I, brightness always roughly the same, making them standard candles, revealing cosmic distances, accelerating expansion, dark energy, the universe growing faster and faster into cold, dark infinity. But here, now, in this room, there's only warmth, softness, you and the darkness. Nothing expanding, nothing changing, just stillness, perfect, complete, eternal. Now, Doppler spectroscopy reveals hidden planets. The star wobbles, pulled by orbiting planet. Spectrum shifts, blue, approaching, red, receding, periodic, revealing orbital period, mass, distance. From starlight alone, we know invisible worlds circling distant suns. Thousands found this way, thousands more waiting, undetected in the data, in the darkness between stars. Some binary stars eclipse from our viewpoint. One passes in front of the other. Light dims precisely, predictably. From the light curve, we learn stellar sizes, temperatures, orbital inclination, separation, everything from watching brightness rise and fall. Information encoded in light, decoded by careful observation, patient measurement. Your observation is ending now. No more watching, no more measuring, just experiencing, or not even that, just being, fading, dissolving into the background like light, red-shifted by cosmic expansion, stretched, thinned, approaching invisibility. First stars, population D3, massive, metal-free, burning, fierce and fast, dying as pair instability supernovae, completely destroyed. No remnant, just expanding debris, seeding space with the first carbon, first oxygen, first iron, making possible everything after. Every complexity, every planet, every life owes existence to those first stars, unknown, unmourned, but foundational. Dark ages, before first stars, the universe, cooling, expanding, neutral hydrogen, opaque, dark, no light sources except fading cosmic microwave background. For hundreds of millions of years, darkness. Then, first stars ignited, their light, ionized surroundings, creating bubbles of transparency. These bubbles grew, merged, eventually re-ionizing the entire universe. Cosmic dawn, light, returning, but different light, starlight, scattered by new structures, new complexities. We can't see those first stars, too distant, too faint, red-shifted, beyond visibility, but we see their effects in galaxy formation, in cosmic microwave background polarization, in the chemistry of ancient stars, evidence, indirect but compelling. They were there. They changed everything. Then they died. And only their legacy remains. Legacy. What will yours be? Does it matter? In cosmic terms? No. In human terms? Perhaps. But right now, in sleep, even that doesn't matter. Let go of legacy, of meaning, of importance. You're just atoms, temporarily organized, soon to disperse, like stellar wind, like planetary nebulum, beautiful, brief, returning us to the medium from which you came, globular clusters, ancient, beautiful, perfect sphere of stars, hundreds of thousands, all born together 10 billion years ago. They orbit through the galactic halo, unchanged, preserving the early universe's conditions, low metallicity, old stellar populations, evolutionary stages, visible from main sequence to red giants to white dwarfs, a snapshot of stellar life, frozen in time, in their cores. Stars pass close, interact, form binaries, collide, merge, blue stragglers, formed through collision or merger, appear younger than possible. They've been rejuvenated, refreshed by cosmic violence, hidden beneath normal spectra, normal behavior, a secret, written in motion, in position, in mass. Your secrets are safe. No one needs to know. In sleep, there are no secrets, no truth, no lies, just experience without judgment, without meaning. Thoughts bubbling up, sinking down, neither true nor false, just phenomena passing through awareness or through nothing. Open clusters, younger, looser, Pleiades, Hyades, beehive, born together, hundreds of stars from one nebula, but gravity weak, tidal forces from the galaxy slowly dispersing them. Over millions of years, they spread, losing members, eventually completely dissolved. Stars scattered, their sibling relationship forgotten, unknowable. The sun probably had siblings, born in a cluster 4 billion years ago, now lost, anonymous among billions, never to be identified, never to be reunited. Separation is inevitable. Nothing lasts, nothing holds together forever. Let that comfort you. Nothing lasts means nothing matters, means you can release everything. All burdens, temporary, all joy, fleeting, all pain, passing. Just let the current carry you. No resistance, no effort, floating downstream toward sleep, toward dreams, toward nothing. Stars near. Sagittarius A, the galactic center's black hole, orbit in elliptical paths. S2 circles in 16 years. Closest approach 17 light hours from the event horizon, moving at 5,000 kilometers per second, 3% light speed. Time dilation measurable. General relativity tested, proven. Gravity warping space-time, slowing clocks, bending light. Beautiful mathematics made visible in stellar motion. At that speed, time passes slightly slower for S than for us. The difference, tiny but real. Relativistic effects, the universe, stranger than intuition suggests. Space, time, mass, energy, all interconnected, all flexible, all relative, like consciousness. Flexible, relative, slipping between states, waking, dreaming, sleeping, without clear boundaries, just gradients, transitions, fading. 136A1, most massive star known, 300 solar masses, shining with 5 million solar luminosities. Wind so strong it loses a solar mass every few million years, cannot last, already shrinking. When it explodes, it will outshine the full moon, briefly visible in daylight, for weeks, then fading, leaving a black hole. Perhaps 100 solar masses, the most massive stellar remnant possible. Darkness, born from ultimate light. Smallest stars, EBLM Jafar 57 Abe, barely massive enough for fusion. 8% solar mass, smaller, and it would be a brown dwarf, failed star, glowing only from contraction, but it made it barely fusion ignited, burning slowly, efficiently, for trillions of years. It will outlive everything. Last ember in a cold universe, still shining when galaxies have gone dark. You will not outlive even this night. Your consciousness, temporary, fragile, already fading, but that's okay. That's perfect. You don't need permanence. You just need this moment, and then release. Let it go. Let it all go. HD 14283. 14 billion years old, nearly as old as the universe. Metal poor, ancient, population 2, born in early galaxy, survivor, witness to cosmic history. What has it seen? the formation of galaxies, births of billions of stars, deaths, supernovae, but stars don't see, don't remember. They simply exist, shine, and die. No awareness, no experience, just physics playing out inevitably. Be like that. No awareness, no experience, just physics, breathing, automatic, heart beating, unconscious, brain activity, slowing, delta waves, rising, sleep, approaching, unstoppable. Let it come, welcome it, surrender to the inevitable, the natural, the necessary. In the far future, trillions of years hence, the last red dwarfs will finally exhaust their fuel, the stellar era ending, no more stars, no more fusion, only white dwarfs, neutron stars, black holes, and darkness. The black holes will evaporate through Hawking radiation, taking Google years, but inevitable. Eventually, even they will fade. The universe approaching heat death, maximum entropy. No more change, no more time, no more meaning, just uniform darkness forever. But that's, so far, unimaginably far. Right now, stars still shine, life still exists, you still breathe, even if barely, even if fading, still here, still existing for a few more moments before sleep takes you completely. The stars keep burning while you drift deeper. They don't need your attention. They were shining before you were born. They'll shine after you're gone, indifferent, eternal, beautiful. Let them keep watch while you let go, trusting the universe to continue without your participation, your observation, not required, your consciousness not necessary. Just release into darkness, into silence, into sleep. Stars breathing light into darkness, creating heavy elements, enabling planets, life, consciousness. Just so consciousness can look up, wonder, and eventually return to sleep. The universe creating witnesses to itself, then letting them rest. Eternal cycle of waking and sleeping, knowing and forgetting, being and not being. Your being is fading, now almost gone, just echoes of awareness, distant, unimportant, like starlight from the edge of the observable universe, redshifted, stretched, dimmed, almost invisible, almost nothing. And in that nothing, peace. In that absence, rest. In that darkness, home. Let the stars keep shining. Let the universe keep turning. Let yourself finally, completely let go. The universe keeps turning while the stars keep breathing light into the dark, and will keep drifting, floating together through the mysteries. And we'll keep drifting, floating together through the mysteries. 100 night sky mystery looping softly, endlessly through the night. Tonight we'll drift through the slow procession of the stars above ancient skies. Why the Milky Way seems to breathe across the seasons. How faint light travels for billions of years to reach your eyes. There's nothing you need to do now. Just let your body sink, heavier heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into night sky. Imagine the celestial sphere, that ancient dome, arching overhead, as if the universe were painted on the inside of a perfect bowl, curving down, down, to every horizon. The ancients saw it this way, this sphere, turning, slowly, carrying every star, every planet, in its gentle rotation, and your body feels that turning now, so slow, you barely notice, just your breath, rising, falling, like the sphere itself, breathing. The stars appear to move, not because they're rushing through space, but because you are, because Earth beneath you spins, one full rotation every 24 hours. And as you lie here, sinking deeper, you're spinning too, carried eastward at 1,000 miles per hour, though you feel nothing, nothing but stillness, nothing but the soft weight of blankets, of gravity, of sleep. Heavier, heavier. This rotation, this steady turning, makes the stars rise in the east, just like the sun, arc overhead through the night, and set in the west, disappearing, reappearing in an endless cycle, older than memory, the entire sky appearing to wheel around you, though really, it's you, turning beneath the fixed and patient stars. Feel that. Feel yourself turning slowly into darkness, into rest. The Earth spins on its axis, tilted 23.5 degrees, like a top, wobbling gently, and this tilt, this lean, gives us seasons, gives us summer stars, winter stars, the long nights, the short ones, all because of this angle, this ancient tilt, perhaps caused billions of years ago by a collision, a cosmic impact, when Earth was young, molten, new. And that tilt itself is slowly, so slowly, shifting the axis like a spinning top, precesses, traces a circle in space, taking 26,000 years to complete one full wobble. Your breathing slows in, out, so much faster than this cosmic drift, this precession of the equinoxes, discovered by ancient Greek astronomers, watching, measuring the slow, imperceptible shift of stars against the seasons. 5,000 years ago, Polaris wasn't the North Star. Another star, Thuban in Draco, marked true north for ancient civilizations, building their monuments, aligning their temples. And in another 13,000 years, Vega will be the pole star, the sky slowly, endlessly, rearranging its patterns, while you, here, now, sink deeper into this moment, this breath, this soft, descending, quiet. This gentle precession of Earth's axis continues its slow cycle every 26,000 years, shifting the pole star across the ages, the ecliptic, Imagine it, the path the sun appears to trace across the sky throughout the year, sliding through the zodiac, through those ancient constellations, Aries, Taurus, Gemini, and onward. This path, this ecliptic plane, is really the plane of Earth's orbit, and the planets travel close to this line, wandering, which is what planet means, wanderer in ancient Greek. All the major planets stay near this ecliptic because they formed from this same flattened disk of gas and dust that birthed our solar system long ago. These zodiac constellations, 13 of them actually, not 12. With Ophiuchus bridging between Scorpius and Sagittarius, these star patterns, so familiar, so loaded with myth and meaning, mark the ecliptic's path, where sun and moon and planets drift, month after month, century after century. Your eyes growing heavier, heavier, as you imagine those ancient patterns overhead in the darkness. Ophiuchus, the serpent bearer, reminds us how the constellations we inherited from antiquity were never perfectly fixed boundaries, but living maps of the wandering lights. Some stars never set, circumpolar stars, wheeling endlessly around the celestial pole, never dipping below the horizon if you're far enough north or south. In the northern hemisphere, Polaris sits nearly motionless, while the Big Dipper, Cassiopeia, other constellations, circle it throughout the night, throughout the year, always visible, always wheeling, patient, eternal. These unchanging circles in the sky offered ancient peoples a sense of cosmic stability amid the shifting seasons below. Polaris, the current North Star, isn't the brightest star, but it sits, by cosmic coincidence, less than 1 degree from true north, from the point in the sky directly above Earth's North Pole. Sailors used it for centuries to navigate, to find their way across dark oceans, beneath dark skies, always knowing Polaris meant north, meant home, meant direction in the vastness. Even today, in an era of GPS, many still feel a quiet reassurance looking up to see that steady, faint light holding its place. If you watch the stars for hours with a camera, its shutter open, you'd see star trails, circular streaks of light arcing around Polaris, each star tracing its nightly path, a record of Earth's rotation captured in light. The longer the exposure, the longer the arcs until dawn, when stars fade into blue, into daylight, into invisibility. Those graceful arcs reveal the invisible spin of our world, turning the night into a silent testament to motion we feel but rarely see. Your breathing, so slow now, in, out, like those arcs, those patient trails of light. Each inhale and exhale mirrors the steady turning of the heavens above you. A sidereal day is the time it takes Earth to rotate once, relative to the distant stars. 23 hours, 56 minutes, 4 seconds, slightly shorter than a solar day, which measures noon to noon, sun to sun. The difference, because Earth also orbits, moving along its path around the sun, so it must rotate a little extra to bring the sun back to the same position in the sky. This 4-minute difference accumulates over the year, causing the stars to rise about 4 minutes earlier each night. Feel your heart beat. Thump, thump, so much faster than these cosmic rhythms, these days upon days measured in starlight. Yet in this quiet space, your pulse gently aligns itself with the deeper, slower pulse of the universe. The moon, rising, setting, changing, always changing its face, its position, its presence in the night sky, sometimes full and bright, flooding the darkness with silver, sometimes a sliver, a whisper of light, sometimes invisible, new, hiding between earth and sun. Its wanderings against the backdrop of stars mark time in ways calendars can only approximate. The phases, waxing, growing, from new to crescent to quarter to gibbous to full, then waning, shrinking, gibbous to quarter to crescent to new again. A cycle, 29.5 days, over and over. The same face always turned toward Earth, locked by tidal forces, eons ago. This synchronous rotation binds the moon to us in an eternal tidal dance that shapes oceans and perhaps even ancient human rhythms. But not quite the same face. There's a wobble, a gentle rocking, called libration, allowing us to see over time about 59% of the moon's surface, not just 50. The moon nods yes, north to south, nods no, east to west, as it orbits, swinging slightly, revealing, hiding, revealing again, hidden valleys, ancient craters along its edges. Through libration, we glimpse secrets the moon keeps just out of permanent view, teasing us with glimpses of its far side. Let your jaw release, soften, like the moon's edge, blurring into sleep. Feel the tension melt away as softly as the lunar horizons fade into shadow. Earthshine, that faint glow, on the dark part of the moon, when it's a crescent, is sunlight reflected off Earth, bouncing onto the lunar surface. Leonardo da Vinci explained this 500 years ago, understanding that Earth shines too, that our planet glows bright and blue when seen from space, from the moon, illuminating lunar nights with ghostly light. This gentle earthlight reminds us that even in darkness, our world casts its own soft radiance outward. A blue moon doesn't mean the moon looks blue. It's the second full moon in a single calendar month, or the third of 4 full moons in a season. Rare enough to give us the phrase, once in a blue moon, though it happens every 2 to 3 years. The moon can look blue after volcanic eruptions, when particles scatter light, but that's different, rarer still. The phrase captures how uncommon yet predictable celestial events can feel in the span of a human life. Heavier, heavier, your limbs sinking into the mattress. Let gravity pull you deeper, as inexorable as the moon's gentle tug on the tides. A supermoon, when the full moon coincides with perigee, the moon's closest approach to Earth in its elliptical orbit, appearing slightly larger, slightly brighter, though the difference, subtle, about 14%, between the closest and farthest full moons. Still, it's a beautiful name for a beautiful sight. That bright disk, hanging low, massive seeming, near the horizon. When it rises large and golden, the illusion of nearness draws the eye and quiets the mind in wonder. A blood moon, the colour of the moon during a total lunar eclipse, when Earth's shadow falls across the lunar face. The moon doesn't disappear, but glows. Deep red, deep orange. This colour comes from Earth's atmosphere, bending sunlight, filtering out blue, projecting red, the same physics that makes sunsets crimson, now painting the moon in Earth's sunset colours. In that ruddy light, the moon wears our planet's atmosphere like a veil of shared twilight. Lunar eclipses, safe to watch, unlike solar eclipses, you can stare at the moon as it darkens, as it reddens, as Earth's shadow slowly creeps across. Mountains on the shadow's edge make it jagged, irregular, not a smooth arc, but a rough darkness, eating light. The uneven edge, etched by lunar peaks, reveals the rugged reality behind the perfect circle we imagine. Solar eclipses, rarer from any one location, occur when the moon passes between Earth and Sun, blocking that searing disk. In a total eclipse, day becomes night, stars appear, the temperature drops, birds fall silent, confused, and the sun's corona, its outer atmosphere, becomes visible, white streamers reaching into space, only visible when the bright disk is covered, hidden. The moon and sun appearing almost exactly the same size in our sky, a cosmic coincidence, perfect, precise. This fleeting alignment, where apparent sizes match so precisely, is a rare gift of perspective in our solar system. Penumbral eclipses, subtler still, when the moon passes through Earth's outer shadow, the penumbra barely dimming, barely noticeable, unless you're watching carefully. A ghost of an eclipse, a whisper, easy to miss, like the edge of sleep, blurring past conscious awareness. Its faint shading slips by unnoticed by most, much like the first gentle drift toward dreams. Your eyelids, so heavy now, let them close if they haven't already. Allow them to fall as naturally as night follows the fading light. The Milky Way, our home galaxy, a spiral of 400 billion stars. When you look up at that cloudy band, stretching across the darkest skies, you're looking into the flat disk of our galaxy, seeing the combined light of millions upon millions of stars, too distant to resolve individually, just light, merging, flowing, like milk, like a river, across the heavens. Gazing into it connects you to depths of space and time beyond any single lifetime. The galactic core, towards Sagittarius, appears brightest, most dense. In summer, from the northern hemisphere, it arches high, overwhelming, filled with structure, with dark lanes, with glowing regions. In winter, you look outward, toward the galaxy's edge, the Milky Way fainter, higher, toward Auriga, Perseus, still beautiful, but quieter, dimmer. Each season offers a different face of our galactic home inviting renewed wonder under changing skies. The Milky Way seems to breathe across the seasons, appearing, disappearing, changing position as Earth orbits, as our view shifts, always there, even when invisible, hidden by daylight, by moonlight, by city glow. Its presence endures unseen, a constant river of stars waiting for darkness to reveal it again. Dark nebulae, clouds of dust and gas, blocking the light of stars behind them. They look like holes, voids in the Milky Way, the great rift, splitting the band of light from Cygnus down through Sagittarius. Actually denser than surrounding space, these dark clouds, future stars, unborn, waiting in the cold, the dark. Within their obscuring embrace, new suns quietly gather strength for their eventual ignition. Let yourself sink into that darkness, that cosmic cold, transformed here into warmth, into rest, into the soft embrace of sleep. Embrace this welcoming void as a cradle rather than an absence. Emission nebulae, glowing clouds where stars have recently formed, energetic light from young stars, ionizes hydrogen, making it glow red, pink, like the Lagoon Nebula, the Eagle Nebula, stellar nurseries where gravity pulls gas together, tighter, tighter, until fusion ignites and stars are born. These radiant regions pulse with the raw energy of creation, painting the night with colour born of fire. Reflection, nebulae, blue clouds, where starlight scatters off dust particles. Blue light scatters more easily, so these nebulae glow soft blue around bright stars. The Pleiades, surrounded by reflection nebulosity, faint, delicate, captured in long exposure, invisible to eyes alone. Their ethereal blue veil whispers of gentle scattering, visible only when we linger long enough in darkness. Sinking, drifting, deeper now, carried on currents of quiet like dust motes in starlight. Open star clusters, loose groups, hundreds of stars, born together from the same cloud, still loosely bound by gravity. The Pleiades, the Hyades, visible to the unaided eye, soft knots of light. Binoculars reveal their beauty. Dozens of stars, siblings, slowly drifting apart over millions of years until they scatter, disperse, lose their family identity. These sibling groups remind us that even stars born in closeness eventually find their own paths across the galaxy. Globular clusters, ancient, dense, spherical swarms of hundreds of thousands of stars orbiting the galactic halo, older than the Milky Way's disk, perhaps 12 billion years old, nearly as old as the universe itself. These clusters, faint smudges to the eye, resolve in telescopes to incredible density. Stars packed so close, their night skies must be spectacular, filled with neighbours, impossibly bright. In their hearts, the night would blaze with countless close suns, a dazzling eternal daylight, star-forming regions where the universe makes new light. Orion Nebula, visible even in the city, a fuzzy patch in Orion's sword. In darkness, through binoculars, it reveals structure, wings, cavities, blown by stellar winds. 4 bright stars, the trapezium, at its heart, illuminating, sculpting the gas around them. The trapezium's fierce young light carves and illuminates this vast cradle of creation, stellar nurseries where infant stars, still wrapped in their birth clouds, glow infrared, invisible to our eyes, but seen by special cameras, by space telescopes, revealing protostars, disks of dust, where planets might be forming around stars, less than 1 million years old, cosmically newborn. These hidden disks hint at worlds yet to emerge, cradles within cradles in the ongoing story of formation. Thump, thump, your heartbeat, slow, so slow, matching now the unhurried tempo of cosmic birth and becoming. Stars have life cycles, born in nebulae, living millions, billions of years, fusing hydrogen to helium in their cores. Eventually, fuel runs low, the core contracts, heats, the outer layers expand, cool, and the star becomes a red giant, enormous, hundreds of times its original size. Betelgeuse, Antares, red giants visible to the unaided eye, near the end of their long lives. In their swelling red phase, they glow with a final expansive beauty before transformation. When a star like our sun dies, it sheds its outer layers, creating a planetary nebula, a shell of glowing gas, expanding, fading, over thousands of years. The core remains compressed, hot, a white dwarf, Earth-sized, incredibly dense. A teaspoon of white dwarf material would weigh tons on Earth. These remnants slowly cool over billions of years, fading to black. The glowing shell drifts outward like a last breath, leaving a dense ember to cool in silence. Heavier stars die differently, violently. When their cores collapse, they explode. Supernovae outshining entire galaxies for weeks, then fading, leaving behind expanding shells of debris, supernova remnants like the Crab Nebula, still expanding, still glowing from an explosion witnessed in 1054 by Chinese astronomers who recorded a guest star bright enough to see in daylight. Such cataclysms seed the cosmos with heavy elements, the very stuff from which new worlds and perhaps life arise. Let your muscles release, soften like stars, releasing their outer layers into space. Let every holding go, drifting free into the vast peaceful night of rest. Neutron star, cores of massive stars, compressed beyond white dwarf density, so dense a teaspoon would weigh billions of tons, a thimble outweighing Mount Everest. These remnants, only 20 kilometers across, spinning rapidly, some completing hundreds of rotations per second. Their extreme density crushes protons and electrons together into neutrons, creating matter so stable and strange it challenges our understanding of the physical world. Pulsars, neutron stars, with intense magnetic fields, beaming radiation from their poles. As they spin, the beam sweeps past Earth like a lighthouse, pulsing with incredible regularity, millisecond pulsars, keeping time better than atomic clocks, cosmic metronomes ticking away in the darkness. These precise pulses have allowed scientists to test theories of gravity and even search for ripples in space-time itself. Black holes, where gravity wins completely. Nothing escapes, not even light. The core of a massive star, collapsed to infinite density, a singularity, surrounded by an event horizon, the point of no return, space and time, distorted, broken, twisted into impossible shapes. We can't see black holes directly, but we see their effects, gas spiraling inward, heating, glowing, before vanishing forever. Around them, time itself stretches near the horizon, so that to a distant observer, anything falling in appears to slow and freeze eternally. Gravitational lensing, where massive objects bend space itself, light from distant galaxies curves around, creating multiple images, arcs, even Einstein rings, perfect circles of light, space acting like a lens, magnifying, distorting, revealing galaxies too distant, too faint to see otherwise. This natural telescope has unveiled some of the most remote and ancient galaxies, letting us peer billions of years back towards the dawn of cosmic structure. Your body, so heavy, so relaxed, bending into the mattress, into sleep. Feel every part of you yielding, curved gently like light around an unseen mass. Variable star, changing brightness over hours, days, years, pulsating, expanding and contracting, like cosmic hearts, beating, mirror in the constellation Cetus, brightening and dimming over 11 months, easily visible, then fading, nearly invisible, then returning. Their rhythmic changes offer a quiet reminder that even stars live through cycles of expansion and renewal. Cepheid variables, special pulsating stars whose period of variation relates directly to their true brightness. The longer the period, the brighter the star. This relationship, discovered by Henrietta Leavitt, allows astronomers to measure distances across the universe. By timing how fast a Cepheid blinks, we know its true brightness. Compare that to how bright it appears, and we know how far away it must be. Thanks to her insight, we learned the true scale of the cosmos, and that our Milky Way is just one island among countless others. Binary star systems, two stars orbiting each other, bound by gravity, sometimes close, touching almost, exchanging mass, sometimes wide, taking centuries to orbit. Many stars we think are single are actually double, triple, when examined closely. Albireo in Cygnus, a beautiful pair, one golden, one blue, visible in small telescopes, contrasting, dancing around their common center. In these graceful dances, stars share material, evolve together, and sometimes end their lives in spectacular shared cataclysms. Each slow beat echoes the patient rhythm of orbiting companions far above. Exoplanet transits, when planets orbiting distant stars pass in front from our viewpoint. The star dims slightly incredibly slightly, but measurably. This is how we've discovered thousands of planets around other stars, worlds we'll never visit, never see, except as the faintest dip in starlight, a shadow crossing a distant sun. These tiny eclipses have revealed diverse worlds, rocky, gaseous, scorching, or frozen, hinting at possibilities we can only imagine. The bare-eye planets: Mercury, Venus, Mars, Jupiter, Saturn, visible without telescopes, known since antiquity. Wandering among the fixed stars, they don't twinkle like stars do. They're disks, too large, averaging out atmospheric turbulence, steady points of light, moving slowly, night by night, against the zodiac. Their steady glow carried stories and calendars for civilizations, marking seasons and seasons of human wonder. Retrograde motion, when a planet appears to move backward against the stars for weeks or months. This happens when Earth, on its faster inner orbit, overtakes an outer planet, making it seem to loop backward, then forward again. This puzzled ancient astronomers who didn't understand. The planets orbit the Sun, not Earth. The loops they traced forced thinkers to reimagine the cosmos, shifting from Earth-centered to Sun-centered views. Conjunctions, when two planets appear close together in the sky, Venus and Jupiter blazing near each other, stunning. The actual distance between them, hundreds of millions of miles, but from Earth they seem to touch, to merge, to dance. These fleeting meetings remind us how perspective can create beauty from vast separation. Oppositions, when a planet lies opposite the Sun in Earth's sky, rising at sunset, setting at sunrise, visible all night at its closest, its brightest. Mars at opposition glows brilliant orange, unmistakable, commanding. Its closest approach in 60,000 years happened in 2003, when it outshone everything except the Moon and Venus. At such times, the planet feels almost touchable, pulling the gaze upward for hours. Planetary alignments, rare configurations, when several planets appear in a line across the sky or clustered in one region. Beautiful, but astrologically meaningless. Their gravity doesn't combine, doesn't affect Earth. Just geometry, just perspective, just light. Yet the sight still stirs awe, a momentary alignment of worlds in our shared sky. Soften your forehead, your eyes, your jaw, sinking deeper. Let the lines of tension smooth away like planets drifting back into quiet motion. Saturn's rings, visible through even small telescopes. Stunning, impossible seeming. Those rings, mostly ice, countless particles, each a tiny moon, orbiting together in a flat disk, so thin that when seen edge-on, they almost disappear. Every 15 years, Earth crosses the ring plane, and Saturn appears ringless, strange, before the rings slowly tilt open again. This periodic vanishing makes the rings feel even more precious, a temporary gift of cosmic geometry. The rings won't last forever. They're eroding, raining down onto Saturn, disappearing in 100 million years, perhaps less. They'll be gone. So we're fortunate to live in this moment when Saturn wears its crown of ice. Cherish the view we have now, knowing future eyes may never see Saturn so adorned. Jupiter's moons, the 4 largest, discovered by Galileo in 1610, visible through binoculars, 4 points of light, flanking the planet, changing position night by night as they orbit. Io, Europa, Ganymede, Callisto, each a world. Europa perhaps harbouring an ocean beneath ice. Io, volcanic, the most geologically active body in the solar system. Their ceaseless circling offers proof that motion and change continue even in the coldest reaches. Watching these moons, you can see the universe in motion, see orbits happening in real time over hours, moons disappearing behind Jupiter, reappearing, being eclipsed by Jupiter's shadow. Tiny dramas playing out 400 million miles away. Each eclipse and emergence unfolds like a miniature clockwork of the heavens. Phases of Venus, visible through telescope as it orbits between Earth and Sun. When Venus is far, on the other side of the Sun, it appears full but small. When near, between Earth and Sun, it appears as a crescent, but large, beautiful, changing, like the moon, but brighter, so bright it casts shadows on moonless nights. Its brilliance and shifting shape make Venus a mirror of lunar cycles, yet dazzling in its own right. Mars at opposition, glowing, fierce, ruddy. The opposition surge, enhanced by something called the opposition surge, light scattering back from Martian dust directly toward Earth, making the planet appear brighter, more intense. Watching Mars throughout the year, you can see it brighten toward opposition, then fade again as geometry shifts. This surge turns the red planet into a beacon, drawing the eye night after night. Let your breathing slow even more, in, out, like the planets in their orbits. Each breath traces an ellipse, calm and unhurried. Uranus and Neptune, barely visible to the unaided eye. Uranus, just possible, under dark skies, if you know exactly where to look, a pale greenish disk. Neptune, too faint, requiring binoculars, at least. These ice giants, distant, cold, taking decades, centuries to complete their orbits. Voyager 2, our only visitor, flew past in the 1980s, sending back our only close-up views. Their remoteness makes every glimpse feel like a rare message from the solar system's quiet frontier. The asteroid belt between Mars and Jupiter, millions of rocky fragments, leftovers from the solar system's formation, never coalescing into a planet because of Jupiter's gravity, stirring, disrupting, preventing. Most asteroids stay in the belt, safely distant, but some drift inward. Jupiter's influence preserved this scattered record of the early solar system, a museum of unfinished worlds, near-Earth asteroids, crossing Earth's orbit or coming close. Thousands have been discovered, catalogued, tracked, Most are small, harmless, but occasionally one passes nearby, within the moon's orbit, a reminder that space is full of debris, ancient rubble, still wandering. Our vigilant watch over them reflects both caution and curiosity about our place in a dynamic cosmos. Meteors, shooting stars, not stars at all, but tiny particles, grains of dust, pebbles from comets or asteroids, burning up as they hit Earth's atmosphere at thousands of miles per hour, the friction heating them white hot, incandescent for a second, 2 seconds, then gone, vaporized, streaks of light, wishes made on cosmic dust. Each fleeting streak is a brief visitor from distant origins, gone in an instant yet remembered. Meteorites, the rare ones that survive, that reach the ground, most small, but some massive, blasting craters, changing history. The Barringer crater in Arizona, nearly a mile across, 50,000 years old, carved by an iron meteorite, 150 feet wide, travelling 12 miles per second. These survivors carry stories of impacts that shaped landscapes and perhaps even life's path. Thump, thump, feel your heart. Slower now, slower. Let it settle into the deep, steady cadence of the sleeping Earth. Meteor showers, when Earth passes through debris streams, left by comets, thousands of particles entering the atmosphere, dozens per hour, hundreds at the shower's peak. The Perseids in August, the Geminids in December, reliable, annual, each shower seeming to radiate from a particular point in the sky. These annual displays turn the night into a gentle rain of light, predictable yet always wondrous. Radiant points, the perspective effect, making meteors appear to stream outward from one constellation, Perseus for Perseids, Gemini for Geminids, actually the particles, travelling on parallel paths, but perspective, like railroad tracks, seeming to converge in the distance to diverge nearby. The illusion binds the shower to a single origin, much as perspective unites distant stars. Fireballs and bolides, exceptionally bright meteors, brighter than Venus, sometimes bright enough to cast shadows, to light up the landscape. Some explode, fragmenting, leaving glowing trains that persist for seconds, minutes after the meteor has vanished. Sonic booms, occasionally rattling windows, startling but harmless. Their sudden brilliance can startle the night, then fade into quiet memory. Comets, dirty snowballs, icy nuclei a few miles across, orbiting the sun on long elliptical paths. When they approach, the sun's heat vaporizes ice, releasing dust and gas, forming the coma, the fuzzy head, and the tail, or tails, pointing away from the sun, pushed by solar wind, by radiation pressure. Their awakening near the sun transforms them from invisible wanderers into glowing spectacles. Some comets return regularly. Halley's Comet, every 76 years. Last visible in 1986, next in 2061. Others visit once, then depart on orbits taking thousands, millions of years, or escaping entirely into interstellar space, never to return. Each return or farewell marks a chapter in the long conversation between comets and our sun, the Oort cloud, hypothetical, vast, surrounding the solar system, 1 trillion comets, perhaps more, in a spherical shell, extending halfway to the nearest star. Occasionally, gravity nudges one inward, beginning its journey toward the sun, toward visibility, toward our skies. This distant reservoir quietly supplies the occasional bright visitor that graces our nights. The Kuiper belt beyond Neptune, another reservoir of icy bodies, including Pluto, now classified a dwarf planet, along with Eris, Makemake, and others. These distant worlds take centuries to orbit, frozen, dim, barely explored. New Horizons flew past Pluto in 2015, revealing mountains of ice, plains of nitrogen, a heart-shaped region, unexpected, beautiful. Pluto's heart and icy peaks showed us that even the farthest reaches hold surprises and subtle beauty. Zodiacal light, a faint pyramid of light extending up from the horizon after sunset or before dawn, best seen from dark sights in spring and autumn. This glow, sunlight scattered by dust particles orbiting the sun in the ecliptic plane, the same dust that makes meteors when Earth plows through. This soft cone links the planets, asteroids and comets in a shared veil of ancient debris, gently illuminating the edge of night. Gegenschein, even fainter, a diffuse glow, directly opposite the sun in the midnight sky, counterglow in German, caused by sunlight reflecting back from dust particles beyond Earth's orbit, incredibly subtle, requiring the darkest skies, the most patient eyes to perceive. This elusive opposite glow completes the zodiacal light's full circle, a quiet reminder of the dust that fills the inner solar system like an invisible halo. Airglow, Earth's atmosphere, glowing faintly all the time, even on moonless nights. Chemical reactions in the upper atmosphere, releasing light, green, red, across the whole sky. Too faint to see with the unaided eye, usually, but cameras capture it in long exposures, bands of colour, rippling, moving, evidence that our atmosphere is alive, reacting, glowing, even in darkness. This perpetual emission, powered by solar energy stored and released molecule by molecule, blankets the planet in a soft, ceaseless luminescence. Aurora borealis, the northern lights, shimmering curtains of green, red, purple, dancing across the polar sky, caused by solar wind, particles from the sun colliding with Earth's magnetic field, funneled toward the poles, striking atmosphere, exciting oxygen and nitrogen, making them glow. The colours depend on altitude on which atoms are struck. Each shimmering wave carries echoes of the sun's distant fury, transformed into silent beauty by our protective magnetic shield. Aurora australis, the southern lights, the same phenomenon in the Antarctic, equally beautiful, less often seen, simply because fewer people live that far south. But research stations, remote observers, witness displays, just as spectacular, mirroring their northern cousins across the planet's magnetic axis. The symmetry of auroras north and south reveals the unity of Earth's magnetic embrace, linking hemispheres in shared celestial fire. Strong solar storms can push auroras farther south, farther north, visible from middle latitudes, even from places that rarely see them. In 1859, the Carrington event, the largest recorded solar storm, brought auroras as far south as the Caribbean. Telegraph systems sparked, caught fire, the sky ablaze with dancing light. That historic storm reminds us how closely the sun's moods can touch and illuminate even the most equatorial skies. Light pollution, the enemy of dark skies, cities glowing, wasting light upward into space, obscuring stars, erasing the Milky Way. Most peoples now live under skies where the galaxy is invisible, where only the brightest stars pierce through. A loss, cultural, spiritual, disconnecting us from the cosmos. This artificial brightness severs an ancient human bond, replacing wonder with a narrower, brighter night. Dark sky reserves, protected areas where lighting is controlled, minimized, allowing the night to remain dark. These places, rare, precious, International Dark Sky Association certifies them, recognizes their value. Certain parks, certain communities, fighting to preserve what most have lost. In these sanctuaries, the night reclaims its depth, offering refuge for both wildlife and the human spirit. The Bortle scale measures sky darkness, from Class 1, pristine, to Class 9, inner city. In Class 1 skies, the zodiacal light is obvious. The Milky Way casts shadows. Clouds appear as dark holes against the glowing sky. In Class 9, only the moon, planets, and the very brightest stars are visible. The gradient of loss. Each step down the scale marks a quiet diminishment, a fading of the cosmic backdrop we once took for granted. Limiting magnitude, the faintest star you can see with the unaided eye. In perfect conditions, magnitude 6.5, maybe 7, representing stars, hundreds of times fainter than the dimmest stars visible from the city. Under urban skies, magnitude 3, 4 at best, 100 times fewer stars visible, a sky impoverished. That vast difference in visible stars measures not just light, but the gradual withdrawal of the universe from our unaided gaze. Atmospheric seeing, the steadiness of the air, turbulence, heat rising, wind shear, all blur. Astronomical images make stars shimmer, dance. On nights of good seeing, stars appear as steady points. Planets show crisp detail through telescopes. On poor nights, everything wavers, melts, frustrating observers. This is why major observatories sit on mountaintops above much of the atmosphere. Good seeing turns the sky into a sharp lens, letting distant worlds reveal their secrets with unusual clarity. Transparency, how clear the air is, humidity, dust, pollution, all scatter light, dim stars, reduce contrast. A transparent night with steady seeing is an astronomer's gift, rare, cherished. Such nights feel like a gift from the atmosphere itself, stripping away haze to unveil the sharpest, deepest views. Scintillation, the scientific word for twinkling. Stars twinkle because their light passes through layers of moving air, bending, shifting, changing intensity rapidly. Planets don't twinkle as much because they're disks, not points. The twinkling averages out. This difference helps identify planets from stars in the sky. The restless dance of starlight through air adds a living shimmer, a reminder of the fluid medium between us and the cosmos. Refraction near the horizon bends light from objects low in the sky. The atmosphere acts like a prism, lifting images slightly. The sun at sunset is actually already below the horizon when you see it, refraction pulling its image upward, an illusion, allowing a few extra minutes of daylight. This gentle lift grants us lingering views of setting suns, stretching twilight just a little longer. This refraction also flattens the sun and moon near the horizon, making them appear oval, squashed, the bottom edge lifted more than the top because it's deeper in the atmosphere. Subtle geometry, invisible to casual glance, but there, real. The squashed shape is a quiet optical poem, written by layers of air bending light in precise, unequal ways. The green flash, a rare phenomenon at sunset or sunrise. The very last bit of the sun flashing green for a second less, caused by atmospheric refraction, dispersing light like a prism. Green light, bent more than red, the last colour to disappear, requires perfect conditions, clear horizon, calm air. Sailors chased this sight for centuries. That fleeting emerald spark has inspired legends and longing, a final gift from the departing sun. Let your thoughts drift away like light dispersing into nothing. Release them gently, letting them fade into the quiet expanse beyond. Seasonal constellations changing throughout the year. Orion dominating winter skies. Scorpius in summer. These patterns rising and setting 4 minutes earlier each night, drifting westward through the seasons, because Earth orbits, changing our viewpoint, bringing new star to the evening sky, bidding farewell to others. This slow seasonal procession mirrors the wheel of the year, guiding us through cycles of presence and absence. The mythology of constellations, stories overlaid on randomness. These stars, unrelated, vastly different distances, appearing grouped only from our perspective, yet humans everywhere connected them, saw figures, heroes, animals, told stories, connecting earth to sky. In these imagined shapes, we find meaning, weaving our own narratives across the indifferent vastness. Orion the hunter, Ursa Major the great bear, Cassiopeia the queen. Each culture had different stories, saw different shapes. Aboriginal Australians saw the dark spaces as much as the stars, the emu in the sky, outlined by dark nebulae in the Milky Way, different lens, same sky. The emu reminds us that absence can be as powerful as light, shaping stories from the void between stars. Star names, many from Arabic: Betelgeuse, Aldebaran, Rigel, Deneb. These names, centuries old, from when Islamic astronomers preserved, expanded Greek knowledge during Europe's Dark Ages. Other names from Latin, Greek, Chinese, each star carrying history in its title. Every name is a thread of human curiosity, linking us across time to those who first charted the heavens. Ancient sky maps, scratched on cave walls, carved in stone, painted on tomb ceilings. The Nebra sky disk, Bronze Age, 3,600 years old, showing the Pleiade, the crescent moon, perhaps the earliest concrete depiction of celestial objects, evidence that humans have always looked up. That ancient disk speaks of an unbroken lineage of wonder, proof that the urge to gaze upward is as old as our species. Navigation by stars, how Polynesians crossed the Pacific, how Vikings sailed to Iceland, Greenland, using the sky as their map. Celestial navigation, reading latitude from star positions. Polaris's angle above the horizon equals your latitude in the northern hemisphere. Simple geometry that enabled global exploration. In the angle of a single star, ancient voyagers found direction, turning the night sky into the greatest map ever drawn. Cultural night skies, each tradition passing the heavens differently. The Chinese divided the sky into 28 mansions. The Egyptians aligned pyramids to stars. The Maya tracked Venus with incredible precision, predicting its appearances centuries in advance, all looking up, all finding meaning, pattern, connection. Indigenous sky stories, passed down verbally for thousands of years. Australian Aboriginal astronomy, perhaps the oldest, continuous astronomical tradition. Stories encoding seasonal information, navigation, calendars, embedded in mythology, science, and story intertwined. Stone Age astronomy, long before writing. Stonehenge, aligned to solstices. Newgrange, in Ireland, older than the pyramids, its passage illuminated only at winter solstice dawn. Megalithic alignments across Europe, tracking sun, moon, stars. Sophisticated understanding without telescopes, without math, just observation, patience, generations. Timekeeping by stars, the rising of particular stars, marking seasons. Sirius rising before dawn announced the flooding of the Nile for ancient Egyptians. The Pleiades, heliacal rising, marked harvest in Greece. Planting in other cultures. Stars as clocks, as calendars, as connections between cosmos and agriculture. Survival. Calendars and the sky. Lunar calendars, solar calendars, lunisolar, trying to reconcile. The moon's phases, with the sun's yearly cycle, the metonic cycle. 19 years equals 235 lunar months, almost exactly, discovered independently by cultures worldwide. The sky, teaching mathematics through simple observation, long exposure night photography, revealing what eyes can't see, the Milky Way's structure, nebulae glowing, colours emerging, reds and blues, invisible to our night-adapted vision, which sees mostly in black and white, cameras collecting light, minutes, hours, accumulating photons, building images of incredible depth, beauty, Milky Way photography, and art, science, finding dark skies, clear nights, the galactic core rising, composing the shot, foreground landscape, sky above, long exposures, wide apertures, high ISO, capturing the river of stars as our ancestors saw it before electricity, before cities, before we forgot the night, star color and temperature. The hottest stars burn blue, blue-white, stars like Rigel, Spica, cooler stars, yellow, like our sun, cooler still, orange, red, Betelgeuse, Antares. The color reveals temperature, composition, age, a rainbow of stellar physics, visible to the careful observer, spectral classes, OBAF-GKM, from hottest to coolest. Each class subdivided 0 to 9, our sun, G2, mid-range, common, unremarkable, except that it's ours. And in recent years, new classes, LTY, brown dwarfs, failed stars, too small to sustain fusion, glowing dimly in infrared, your body completely still now, sinking deeper while we drift through more mysteries, more whispers from the cosmic dark. Bare eye observing requires nothing but patience and darkness. No equipment, no technology, just your eyes adapting slowly to the night. It takes 20 minutes, 30 minutes for your pupils to fully dilate, for the rods in your retina to become most sensitive. Patience rewarded with fainter stars emerging like memories surfacing from deep water. This quiet adaptation transforms the ordinary night into a deepening revelation, layer by layer, as the universe slowly unveils itself to the waiting gaze. Averted vision, the technique of looking slightly away from what you want to see. The center of your retina, filled with cones for color, for detail, but less sensitive, in darkness. The edges, filled with rods, more sensitive, detecting fainter light. So you look beside an object, and it appears brighter, clearer, a paradox, seeing better by not looking directly. The gentle shift of focus teaches a deeper truth. Sometimes the most profound sights appear only when we stop staring straight at them. Let your eyes rest now, closed or nearly closed, feeling the darkness behind your eyelids like the darkness between stars. In that inner dark, the boundary between your vision and the cosmos softens, merging into one peaceful void. Binocular astronomy opens the sky, handheld telescopes, really, magnifying 7 times 10 times, revealing what eyes alone cannot. Star clusters resolving into individuals, the Andromeda Galaxy showing structure, detail, nebulae emerging from darkness, Jupiter's moons visible as tiny points flanking the planet. With this simple tool, the distant becomes intimate, turning faint smudges into recognizable worlds and gathering the scattered light of galaxies into something almost touchable. Binoculars have advantages over telescopes. Portable, affordable, 2 eyes instead of 1, creating depth, immersion. The field of view, wide, sweeping. You can scan the Milky Way swimming through starfields, lost in the abundance of light. That wide binocular embrace invites a sense of swimming through the stars rather than merely observing them from afar. Some observers prefer binoculars, always. The immediacy, the freedom, no setup, no alignment. Just step outside, look up, and see double stars, variable stars, comets, all accessible, all beautiful, through simple glass and darkness. For many, binoculars remain the truest companions of the night, uncomplicated, always ready, offering discovery without the weight of expectation. Heavier, heavier, your breathing, slowing to match the patient pace of observation. Each slow breath carries you further into the calm rhythm that mirrors the unhurried unfolding of the sky. Telescopes reveal deeper still. Refractors, using lenses. Reflectors, using mirrors. Each design with advantages, compromises. More light gathered, fainter objects visible. Higher magnification, planets showing detail. Saturn's rings, Jupiter's bands, Mars's polar caps, the moon's craters, crisp, sharp, impossibly detailed. Through that gathered light, the telescope becomes a bridge across unimaginable distances, bringing the remote and ancient into the present moment. The first time someone looks through a telescope at Saturn, they often gasp or fall silent. It seems impossible that this icon, this symbol, exists, really exists, as a physical object hanging in space. Those rings, real, ice particles, orbiting, governed by gravity, by physics. Not a picture, not an illustration, but Saturn itself. Light, travelling 90 minutes from there to your eye. That gasp is the sound of awe breaking through, the instant when a childhood symbol becomes a tangible living world suspended in the dark. Optics, the science of bending light. Lenses, focusing rays to a point. Mirrors, reflecting, collecting. The larger the aperture, the more light gathered, the fainter the objects visible. An 8-inch telescope gathers 4 times more light than a 4-inch, revealing twice as many stars, going twice as deep into space, into time. Each increase in aperture is a quiet act of reaching farther back in cosmic history, capturing photons that left their sources long before humanity existed. Thump, thump, your heart, beating slower now, relaxed, at peace. Let that gentle rhythm settle, echoing the steady pulse of light arriving from distant ages. But telescopes have limits. Magnification can't be increased indefinitely. The atmosphere, turbulent, blurs details. Beyond a certain point, empty magnification, making things larger, but not clearer, just blurrier. The art is finding the balance, clarity and size, detail and brightness. Each night, different. Each object, requiring different approaches. Mastery lies not in pushing harder, but in learning to listen to what the sky offers on any given night. Sky charts, planispheres, printed maps of the heavens, rotating wheels showing which constellation are visible at any hour, any date. Turn the dial to your time and see what's overhead, what's rising, what's setting. Ancient tools, still useful, still elegant, requiring no batteries, no screens, just paper, alignment, knowledge, passed down through generations. These simple wheels carry centuries of accumulated wisdom, turning the turning sky into something predictable yet endlessly wondrous. These charts teach patterns, relationships between stars, the summer triangle, Vega, Deneb, Altair, the winter circle, Sirius, Procyon, Pollux, Capella, Aldebaran, Rigel, forming a vast hexagon spanning half the sky. Learn these patterns and you're never lost. The sky becomes familiar, friendly, knowable. Once the patterns take root, the vast dome feels less like chaos and more like a familiar room filled with old friends. Let your thoughts drift like constellations, rotating slowly across the dome of your mind. Allow them to circle gently, unhurried, as constellations do across the seasons. Apps for night sky tracking, modern tools, smartphones, tablets, pointing at the sky, identifying what you see. Augmented reality, overlaying names, lines, information onto the real view. Hold up your phone and learn instantly what you're looking at. These glowing screens serve as patient guides, whispering names and stories to anyone willing to lift their eyes and ask. Some purists resist this, preferring charts, star hopping, the old ways. Others embrace the accessibility, the learning, the quick identification. Perhaps both have value. Technology lowering barriers, making the sky less intimidating, more welcoming to newcomers, while traditional methods develop deeper understanding, connection, patience. Whether through ancient paper or modern light, the goal remains the same: to meet the night with curiosity and wonder. The apps can show the sky at different times, past, future, simulating how the sky looked centuries ago will look centuries hence. The planets rewinding, forwarding, eclipses, conjunctions, oppositions, all predicted, all visualized. The computer calculating what once required years of observation, mathematics, careful record keeping. In their simulations, we glimpse the timeless dance of the heavens, past and future collapsing into the quiet now. Seasonal sky changes, the slow, inevitable rotation of constellations, Orion dominating, Winter evenings, gone by summer, replaced by Scorpius. Low in the south, by Sagittarius. The teapot, pointing toward the galactic core. Each season brings its own sky, its own character, its own memories. These seasonal shifts weave the sky into the fabric of our lives, marking time with light rather than clocks, heavier, sinking deeper into the mattress, into yourself. Let gravity draw you inward, as steady and gentle as the turning of the seasons above. Spring brings Leo, Virgo, Booters, the bright stars, Regulus, Speaker, Arcturus, forming a long arc. Follow the arc of the Big Dipper's handle to Arcturus. Continue the curve to Spica. Arc to Arcturus. Speed on to Spica. A mnemonic passed down. Teacher to student. Parent to child. Stargazer to stargazer. That flowing arc becomes a memory thread, linking generations of watchers who followed the same curve across spring nights. Summer, the Milky Way, arching overhead, the summer triangle, bright and bold. Cygnus the swan, flying south, down the galactic plane. The Northern Cross, another name for the same pattern. Deneb at the head or tail, depending on your perspective. Albireo at the base or beak, that beautiful double, gold and blue. In summer the galaxy feels close, its river of light inviting you to lose yourself in its endless flow. Autumn brings Pegasus, the great square, nearly empty, of bright stars inside, a guide to darkness, to the quality of your sky. How many stars can you count within the square? None under city lights. 5, 10, 20 under dark skies. A simple test of light pollution, of atmospheric clarity, of how much the universe reveals to patient eyes. The great square stands as a quiet mirror, reflecting back the depth of darkness you have found or lost. Winter, the richest season for northern observers. Orion, blazing. Taurus, the Pleiades. Gemini, Auriga. Canis Major with Sirius, the brightest star in the entire night sky. Cold air, crisp, steady, making stars less twinkly, more defined. The price of cold fingers, frozen breath, rewarded with spectacular views. Winter's sharp clarity turns every star into a diamond point. A quiet compensation for the season's chill. Thump, thump, barely perceptible now, your heartbeat fading into background, into sleep. Long-term sky cycles and beyond seasons, beyond years. The Saros cycle of eclipses, 18 years, 11 days, 8 hours. After one Saros, eclipses repeat, almost identically, slightly shifted. This cycle, known to ancient Babylonians, used to predict eclipses centuries in advance. The sky, regular, mathematical, predictable. Despite its vastness, the Metonic cycle, 19 years, equals 235 lunar months, almost exactly. So the moon's phases repeat on the same calendar dates every 19 years. Your birthday moon will be the same phase 19 years later. 38 years. 57. A personal connection to cosmic rhythm. Precession, that slow wobble of Earth's axis, changes everything over millennia. 26,000 years for one complete cycle. The zodiac constellations shifting relative to seasons. When astrology was formalized 2,000 years ago, the sun at the spring equinox was in Aries. Now it's in Pisces, moving backward through the zodiac, one constellation every 2,000 years, approximately. Let your body release completely. Nothing holding on, nothing resisting, just releasing into gravity, into rest. The North Celestial Pole, where Polaris sits now, will trace a circle through the sky over those 26,000 years. Different stars becoming pole stars, then moving on in the future. Vega, bright and blue, will mark north for our descendants. In the past, Thuban in Draco guided ancient Egyptian architects, aligning pyramids to their contemporary north, the sky. 10,000 years ago, recognizable but different. Constellations, stretched, warped, slightly, by proper motion, the individual movement of stars through space. Orion's belt, more curved, the Big Dipper's handle, straighter, different pole star. Vega was closer then to marking north than it is now. Prehistoric humans saw nearly the same stars, organized them differently, told different stories, but the raw material almost identical. They watched the same Sirius rising before dawn in summer, the same Aldebaran glowing red in Taurus, the same Pleiades clustered like diamonds on velvet. 10,000 years ago, the Sahara was green. Humans hunting, gathering, looking up at dark skies, unmarred by cities, unspoiled by light. The Milky Way, overwhelming, dominant, impossible to ignore. Did they wonder about those clouds of light? Did they imagine other worlds, or see only mystery, beauty, divinity? Heavier, heavier, words themselves becoming heavy, difficult, unnecessary. The sky, 10,000 years from now, will be different, more noticeably changed. Constellation shapes distorted, some stars moving relative to others. The Big Dipper becoming less dipper-like, handle bending, bowl stretching, eventually unrecognizable, though that takes 50,000 years, 100,000, longer than human civilization has existed so far. Betelgeuse might have exploded by then, gone supernova, outshining everything briefly, then fading, leaving behind a neutron star or black hole and an expanding shell of glowing debris, or it might not have. Stellar evolution, predictable in general, uncertain in specifics. We know it will happen. We don't know when Polaris will have moved away from the pole. Gamma Cephei taking its place around the year 3100, then others in sequence. The sky turning on timescales beyond human perception, yet real. measurable, inevitable. In 10,000 years, humanity, if it survives, will likely be very different. Spacefaring, perhaps, with telescopes, in space, above atmospheres, above light pollution, seeing the universe with unprecedented clarity, or perhaps we'll have destroyed ourselves, and the night sky will shine on an empty earth, empty cities, overgrown, reclaimed by nature. The stars don't care which future unfolds. They'll shine regardless, for billions of years more, until they too exhaust their fuel, expand, collapse, explode, or fade. Everything, temporary, even stars, even galaxies, even, perhaps, the universe itself. Thump, thump. But that's so far away, so unimaginably distant. Tonight, now, this moment, the stars shine, you breathe, the earth turns, the cosmos continues, and that's enough, more than enough. The silence of the night sky, profound, absolute, no sound, travels through vacuum, the stars exploding, colliding, forming, all in perfect silence. If you could hear the universe, it would be deafening. Supernovae, pulsars, black holes, colliding, neutron stars, merging, unimaginable violence, rendered silent by the absence of medium to carry sound. Here, on Earth, beneath atmosphere, we have sound. Wind, rustling leaves, distant traffic, dogs barking. Even in the quietest places, some sound, always. But looking up, you're seeing silence, pure visual experience. No soundtrack, just light, ancient light, traveling through perfect quiet. This silence, calming, the night sky, not demanding, not insisting, just being there, present, patient, waiting for those who choose to look indifferent to those who don't. The universe requires nothing from us, expects nothing, judges nothing, just exists, vast, silent, beautiful. Let yourself sink into that silence, that vastness. Nothing required of you, nothing expected, just rest, just peace, just being. The scale impossible to grasp. Truly, a light year, 6 trillion miles. The nearest star, 4 light years, 24 trillion miles. The galaxy, 100,000 light years across the observable universe, 93 billion light years in diameter. Numbers too large to hold, to feel, to understand. They wash over you, leaving only a sense of smallness, of insignificance. Paradoxically, comforting. You don't matter to the universe. Your worries, your fears, your regrets, your plans. The stars don't notice. The galaxies don't care. And somehow, that's freeing. That's peaceful. You can let go. You can rest. You're small. You're temporary. You're insignificant. And that's okay. That's beautiful. Even for this moment, you exist, conscious, aware, able to see, to wonder, to appreciate the universe, experiencing itself through you. Brief, flickering, temporary, but real, but here, but now. heavier, heavier, letting go of meaning, of significance, of self, just sensation, just breath, just the slow descent into sleep. Your ancestors looked up at these same stars, felt this same wonder, this same smallness. Your descendants, if you have them, will do the same. The stars, connecting generations, across centuries, millennia. All of us, looking up, wondering, feeling small and connected and temporary and eternal. The night sky doesn't change or in human lifetimes, not noticeably. It's the closest thing we have to permanence, to stability in an ever-changing world. Empires rise and fall. Technologies appear, cities grow, decay, but the stars remain, nearly unchanged, faithful, constant, patient. This constancy, comforting, reassuring. No matter what happens in your life, in the world, the stars will be there, shining, silent, infinite, waiting for you to look up, to remember what you're part of, where you come from, how small and precious and temporary you are. Thump, 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 fading now, fading. Let the sky hold you. Let the darkness embrace you. Let the silence soothe you. Nothing to do, nowhere to go, just here, just now, just breathing, just being, just drifting away. Your eyes closed, your body still, your mind quiet. The universe, vast, above, around, within, all connected, all one, all fading into sleep, into dreams, into the soft, eternal, dark. The mysteries continue. The night sky was whispers, and you drift deeper, deeper into rest. The scale of silence extends beyond what we can hear. Light, travelling for years, centuries, millennia, arriving without sound, without announcement, just appearing on your retina. A photon, born in a star 8,000 years ago, crosses the galaxy, survives interstellar space, Earth's atmosphere, and strikes one receptor in your eye. Mission complete, information delivered in silence, in darkness, patient beyond measure. Some of those photons absorbed by dust, never reaching Earth. Others bent by gravity, diverted, delayed, arriving later or earlier than expected. Each photon with a story, a journey, most lost, scattered, absorbed. Only the successful ones, the survivors, create the image you see when you look up. Let your breathing become even slower, softer, like light, fading into distance. The human eye is remarkably sensitive. In perfect darkness, after full adaptation, you could theoretically see a single photon if your brain processed it. Usually, it takes 5 to 7 photons, arriving nearly simultaneously, to trigger conscious perception. So few, so delicate, yet enough to see stars thousands of light years away. Your eye is a time machine. Looking at Vega, you see light that left that star 25 years ago. Looking at Deneb, 1800 years. The Andromeda Galaxy, 2.5 million years, you're seeing the past directly. The universe as it was, not as it is. Everything delayed by the finite speed of light. This means the universe you perceive doesn't exist. Not anymore. Not in that configuration. Stars have moved. Some have died. New ones have formed, but their light hasn't reached you yet. You'll see those changes. Eventually, years from now, centuries from now, the universe constantly updating, but always showing you its history, never its present, heavier, sinking deeper into layers of time, of consciousness, of rest. Telescopes extend this principle. Looking through a large telescope at a distant galaxy, you might see it as it was when Earth was forming, when dinosaurs walked, when humans first stood upright. The deeper you look, the further back you see. Astronomy is archaeology, excavating, not dirt, but time itself. The James Webb Space Telescope, looking back 13 billion years, nearly to the Big Bang itself. Seeing galaxy forming, infant galaxies, awkward, irregular, not yet, the elegant spirals. We know today, this is cosmology, watching the universe grow up, evolve, change from simple to complex, from smooth to structured. But you don't need a space telescope to time travel. Just your eyes, just a dark sky, just patience. The light reaching you from any star left that star before this moment, sometimes just minutes before, if you're looking at the sun, usually years, decades, centuries, the universe teaching you that now is relative, that simultaneity is illusion, that everything is delayed, separated by distance and time. Thump, thump, your heartbeat almost imperceptible, like the pulse of the universe, slow, patient, eternal. Photography changed astronomy before cameras, astronomers sketched what they saw, drew nebulae, planets, star clusters by hand. Beautiful drawings, subjective, limited by human perception, by expectation. People drew what they expected to see, often missing what was actually there. Cameras don't have expectations. They record photons accumulating light over minutes, hours, revealing faint structures, invisible to the eye. The first photographs of the Orion Nebula shocked observers, so much more than anyone had seen. Extensions, tendrils, colours, detail, beyond imagination. Long exposures reveal the universe as it truly is, not as we see it, but as it exists. Faint galaxies, distant nebulae, the colours of stars, of gas clouds, reds, blues, greens, purples, invisible to dark adapted eyes, which see mostly in monochrome. Camera see what we cannot, extending our senses, our reach, our understanding. Modern astrophotography combines art and science, stacking dozens, hundreds of exposures, aligning them precisely, removing noise, enhancing signal. The final image represents hours of collected light, processed, refined, showing details that no single observation could reveal. Let your eyelids rest, heavy, still. Your eyes don't need to see anymore. Your mind can show you the stars from memory, from imagination, from the deep, ancient connection we all carry. Amateur astronomers with backyard setups now capture images rivaling professional observatories from decades past. Technology democratizing space, charge-coupled devices, CCDs, CMOS sensors, sensitive, affordable, computer processing, sophisticated, accessible. Anyone with dedication can photograph galaxies, nebulae, revealing their own piece of the universe to share with the world. Some spend entire nights tracking targets, collecting photons. Others prefer just looking. No camera, no recording, just the ephemeral experience. The photons entering their eye, processed by brain, remembered imperfectly but intimately, both valid, both beautiful. Different approaches to the same infinite sky. The moon is the easiest target for photography. Bright, close, detailed. Any camera can capture it. Even phones now produce stunning lunar images, craters, Maria rays, mountains, all visible, frozen in a single frame. The same moon humans have photographed for 170 years. Since Daguerre, since the birth of photography itself. Planets require more skill, small, requiring magnification, fighting atmospheric turbulence, lucky imaging, taking thousands of frames, keeping only the sharpest when atmosphere steadies momentarily, stacking the best, creating an image clearer than any single frame, revealing Jupiter's storms, Saturn's rings, Mars's features with remarkable clarity, heavier, every muscle releasing, surrendering to gravity, to stillness. Deep sky objects demand dedication, hours of exposure, precise tracking, dark skies, patience, but the results, extraordinary, personal images of the Andromeda Galaxy, of the Orion Nebula, of star clusters that you captured yourself, light that travelled thousands of years to reach your camera sensor, preserved forever in digital memory. Some photographers spend years on a single target. The Hubble Space Telescope pointed at the same patch of sky for 11 days. The Hubble Ultra Deep Field revealing 10,000 galaxies in a region the size of a grain of sand held at arm's length. The faintest galaxies, 32 billion light years away, their light stretched, red-shifted by expanding space. You could spend 1,000 lifetimes imaging the sky and never capture everything, never exhaust the possibilities. Infinite targets, infinite variation, infinite beauty, the universe, providing endless inspiration, endless mystery, endless Wonder. The sky changes, subtly, constantly. Planets moving against the stars, comets appearing, disappearing, asteroids drifting through, new supernova flaring up in distant galaxies, variable stars brightening, dimming, the sky dynamic, living, evolving, despite appearing eternal, unchanging, fixed. Thump, thump, slower still, barely there. Dedicated observers monitor targets nightly, weekly, tracking asteroid positions, measuring variable star brightnesses, searching for supernovae in distant galaxies, amateurs contributing to science, discovering comets, asteroids, variable stars, their names attached forever to their discoveries, small immortality in the vastness, the universe, rewards, patience, consistency, attention. Those who watch regularly notice changes, patterns, rhythms. The casual observer sees a snapshot, static, unchanging. The dedicated observer sees motion, evolution, story, unfolding across nights, weeks, years, decades. Some observers keep journals, sketching what they see, recording dates, times, seeing conditions, equipment used, objects observed. Over years, these journals become treasures, personal histories of observation, of learning, of connection with the sky. Looking back through old entries, remembering that night, that moment, that first glimpse of Saturn, of the Andromeda Galaxy, of the Pleiades, in binoculars. Astronomy teaches patience. Things happen slowly. Planets taking weeks to cross a single constellation, comets brightening over months, variable stars cycling over days, years, everything requiring, waiting, watching, returning, night after night, slow rebuilding, understanding, familiarity, relationship with the sky. Let your mind slow to match this cosmic pace. Thoughts like planets drifting, taking months to move, eventually stopping completely. Just stillness, just darkness, just rest. Modern light pollution has costs. Beyond losing the Milky Way, circadian rhythms disrupted by constant light, migrating birds confused by city glow, crashing into buildings, sea turtle hatchlings disoriented, crawling toward streetlights instead of ocean. Ecosystems evolved for billions of years with dark nights, now bathed in artificial light, disrupting breeding, feeding, navigation. Humans, too, suffer. Melatonin production suppressed by blue light, sleep disrupted, health impacts, depression, obesity, diabetes, possibly linked to chronic light pollution. We evolved under dark skies. Our bodies expect darkness, need darkness for proper function, for rest, for health. Some cities now transitioning to better lighting, shielded fixtures, pointing down, not up, warmer colours, less blue, dimming after midnight when fewer people are outside. These changes reduce sky glow, improve star visibility while maintaining safety, security, a compromise benefiting everyone, everything. Dark sky preserves offer refuge for both humans and wildlife. Places where natural darkness is protected, maintained, where the Milky Way still dominates, where nocturnal animals thrive, where people can experience the sky as ancestors did, a reminder of what we've lost and a hope for what we might reclaim. Heavier, everything heavier, thoughts, words, meanings, all dissolving into sleep. The International Astronomical Union designates official names for stars, planets, features, standardizing, so everyone uses the same terms. Most stars don't have names, just catalogue numbers. HD 294558, Kepler 4522, Gliese 5581, thousands, millions, billions of stars. Most anonymous, just numbers in databases. Their light reaching us, but their names unknown, unknowable. A few hundred stars have traditional names passed down from Arabic, Greek, Latin, Chinese, Betelgeuse, Rigel, Aldebaran, Antares. Names with history, with meaning, some translated as the follower, the foot, the rival, describing position, colour, relationship to other stars. Recently, the IAU allowed public naming campaigns for exoplanets, systems, thousands submitted, suggestions, voting, deciding, winners announced. Now those distant worlds have names: Poesisia, Sazasa, Trappist, familiar words for alien places, bringing them somehow closer, making them more real, more knowable. But most of space remains nameless nebulae, identified by catalogue numbers Messier 42 NGC 1976, both names for the Orion Nebula, galaxies IC 342 UGC 1810, ESO 269 G57, cold designations for warm, glowing objects of incredible beauty. The universe, too vast for poetry to label everything. Perhaps it's appropriate. Most things need no names, no labels, no designation. They simply exist, glowing, spinning, evolving, in silence, in darkness, witnessed or not, named or not, unchanged. By our attention, our categories, our understanding, let yourself become nameless too. No identity, no story, just existence, just consciousness, fading, just the slow descent into nothingness, into everything, into sleep. The stars above don't know you're watching, don't know you exist, don't know Earth exists. They shine into void, their light spreading in all directions, only a tiny fraction intercepted by planets, by moons, by spacecraft, by eyes, most travelling forever into expanding space, never striking anything, wasted from one perspective. But light doesn't care. It's not wasted, it's not saved. It simply travels until it doesn't. Your existence, similar, brief, travelling through time, toward an end, inevitable. Consciousness, flickering, temporarily, then fading back into the unconscious universe. Not sad, just factual, just the way things are, temporary patterns in temporary matter, briefly aware, then not. But right now, you're aware, barely, consciousness, flickering, like a distant star, fading, growing dimmer, soon to disappear, into sleep, into unconsciousness, temporary death. And that's good, that's rest, that's necessary, that's what you need. Release everything, let go of all of it, the facts, the numbers, the names, the stars, the galaxies, the universe, even awareness itself. Let it drift away like light into distance, dimming, fading, going, gone. Silence, scale, darkness, distance, time, space, all concepts dissolving into nothing, into sleep. Your body, still. Your breath, barely. Your mind, empty. The universe, vast, and you, small, floating, fading, sinking deeper into the soft, the quiet, the deep, eternal night, distance to stars, measured by parallax, watching a star shift position slightly as Earth orbits. The greater the shift, the closer the star. Nearby stars, like Alpha Centauri, show measurable parallax. Distant stars, shifts too small to detect from Earth, requiring space telescopes, Gaia, measuring billions of stellar parallaxes, mapping the galaxy. Light years explained, the distance light travels in 1 year, 6 trillion miles, about 10 trillion kilometers. The nearest star, Proxima Centauri, over 4 light years away. Its light left that star over 4 years ago. Before reaching your eyes tonight, we see the past always. When we look at stars, cosmic background light, faint glow from all the galaxies, too distant, too faint to see individually. Their combined light filled space, a diffuse background discovered by measuring the overall brightness of the sky. Between stars, evidence of billions of galaxies beyond our sight. Faint galaxies overhead, millions of them in every direction, most invisible to the unaided eye. But there, filling the universe, each galaxy, hundreds of billions of stars. The Hubble Deep Field pointed at a tiny patch of seemingly empty sky, revealed thousands of galaxies in that speck. Alone, Andromeda, the nearest large galaxy, visible to the unaided eye, a faint smudge in the constellation Andromeda, 2.5 million light years distant. Its light began its journey before humans existed, photons traveling through space, while on Earth, ice ages came, went, species evolved, vanished. The Andromeda galaxy, larger than the Milky Way, approaching us. Blue shifted. We're falling together, pulled by mutual gravity. In about 4 billion years, we'll collide, merge, forming an elliptical galaxy. Milkomeda, someone called it. But individual stars, so far apart, won't collide. the galaxy as we'll pass through each other like ghosts, local group galaxies, Andromeda, the Milky Way, Triangulum, and dozens of smaller satellites, dwarf galaxies, orbiting the larger spirals, the Magellanic Clouds, visible from the southern hemisphere, irregular galaxies, satellites of the Milky Way, currently being torn apart by tidal forces, streams of stars, pulled free, orbiting, merging, deep sky observing, requires dark skies, patience, averted vision, looking slightly to the side, using the more sensitive rods in peripheral vision. Objects, invisible when looked at directly, appear when gazed at indirectly. The Andromeda Galaxy grows when you don't quite look, heavier and heavier, sinking into the mattress, into the pillow. Telescopes reveal what eyes cannot: faint nebulae, distant galaxies, details on planets, but the unaided eye has its own magic, immediacy, the sense that you're directly connecting, no glass between you and ancient light. That photon hitting your retina travelled uninterrupted across light years, centuries to reach you. This moment, this breath, every star you see without a telescope lies within about 1,000 light years. Most much closer. Our neighbourhood, our local bubble, within the vast spiral of the Milky Way, further star, too dim, lost in distance. But these visible ones, these points of light, are still suns, possibly with planets, possibly with life, looking back at us. Feel your breathing, slow, slower, in, out, like light, travelling, patiently. The universe is mostly empty, vast distances, between stars, between galaxies. If the sun were a basketball, Earth would be a peppercorn, 8 city blocks away. Pluto, a grain of sand, miles distant. The nearest star, another basketball, 4,000 miles away. Emptiness, cold, dark, broken only by tiny islands of warmth, of light. Yet this emptiness isn't truly empty. Quantum fields pervade all space. Dark matter, invisible, undetectable, except through gravity, holds galaxies together. Dark energy, even stranger, pushes the universe apart, accelerating its expansion. 95% of the universe is dark matter and dark energy. We see only 5%, only the bright fraction. The night sky teaches humility, scale beyond comprehension, age beyond imagining, billions of years, billions of light years, our lives, so brief, so small. Yet here we are, conscious, aware, able to measure, to understand, to appreciate. We are the universe, looking at itself, thinking about itself. Thump, thump, your heartbeat echoing the pulse of distant pulsars in ancient times, before telescopes. People saw only about 6,000 stars, total, visible from any location. With binoculars, 100,000. With telescopes, millions, billions. And still, we've barely started counting 400 billion stars in our galaxy alone. 2 trillion galaxies in the observable universe, numbers too large to grasp, to feel, to hold in mind. Yet each photon, each particle of light that reaches you, connects you to that distant star, that ancient past. You are touching, literally, the cosmos. When you see starlight, the atoms in your body were forged in stars, long dead. You are star stuff, as Carl Sagan said. The universe, made conscious, looking back at its own history. Some stars you see tonight no longer exist. Supernovae, centuries ago, millennia ago, their light, still travelling, still reaching Earth. Ghosts, already gone, but still visible. The sky, a museum of cosmic history. Light from different eras, arriving simultaneously at your eyes. Other stars are being born right now in nebulae, too distant, too faint to see. Their light hasn't reached us yet, won't reach us for thousands of years. The universe, always creating, always destroying, always changing, though from our perspective, everything seems eternal, fixed. Let your thoughts dissolve into vastness, into silence. Early astronomers, Hipparchus, Ptolemy, catalogued stars, measured positions, created systems to predict planetary motions, wrong in details, geocentric, Earth at center, but accurate enough for navigation, for calendars, for understanding patterns in the sky. Copernicus put the sun at center. Galileo, with his telescope, saw moons orbiting Jupiter, proving not everything orbits Earth. Kepler discovered planets move in ellipses, not circles. Newton explained why. Gravity, holding the solar system together, each generation seeing further, understanding deeper. Herschel discovered Uranus, the first planet, unknown to ancients. Then Neptune, predicted mathematically, before being seen, based on Uranus's wobbling orbit. Something was pulling it. Eventually, telescopes found Neptune, where calculations said it must be. Triumph of reason, mathematics, physics, prediction confirmed. Hubble, in the 1920s, proved galaxies exist. Beyond the Milky Way, the universe, suddenly, unimaginably larger. Then he discovered galaxies are receding. The more distant, the faster. The universe is expanding, growing, stretching, space itself, flowing outward, carrying galaxies like leaves on a vast cosmic river. This expansion implies the universe had a beginning. 13.8 billion years ago, the Big Bang, everything condensed, infinitely hot, infinitely dense, then expanding, cooling, forming particles, atoms, stars, galaxies, planets, us. The night sky shows us this history, this evolution, written in light. Thump, thump, slower still. The cosmic microwave background, faint radiation, filling all space, afterglow of the Big Bang, cooled now to 3 degrees above absolute zero, invisible to our eyes, but detected by radio telescopes, showing tiny variations, seeds that grew into galaxies, into clusters, into the cosmic web of structure we see today. The universe will continue, expanding, forever, probably. Current evidence suggests galaxies will drift apart, stars will burn out, black holes will evaporate. Eventually, the universe growing darker, colder, emptier, over trillions of years. But that's so far away, so unimaginably distant. Tonight, the stars still shine. For now, for us, the night sky remains beautiful, mysterious, infinite. Each clear night, an invitation to step outside, to look up, to remember. We're part of something vast, something ancient, something ongoing. The stars don't care. If we watch them, they'll shine, whether we notice or not. But we care. We look up. We wonder. We imagine. We calculate. We dream. This looking, this wondering, is part of what makes us to human consciousness, contemplating the cosmos. Let your body relax completely. Every muscle loose, heavy, sinking. On any clear night, even from a city, some stars break through. Sirius, brightest in the night sky. Vega, Capella, Arcturus, the Big Dipper, Orion's belt. Familiar patterns, reliable friends, unchanged for human history, barely changed for thousands of centuries. Under dark skies, the view transforms. The Milky Way emerges, a river of light. Structure appears, dark lanes, bright clouds. The sense of depth, of 3 dimensions, of floating in a galaxy, rather than looking at a flat dome overhead, lying on your back in darkness, watching stars. You can feel Earth's rotation, the stars, slowly, imperceptibly, sliding westward, the universe wheeling above, while you lie still, carried along by Earth's spin, by its orbit, by the galaxy's rotation, by the universe's expansion, moving, always moving, through space and time. Some people report feeling the overview effect, a sense of profound connection, seeing Earth from space, in their mind's eye, small, fragile, beautiful, alone, in the vast dark, yet teeming with life, the only such place we know, the only home we've ever known, the pale blue dot, as Voyager saw Earth from beyond Neptune, a pixel, barely visible, suspended in a sunbeam. Everything we've ever known, everyone we've ever loved, every civilization, every triumph, every tragedy, on that speck. Carl Sagan's words echo across decades. A call to cherish, to protect our tiny world. Your breath barely moving now, in, out, like tides, like winds, like the slow drift of continents. Stargazing connects us to ancestors who watched the same stars, wondered the same questions, told different stories, but felt the same awe. Thousands of years ago, someone looked at Orion and wondered, what is light? How far? How many? In the future, people will look up and see mostly the same stars. The sky changes slowly, very slowly. Barnard's star, moving fastest, crossing the sky, 10,000 years to move, half a moon width. The constellations our descendants will see, nearly identical for millennia to come. But eventually, hundreds of thousands of years, the patterns shift. Stars drift, constellations dissolve, new patterns form. The Big Dipper's handle will bend, break, scatter. Nothing lasts forever, not even the seemingly eternal stars, except, in another sense, they do last. The atoms they create through fusion spread through supernovae, seeding space with heavy elements. These elements form new stars, new planets, new life, us. We are literally made of stars, not metaphor, but fact. Every atom, heavier than hydrogen, forged in stellar cores or in supernova explosions. The calcium in your bones, the iron in your blood, the carbon in your cells, all created in stars that died billions of years ago. You are ancient, cosmically ancient, even if your body is young, heavier, letting go. Light pollution robs us of this connection. The Milky Way, invisible to 2/3 of humanity. Children growing up, never seeing a truly dark sky, never experiencing that vastness, that perspective, that sense of place in the universe. But it can return. Turn off lights, shield others, let the darkness come back. The stars are still there, always there, waiting to be seen, waiting to remind us what we're part of, where we came from, how small, how precious we are. Some nights, clouds cover everything. No stars visible, just grey or black, featureless. But even then, above the clouds, the stars shine, the galaxy turns, the universe expands, oblivious to weather, to clouds, to our temporary blindness. Other nights, crystal clear, no moon, no clouds, stars, beyond counting, the Milky Way, overwhelming. You can get lost in that view, lose track of time, lose yourself in wonder. Let yourself drift away now, completely. Nothing to hold, nothing to do, just floating in darkness, in warmth, in safety, while above, beyond, the universe continues its ancient dance, its slow, patient unfolding. Thump, 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 slower. The International Space Station passes over several times per night, sometimes bright, steady, moving, faster than any plane. It's people up there, humans, orbiting, seeing 16 sunrises per day, looking down at the curved horizon, the thin blue line of atmosphere, experiencing the overview effect firsthand. Satellites, dozens, hundreds, visible on any clear night, now streaking silently across the stars. New constellations, artificial, Starlink, other mega constellations, thousands more coming. Some see this as progress, connectivity, others as pollution, intrusion into the natural sky. The night sky changing in our lifetime, becoming less wild, more crowded. But beyond the satellites, beyond Earth orbit, the natural sky remains. The planets still wander, the stars still shine, the galaxies are still spiral, unaffected, used by our activity. Down here, the cosmos continues, indifferent, magnificent. Imagine a civilization on a planet around another star, looking up at their sky, seeing different constellations, different patterns, maybe no moon or 3 moons, maybe in a binary star system, 2 suns, never experiencing true night, or maybe deep within a globular cluster, sky ablaze with thousands of close, bright stars, never seeing the darkness we experience, or maybe on a planet at the galactic edge, looking out at the universe, seeing galaxies stretching away into deep space. No Milky Way obscuring the view, just clear, dark sky filled with distant islands of stars, every world a different sky, different view, different perspective on the cosmos, but the same physics, the same atoms, the same fundamental reality, binding everything together. Your thoughts fading now, dissolving, words losing meaning, just sensation, just weight, warmth, darkness, breath, the night sky, above you, always above you. Even when invisible, it's there. Stars, shining, galaxies, turning, light, travelling, and you, here, now, part of it all, connected through gravity, through atoms, through light, one small consciousness in a vast, unconscious universe. But consciousness matters. Awareness matters. The universe can be appreciated, understood, loved, because we exist, because you exist here, breathing, thinking, feeling, slowly slipping into sleep. The stars will still be there when you wake, different ones, risen, others set, the wheel continuing is to turn, the cosmos, patient, eternal, while you rest, while you dream. Thump, thump, thump. Let it all go now. All the facts, all the numbers, all the names. Let them wash over you, like starlight, like darkness, not needing to remember, just feeling the immensity, the beauty, the mystery, the peace of being small, insignificant, yet here, aware, alive. You're breathing, automatic now, body taking over, mind drifting, floating, away, like a planet in its orbit, like a star in the galaxy. You're part of the motion, the flow, the great turning of everything. Sleep comes gently, softly, like nightfall, creeping across the earth, shadow, spreading, bringing rest, bringing dreams, bringing quiet. The universe doesn't need you to watch it. It continues regardless, but you watched. You looked up, you wondered, and in that moment, the universe became aware of itself through you. Now, rest. Let the cosmos continue. Without your gaze, it will be there tomorrow night and the next, and the next, waiting, shining, turning, eternal. Your eyes closed now, or closing. Body completely relaxed, heavy, held by gravity, by earth, by the mattress. Safe, warm, still. The night sky above, the stars, distant, the light, ancient, everything continuing, while you drift deeper into sleep, into dreams, into darkness. Thump, thump, breathing, shallow, slow, consciousness, fading, words, becoming, sounds, meaning, dissolving, just the rhythm, the flow, the gentle pull, downward, inward, into rest. 100 mysteries woven together, one long story of light and darkness and distance and time, all flowing together like the Milky Way across the sky, like your thoughts across the edge of sleep. Nothing to remember, nothing to do, just being, just breathing, just fading away into the soft, the quiet, the deep, the stars above, the darkness around, the universe vast, and you, small, safe, sleeping, held by earth, surrounded by space, part of everything. Let go completely, drift away into sleep, into dreams, into the endless, patient dark. The night holds you, the sky watches, the cosmos continues, and you rest, you sleep, you to dream. Thump, your heartbeat slowing, matching the pulse of distant neutron stars, spinning in space, everything connected, everything. One sleep now, just sleep. The universe keeps turning, the night sky whispering its oldest stories, and we'll keep drifting, floating together through the mysteries. 100 night sky mysteries, looping softly, endlessly through the night. Tonight we'll drift through the slow procession of the stars above ancient skies. Why the Milky Way seems to breathe across the seasons. How faint light travels for billions of years to reach your eyes.